Hi there, welcome to DApp Mentors. I am Darlington Gospel, and we have a lot of things to do today. I think this is going to be our last build for the year, so I just want to make this very special, and it's a very special build to me. This is us going to be building um, a Solana DApp, but not just Solana, but has AI embedded. So we have Solana AI, LLM, MCP server. So you're going to have all those technologies that are buzzing around in one build. So we're building a payroll-based system for decentralized environment where a user can create an organization and add workers to that organizations and pay them. But what we're going to do in this particular build is we're going to remove all those buttons away. We're going to let it go. And then the AI will be the one running the application for us. All we just need to do is to give a command, like an instruction. Hey, create this. Can you create an organization named Tesla for me? And to just create it for you and prompt you to enter to authorize the transaction. You can use it to query the blockchain. Say, hey, how many organizations do I have? How many workers do I have in this specific organization? Can you fund this organization with certain amount of money? Can you withdraw from this organization? Can you calculate the entire amount of money that it will take to pay a certain number of workers in a particular organization? Can you check if this organization's payment cycle is due? So all of those things will happen with the use of LLM. We're using OpenAI in this particular build. It's an amazing build if you ask me, because I have been impressed myself. So if that is actually going to be a weight on your decision making process, that should be it. So it's great build today. I think this is one of the best build for the entire year. So I need you to be very part of it. You're going to be amazing because we're using also you're going to be amazed because we're also using the latest of Next.js and the MCP capability of Next.js is in React 19. All of those things are going to be part of this build, and an amazing interface as well. Everything that I'm saying is already on this build. So please, if you have not subscribed to this channel, now I plead with you, hit that like and subscribe button, click that notification bell, and let's get into the build. All right, please check out our store. We have courses, we have services that you can get in touch with us. We build stuff for people, we build stuff for clients. We also do quite a lot of things. We have Web3 classes, we have so many things that you should check out our website to get yourself acquainted with. So with that further statement, let's jump into the tutorial. All right, welcome. So in this particular session, my goal is to introduce you into what we're trying to build for today. So we're building an AI-powered payroll DApp on Solana. So it's going to be fantastic. It has so many modern ingredients to it, and this is one of the best examples that you ever find on YouTube for free. So this is the DApp that we're building. An AI-powered payroll system on Solana where you literally type something like pay the dev team their salary and it just works for you. There's not too much talk about it. It's fully going to be on chain. Payroll logics are going to be fully on chain. It's going to use natural language for automated, or for payments. All right. And it's going to use zero trust, which means transparency, and this is built for DAOs, decentralized autonomous organizations, startups, remote teams, and even for legacy uh, payroll systems when they actually want to migrate to the new world. All right. So those are the people that this project is for, and of course you as well, for anyone that want to build this, and for all those that would like to use this for their um their school projects. Okay, I've had a few people um find interest in using this project, the idea of this project for their final year project in universities, postgraduates. So it's pretty fantastic idea. Um, so these are the things that you need to have ready for this project. Basic TypeScripts as JavaScript, which is, if you know React, that just solves it for you. Some React as Next.js experience, like we're saying, some basic blockchain help, skills. It's gonna help, but it's not super required. You know, you're gonna need Node.js, npm/yarn, package management. Gonna need Rust, Anchor, and Cargo, all of those things, Solana, CLI installation, you're gonna have them ready. We're gonna be using VS Code. Please, I recommend that so you'll be on the same page with me. I'm gonna be using Phantom Wallet, since we're developing, but in production, I think MetaMask now takes care of Solana as well. So those are the things that you need to have ready for this particular build. you know so this is just this is not about another to do app, blockchain app. This is actually going to be solving a real life problem, a crypto problem, right? So uh, for DAOs and remote teams, this is going to show a global payment. For token project, you can, this is going to be cool, if you're actually, distributing some certain kinds of tokens or funds, right? For startup, you don't need to have PayPal or Stripes anymore, have all those fees. All you just need is your workers um, wallet address, and there you go. It just does the job for you. So this is for the future of work, all right? So that is how this project is about. It's really cool. We're going to see it in action soon. So these are the stacks that constitute this particular project. The stacks we include Next.js. For the front end, we are actually using the latest version of Next.js, and there's a reason for that. So while I was building this, there was an aspect of the project that has to do with MCP. And in Python, it's really cool. It's straightforward. I've done this already on Python, and it's easy to just use fast MCP on Python to structure your MCP server. But in JavaScript, there used to be like a specific package that helps you to organize that. But the latest version of Next.js does comes with an MCP enablement, which you're going to see later on in the course of this of us building the application. It's the same thing. It's the same way where you have API development can happen with Python. I mean with Next.js, but at the same time now we can have MCP server built with Next.js, and you don't need a special kind of package to do that. So it really straightened my job, made it a lot easier for me to develop along, and there is not such a breaking changes between how Next.js normally function and how it is. So totally, amazing. So addition to the Next.js package, that's why I like it. So we have blockchain. For the blockchain, we're going to be using Solana, and for smart contract, we're going to be using Anchor, which is based on Rust. It's basically Rust. So Rust is Solana is fast, cheap, and sort of developer friendly. I'm not going to say that is as friendly as a Solidity on Ethereum. So for AI, we're going to be using OpenAI. Now, this is OpenAI. It's cool and very suiting for what I'm doing. But of course, you can also use tweak it a little bit to use any other LLM, such as Cloud or Me Cloud. Amongst all of these LLM for coding and all of that, I know from experience, not by of course, I must give a caveat that I have not used Grok during LLM integration. So Grok has always been something I use from the X platform or the official Grok platform. But for function calling, which is very important when you're dealing with MCP, function calling, aka tool calling, is very important that an LLM has it. So OpenAI is great at it, but I must say that cloud is greater. Cloud Anthropic, cloud from Anthropic is better at it, but there is no issue with what I've done. You can also try what's it called, Gemini. Gemini, from Google is also good as well. So those are the things you need to be aware of. Need Next.js, OpenAI, okay, and then that is for AI, and it will just stream English, natural language, and convert it into on-chain instruction to execute. And we're also going to be using this wallet, this Phantom wallet. Solana adapter is very important for development purposes, because it will help us during the development phase, where we'll have our own blockchain running on the background. So that helps us a lot. That's why I'm insisting on Phantom. All right, so there we go. Next, you need to know this is a high-level architecture design for our system. So a user comes in and interact with the front end. Front end is built with Next.js, and there is an aspect called chat panel, which is the dashboard. This is where the user interacts with the system. Each question or each interaction with the payroll system, is executed by OpenAI's, OpenAI's LLM, all right, which is ChatGPT or GPT-5, sorry, and GPT-4 actually, that's what we're using. And then from GPT-4, it translates whatever natural language that was communicated and evaluate if it has to invoke a function or call it a tool or not. If it doesn't have to, then it will not. But if it has to, then it will execute and call a tool, one of the tools in that we have available. And if it's a read request, it won't involve Phantom Wallet. Okay, Phantom Wallet doesn't need a read request, doesn't involve read request. So, but if it's a write request, that means if you're carrying out a transaction, if you're writing to the blockchain, then it's going to be invoking this wallet, which is really cool. And then lastly, then it will communicate to the blockchain and return the feedback to the user. Now, this is really cool. OpenAI is 100% client side, meaning no server is involved and no key are exposed. So basically, this application, the only server side is in the blockchain. The OpenAI is communicated from, their provision. So the only thing we're going to be working on that we host ourselves will be the Next.js front end. I'm going to show you the live demo now, which is the next thing that we're going to do. I'll see you in the next part of this video. So currently, this is the application. It's hosted online. So this is the URL where it's hosted. Took a lot of time to build a very interesting UI. Has all this beautiful interface to read. And check out the documentation. It's well documented, so it's easy for you to install or interact with. Right, so very clean UI. And check out Playground, which is where you can test out the smart contract. Maybe you want to deal with the buttons yourself, click on all these things yourself, because we will not be clicking on any one of these buttons. We're going to be using LLM to handle all of that for us. You can know more about the features. You also know more about us. So pretty cool. Now, that is for the UI. Beautiful. Now we need to connect. Make sure that you have Phantom wallet there. I have MetaMask, Brave wallet, and Phantom. I'm going to connect with Phantom. I've already connected with this. So you can see here, I've already created one organization, which is called Tesla. Now, because this is online and a lot of people are visiting it, I've decided not to put my OpenAI key for others to consume my token. So if you're going to be testing this yourself online, that means you have to add your own OpenAI key here. And the good thing is that it is not going to be saved on any place. It's not saved on our backend or on your browser either. It's just going to be available for you to interact at the current arrangement. But once you close this browser or you just refresh, you will need to enter it again. So I'm just going to take a moment to grab my key. Okay, so now I do have my key, because with that key, I can interact with the system. You understand what it's saying here? I need to set my key first, and that's good. I have some organization. I could just ask a simple question like, how many orgs do I have on my account? Okay, isn't this beautiful? You can see that it has only one organization, which is okay. And you can even check it out here. This organization doesn't have any funding yet. So if I say, can we fund that with 2 Solana tokens? And let's see that. This you see the way it triggers my Phantom wallet, and then I have to enter my details, and this is 2 Solana token. You can clearly see how this is going, and then execute that. Once it is successful, it's just going to deposit, update this automatically for you. You see the way we're doing refresh any page, everything just works, and it gives you the transaction ID, which we can check out for ourselves in Solana Explorer. This is really cool. You see how the AI is the one working it out for us. So I'm going to shift this to DevNet, and then make sure that I paste the transaction ID. And let's see what goes on happen there. You can see that there was 2 Solana token that was carried out here. This is what I have balanced in my account. So this is cool. All right. What else can we do? Let's create another organization. Let's say create a new org of Amazon. Let's see that. Then let's you can see that it just automatically created it for us, and this is the transaction signature. Basically, you can visit this, but I think you're gonna have to. I didn't work on it to determine which chain I'm currently working on. As you can see, this is now the organization that has just been added, which is really cool. There's something I want to do. I want to add some workers to this organization, because currently you can see there are no workers here, 0. So let's bring in some workers. I'm gonna do this momentarily. Okay, I'm gonna copy this dev too. Okay. I'm also gonna copy this other dev, this dev tree. And let me copy one more worker, this dev 4. I want to say, can you add these workers to the Tesla org, which is organization, and key them at, let's see, the amount that they are going to be taking 0.3 Solana token each as their payment. And let's click on send. Okay, so I'm going to confirm that. I'm going to confirm this again. I'm going to confirm this. So basically, it executed it for those 3 workers, at the goal. Okay, so this is the idea. You see that it added 3 workers here. You can see each one of the transactions that took place here, and all of those workers have been added in that particular group. So this is good. So now let's do the ultimate test to figure it out. So let's see the Tesla org workers, and then let's click execute. Let's see that in action. Now it's the confirm. Fantastic, it succeeded. So let's check out this transaction. Of course, this transaction is going to be pointing to the mainnet, which is not correct. I'm going to toggle it to the devnet. You can see that in the devnet here, you can see what happened here. So you can see that these are the accounts that got paid. This got paid, this got paid, and this got paid. Each one of them got paid around 0.3 Solana token each. So they received their payment, and that was all executed by an AI. I didn't have to do anything. You can see the remaining balance in that particular treasury. I want to withdraw these 1 Solana token from this Tesla org. So I can say from Tesla withdraw 1 Solana token. Let's execute that, and you approve, and before you see how this just increased your Solana token here. So that's pretty cool. You can see that transaction was successful. You can see that this was debited as well. Very interesting concept altogether, which is cool. So all of these are happening, using an AI. All right. This is what it is. All right. This is what it is, and this is what you're going to be building, and you understand how this is done from the Solana contract down to the MCP. Everything have taken a lot of time to package together. You're going to get it all together absolutely for free here on YouTube. So with that said, let's don't talk too much. Let's jump into the tutorial. I'll see you next. Okay, so we're going to have to start installing and setting up the environment so that we can start our development process. So I'm going to place a link to this repository so that you can download it yourself. And once you download it, basically all I needed to do is to come here. It's currently private, but at the time that this will be released, it's going to be public. So you need to come to this starter. This is starter direct branch. Okay, this is where you need to work from. So I want to say, okay, you want to download this branch, but okay, you want just clone it. You want to clone the project. All right, so you copy that URL. You come to your application. Make sure you go to location where you often have all your project, and then you clone it. Say git clone. I'm going to call this, paste this, not only that, and then you give the name of the directory, DApp pay course. All right, and it's going to clone it into that directory. And then I'm going to open this, course. I'm going to open it in VS Code. Okay, there we go. Fantastic. All right, so there's a lot of things to be done here. Make sure first you are going to be switching to the what's it called? I'm going to bump this a little bit, and then you make sure you switch to the data branch. But I'm going to allow this to just load completely. Okay, so you switch to this data branch. There you go. It's a lot simple, and this is where we're going to start from. In order to install these packages, because look at this, I have Next.js. These are the packages that we're going to be using. I've made sure that in the Anchor folder, I'm going to come to that. So basically, this is all we're going to be doing. At this point, I want to first make sure that I remove the Git repos, the Git directory, because I don't want to update the application using whatever I'm doing here. So I'm going to say remove -rf .git, right? So that will remove the GitHub, thing. All right. So these are the packages that we're going to be installing. This Coral Anchor is very important, and these versions are very important. Please, please, please don't try to be smarter and go download your own version. It would be very frustrating for you. Okay. So just make use of all these versions that I have here, and you'll be fine. Right. So we're going to install this part. There's also another part we're going to install. Look at this package.json here. We also need to install these ones as well in that particular folder. So we have two folders that we need to work on. Not only that, you can install this thing if you don't have Solana packages installed. That's why you need this. So if you are for Windows, you install for your Windows. For Solana, install for Solana. So this is just this. For Linux, sorry. For Mac users, normally like this, you just copy this and you execute it on your terminal, and all of those things will be available. Like currently, I have all that installed. Okay, so these are the various packages that should be available after you've run this installation. So that's what it is. And of course, for you to verify, you can just copy all this and just paste it here on the terminal. And you can see all of them. They are available. I don't have this soft tool because I don't think it's very important to what I'm doing. So if you're on the same page with me, that is fantastic. Then we can jump into this application. The first thing we want to do, let's install this package for Anchor. We want to go cd. Right now, you should know that I don't have any package. This is the only thing, just a hello program, okay? A hello world program. So there is nothing here. I'm just going to install this package. We're going to sit into that Anchor folder and do yarn install, and it's going to take care of it for you. And so the installation for the Anchor packages is done. Now I want to test out that everything is working by running this command, do Anchor build. Okay, so basically it's going to compile this little program here, and that's just it. No big issues. Okay, so that installation is complete. So we've not really coded anything. Basically, we're just having everything running smoothly. And the next thing we want to do is to cd back a step and also install this one here. So need to install it by saying install and wait for it. Okay, so the front end is also installed. There is one more step, a couple of things we need to do to make sure that we are in good condition. We want to do Solana config get. So this will show you the exact network that your computer is currently configured for. If you look right now, that this is configured for the DevNet. Okay, so all our development right now, we want to shift it to to local net. All right. So, and if you check your balance by running Solana balance, so you can see how much that account has. So we want to toggle this to local net because we're going to be doing developing on local net for now. Say Solana config set a URL, say local net. We're going to do it this way instead. Say HTTP local host and give it that specific Solana port, which is 8899. You see that it's toggled to localhost now. So that's good. It's very important that you have that. If I do config C, it's now on that local net. If I try to check my balance, because the local net configuration, that is the local blockchain, is not up and running, so is producing this issue. Okay, so the good thing is that during your installation of Solana, if I do Solana dash version, we have Solana here, then that automatically also got us the Solana validator. Okay, so I'm going to start that validator, test validator. Basically, it's a local blockchain. All right. So that local blockchain, you can spin it up so that when you spin it up, I will do Solana dash test dash validator. Say dash reset, that can clean up some things, and then you spin it up and see the local validator is up and running. Now, if I run that command before Solana balance, find that I have over how many? It's about 5 million or thereabout Solana token. This is good. So we're setting up all these things. At this point, you can then run yarn dev. Okay. And let's go to localhost. So here we go, localhost. Everything is just, all these are dummy organization. There is nothing working here. So we just have the front end, the scaffold. I'm going to disconnect here. So you just have only the scaffold, ability to connect wallet. You can view the playground, but really nothing. There's no smart contract to power it. All of this just front end code only. So, which is good. Now, in the next part of this video, we will then start developing the application step by step. I feel like before we even, get to the other part, finish up the rest of this, I would like to explain some certain code structure for you, because I was doing that. So basically, I kind of have gone far, but this application constitutes front end and this anchor application, which is the Solana application. So in the front end, you're going to have these essential files. But one of the things that you need to take note of outside of these packages that has been installed, you see this package called, Anchor is going to be important if you're going to be interacting with the Solana application. This is Tailwind, these are some test packages, and these are Solana UI packages, and this is Solana Web3 interactive package. This AI is very important. It's going to be useful for interacting, for the UI, that AI, this UI here. If I should connect my wallet. Okay, so this UI was built around this particular AI package. So that's why it's very important to us. This is for icons, and this is Next.js latest version of version, which is version 16. Very important. React 19, of course, and we're also using React Markdown. That's why we have this beautiful, beautiful interface. Okay, so that is very important. What else we're gonna do here? Great. So this is utility function. Basically, these are gonna be various interfaces. It's nothing too crazy about it, but these interfaces are gonna make sense to you because we're deriving them from our smart contract when we're gonna be coding them. This is public folder. You just leave it as it is. This is node module. Leave it as it is. And of course it has been ignored. So once we initialize Git again, it's gonna be tracking this node module. These are components. We have various components such as the chat component. That component is this UI here, which you have here. Okay, that is the chat component. We have client provider, which is a wrapper. Have the dashboard, which is basically the entire place here. We have the footer, the header, the home page, the organization panel, which is this component here. Okay, and we have particles, background. So those are for aesthetics to beautify the page. Now we have about page, dashboard, documentation feature, playground and privacy policy page. Those are the various pages that we have. The home page is also there, which is this main one here. And before we dive in, I want you to take note of this. This is the next.config.ts. Did you see this experiment here and how we enable MCP server? This is very, very important if you're going to make sure that your application will be MCP enabled. You want to make sure that you enable this MCP server to be true on the Next.js configuration. Very important. And this is why I didn't want to have you write this thing from scratch because it could be very confusing. But just follow it. This is battle tested. Already I've set up everything to be in alignment. This TS config is very important. You have it exactly this way. So you need to have it exactly this way. All right. There's also another one here, which complements this, but this is specifically for Anchor. Now for Anchor, this is the things going to need this migration. This is a script that will enable us to deploy smart contracts into any one of the networks that we want, that DevNet, mainnet, or local net. There's also testnet as well. It has its own node modules because we did an installation here. It's built with Rust, and Rust package manager is Cargo. So this is where you put all your programs. Your code is going to live here. This is the folder that will be very much that should be very much important to you. Also going to be doing tests as well. So when we finish writing that, we're going to run some tests so that everything will be all right. And then this target is automatically generated. You don't have any use for it. Just leave it alone. This also, we're going to leave it alone for now. All right. So other than that, we are good to go. So those are the various structure for this particular application. So I'm going to see in the next part of this video. So for now, I'm going to end this. We're not yet there for when we're going to be using it. So we're going to start by working on Anchor development for now. So I'm I'm going to guide you step by step. I'll try my best to make sure that everything is easy for you to follow. So these are the things that we're going to be doing in this project. This payroll program will allow you to do things like create organization or manage organizations, idea and the identity, because each organization belongs to a specific user. It's going to allow you to add workers to a specific salary or organization. I think I should just, do something like this so that you can see what I'm doing. So this is a project overview. So we're going to be able to create organizations, or organization to create account and manage the identity. So just understand that each thing you create using the smart contract is like an account in itself, because it's going to have its own PDA, which is program derived address. We're going to understand it the way Solidity Anchor works, or is different between in the way that Solidity works. So in Anchor, everything you create with a smart contract, every thing you create in the smart contract is a PDA, except for a transaction. A transaction has its own information. So if I'm creating an organization, that is an account. If I'm creating a worker, is an account itself as well. So an organization is going to have workers in them, and we can also specify their salaries within that organization. So we're going to be able to fund an organization. We're going to be able to process batch payment to multiple workers, and which is make the batch payment at once, and all the workers that belongs to that particular organization, they get paid. We're going to have ability to withdraw the remaining funds from the treasury if we wish. So those are the various things that we're going to be covering in this development process. So let me open this anchor.toml package. I'm just going to explain it for you. So this is your project main configuration file. We're going to keep the default structure. It defines your programs, deployment settings, and registry information. So that is what this does. If we need to change anything about it, we'll come back to it. But for now, just leave it as it is. Okay. So right now you have this devnet, this program.devnet section, which is your program ID. This gets generated. We don't change it manually, but if we have to do that, okay. So we have providers as well, depending on where you want to push this. For example, we want to shift this to localnet, so we might just move it to localnet, since we are doing development on localnet for now. Okay, later on we can change it to, we can even duplicate here and have both localnet and that be available together. So this is just it in a nutshell. I don't want to spend much time there. And another thing I want you to know is this file called cargo.toml. This is dependency file. It manages all the Rust dependencies that we're going to be using. So the default setups include Anchor framework, which is using the Anchor framework, and okay, this is the one I'm supposed to be opening. So the default setting is the Anchor framework. It shows you which version of Anchor we're using. Okay, and everything you need for this tutorial. So that's just it. You wouldn't need to spend much time there, but just understand that those are the essential files we're going to be using. Now, what I want to do is to come all the way here. We're going to be working on developing this. I'm going to be working on developing this program step by step now. So this Lib File, we're going to just leave it as this for now. Or we'll come back to it and we'll work on it step by step. So the first thing I want to do is to create state. Okay, so let's create some states. So a state basically defines the data structure, all right? The data structure for a specific account, all right? When it comes to Anchor, you have to understand things such as states, accounts, instructions and all of that. So want to categorize them into folders so that it will be easy for us to understand. So we're going to say state dash organization dash dot rs, which is Rust. So want to define the structure of an organization. And for you to do that, you need to import Anchor language, which is where this comes in. When you import that, you need to bring in, this is how you define an organization. This is where everything is going to be in. So public structure, this is a structure, basically a struct. It's very popular amongst programming languages. Okay, so the first thing we want to do is to define the authority, which is the owner of this organization. We're going to say pub, authority. Authority is a public key. So, and this, represent the owner of this platform. I need you to be very attentive at this stage because this is where we need to be very diligent. Okay, we want to define the name of the organization. Okay, once the public name of this organization, and I want to make sure that it has max length of 100. So it shouldn't be more than 100 characters. That's what we're trying to say here. Okay, that's why we're putting this macro. Little thing here is called a macro. Okay, so we're putting that as an extra instruction around this name. All right, so the next thing we want to do is to also look at Treasury. Treasury is not a public key, is an unsigned integer, or in its of 64, what's it called, 64 bits, size, right? So what one Lamport is basically, one Solana token is equal to around 1 million Lamports. Okay, so that will be this size we're giving it will be able to hold the values of Solana digits. Okay, so total Solana in organization or each particular organization. Now the next thing I want to do, I want to define, I want to say workers count. This is going to help us to keep track of how many number of workers that we have in the platform. So worker count, I'm also going to give it 64 bits. Okay, so the total number of workers currently registered in that organization. Okay, if you follow these steps, it's going to be very clear for you. And we'll need one other this thing. We need this unit timestamp. This is created at the time that the organization was created. And lastly, we need one called bomb. So this bomb here is, bomb is a seed for the PDA derivation used internally by Anchor. So you're not going to be making use of it. You're not going to be touching it. Just keep it there. So these are the various items that mix for this particular organization. Now there are some things we want to add to this. We want to make sure that this organization is an account, we have to put this account in here, okay, which is a macro. And we want to also, so that is the way you tell, Anchor that this is an on-chain account, and also you want to put in this macro as well. This macro is called derive initial space, automatically calculate the space needed for serialization. Okay, so when when an organization is created, the size, the disk space that the size it will occupy in disk varies from each organization depending on the number of characters that was used in creating this organization, the number of workers that it does have, and all of that. So those things they factor in. So those when that is how we use in helping Solana to, or Anchor, to be aware of these changes or this information. Now we want to implement the organization, call it implement organization. Now this implement gives it some certain extra information or characteristics that are quite important. So for example, the max name length, okay, remember we had this, is 100 characters. Okay, so that's the maximum as an extra information. Now it's very important that we calculate the initial space. Remember this whole thing called initial space. Okay, so the wisdom for calculating is just going to be based on this. So we're going to say public const initial init underscore space is going to be almost this, but what we want is it's going to be 32 bits. Now this 32 bits is going to be the authority. I'm going to do this only once because in subsequent places we're just going to be using the same ideas, right? So this is the space for the authority, which is so the authority here is, I'm going to end it here. So authority, that is the space this public key is going to take, is 32 bit space. But of course there are other things that is going to also take. So I'm going to say plus 4 plus 100. Now this is the name string, okay, the name string with max character of 100. Very important that we have that. And then we want also the treasury is going to take an extra 8 bits. The worker count is going to take an extra 8 bit. The created part is going to take an extra 8 bit, and then the bomb is going to take 1 bit. So those are the things. So this is how we calculate the space that this is going to occupy on chain in bytes. All right. So I'm going to give you an extra information. So for example, calculated as 32, for 32 bytes for public key plus 104 bytes for the string, the name string, and then these other ones added together, it equal to around 161 bytes. That is what an organization will be taking. That space is going to be taken on chain. That's fantastic. So how about we also do for workers, because this is only for organization. If we're going to do for workers, we'll create another one called worker dot trust. And of course, remember, I'm going to just be doing this a lot faster than before because I've already explained all this how it works, right? So the remember before we had something like, you know, if you look here, we had something like the authority, because an organization is owned by is a person, you understand, and that person is the authority. But a worker is owned by an organization, so that's the difference that we must take note here. But it's still on similar, ideology. And then we need the worker's public key. Okay, so where this is where the worker is going to be receiving their payment. All right. We also need the salary. This is how much the worker is going to be earning in each cycle of payment that is made, which will be stored in Lamport. All right, and the timestamp of the last paid cycle. So the last time that payment was made to this account or to that worker. So this is where it's going to be stored, right? So prevent paying the same worker twice in the same cycle, all right? And the time and the bump, the created at, and the bump, which is just similar to what we did here as well. So I will take a note of when this worker was added to this organization. All right. So that is it for that state. And we want to also have a worker implementation. So I'm just going to copy and paste this, make it a lot easier. So for this, unlike here where we need a max length, we don't have anything like need for max length when it comes to workers. So we just calculate total space, the account we occupy on chain in byte, which is by this same calculation for org. This is a organization public key. Okay, remember here, this is org key, and the workers public key, which is another 32 kilobyte, because this and this are of the same size. Sorry, this and this are of the same size. And then you have the salary, the last time it was paid, the created at, and the bump. So those records are important. Now, once you do all this, we want to bundle this into what we call a module. All right. So inside here, we're going to create a new file here, call it mod.rs. So that's how we will bundle it. So we want to make, how we make a module is by saying public mod, and then the name of that file, which is, for example, organization. And then you then export that organization by saying use, right, organization. But you want to make sure that everything inside is usable. So this is what we're doing here. So I'm going to do that for the both, which include the worker and the organization, making it accessible or re-export all public items for convenience. So very, very important. And one more thing I want to do, okay, is I want to create another module. This is going to be for errors, handling of errors. So I'm going to create a new file inside a new folder called errors modules. So remember the drill, there's a drill. You want to use anchor, and these payroll errors are going to be enumerable. So it's not a struct. Enum is also another data structure, a data structure as well, just like with struct, to help you to develop a structured error sequence that will be available for our application. So for example, and to instruct Anchor that this is an error code that it will be represented here, you need to use this macro called error underscore code. It creates an error in enum for the program. So what are the various errors that we're going to be dealing with? Okay, so this is how, first of all, we want an error code called unauthorized. Now, this unauthorized, we need to decorate it with another macro called this is another macro here. So we decorate it with another macro. So this macro is say unauthorized access. This is the message that will be produced, and it's very important that we have those messages so that we can be able to detect errors. Okay, but we're just structuring them. So I'm going to add the rest of these messages. They are just a little bit more. So I'm going to put them here and explain one after the other. So this is invalid name. So this error happens when the organization name is too long or exceed the max length, which is supposed to be 100. So, and this is invalid salary. So error is executed when the salary is 0 or invalid. So this is invalid amount when the amount parameter is 0. So it's invalid amount. This amount, okay, we're going to see how it's being used later on. We're going to also have insufficient fund. Error treasury, doesn't have enough. And this is, for example, you want to pay workers, but the treasury doesn't have enough fund, then this error is going to be useful. Then we have missing worker account. So if you're trying to create a worker and you didn't put the wallet address, so that should indicate that the worker account is missing. And this is invalid worker PD. So when the provided worker PD doesn't match expected, so it means that when the wallet address of that worker that you're trying to add to this organization is not a valid Solana PD, then it's going to produce this error. And then we have another one, invalid worker wallet. So error when worker wallet public key is invalid. So these are just various ways we can express an error in our application. So in the next part of this video, I'm going to dive into some instructions. Now we've created states, created error, so we need to create instructions. So the instructions, basically the logic, the idea, the manipulations, the operations that we take place first before a worker or an organization is created. So I'll see you in the next part of this video. So now we're going to be dealing with creating instructions, and I would like you to think about instructions as functions, because each one of these instructions are going to be performing a specific task. So let's jump in. The first instruction we want to create here, I'm going to call it create org. Instruction / create org.rust. So, all right. What we're going to be needing to create an instruction, of course, you know how the drill goes. So we're going to need this anchor preload. So those are the basic things that the framework will require. And we're going to create a function. So say public, okay, public fn is for function create _org, and basically something like this. Okay, we need context and result. I'm gonna try, remove all this, you know. Okay, so create org used context is very important that it should be there. We have this create org, and this create org basically we provide some some extra details to that function, such as um, just a lot of extra details, such as the caller of this function will be captured by this CTX. So many other thing, and then it has to return a result, and that is where we have this that okay. All right, so that okay. And so for you to create an organization, you need two things. You need a name. Basically, that's all you need. Then this one will be dynamically, supplied. Right. So let's jump in. So we can call this the main function, main handler function for creating an organization. And if you're going to create an organization, we want to perform validation. If you actually followed me before in what's it called? If you actually followed my Solidity tutorials that I've been doing before, this should be very easy for you to understand. So you have this now. Require, what am I requiring that this function should have? This is validation. I want to validate that the organization, the name of the organization must match the max length that we associated. And of course, you want to make sure that you use these the crowd on column state, and you want to import organization. All right, so that is very important because we're using it here. Then within that state we can access this property here, which is what would define this property here, or in this implementation method. So it just gives those contexts so we can know the max name length. And then this payroll, we also need to use access the errors from that error log that we have here. And once we access it, then we're looking for, come back here, what you're looking for is this invalid name. So we are accessing this invalid name enum. All right, so that will help us to validate that the name is okay, so we can proceed to doing other stuff. So there's this whole thing about mutable references, and immutable references. Okay, mutable references, they're just talking about a variable state that can be changed, and immutable references are variables that cannot be changed. So the mutable and immutable, they should give us the clue. So we want to say how we get the, let's say, an org now is equal to this. I'm gonna come back here so that you can see what is going on. So in this CTX, you can have access to one of the variables or provisions called account, and then you can have access to not this org but this org. Okay, so account.org, and that will give you the organizations, basically the PD. All right, now that is a mutable reference. You see the way we specify this mut, that's for mutable, but this ampersand here is talking about a referencing to another variable, which is basically this is the variable where we are referring to it. So when we refer it, we can store it here, but the main account is actually here. I don't know if you understand that, but just If you don't understand it, just know that we're just grabbing the specific account to this organization that we're creating. And for this organization, there's something called .authority. Okay. Remember here, if you come here, we have organization has authority. So an account has been created which is based on this state. So want to assign it an authority. So the authority is going to be this organization, this CTX, okay, and then colon account, and then you want to access the account, the authority in that account. That means the one that created this particular organization, and then assign it as the authority here. All right, so that is what you want to do, and you can call that. Basically, this authority is the signer. So you can say set the authority, which is the owner, to the transaction signer. The signer is the person that authorized that, that transaction. So you want to store the name of the organization, but I want to just call on this .clone method. All right. So basically, clone makes a copy. It gives it a copy of it instead of the main. And then the treasury, we want to give it an empty treasury for a start. All right. And then worker count also should be 0 by default. And we want to set the timestamp. How you set the timestamp is very simple. It's like this. So we have this org.created at is equal to this clock module, which comes with Rust and Anchor framework. You're getting the Unix timestamp, okay, and assigning it to this created at. All right, and then the bump. Now the bump, is gonna be coming from this context. It's not coming from this one here, but this context right here. So that is how you assign the bump, right? And then lastly, before you complete, you conclude, you want to give a message, okay? It's more like a logger, a message that will be seen in the whenever Solana, when you check on I don't know if I could find that here. So oh my, I don't have a specific transaction to track here. Otherwise, I will show you. Let me see if I can trace that. Let's check this one, transaction history. No. Let's just leave it alone. Okay. Let's check this transaction record. You can see this is the log, program log. You can see instruction idea. So these are kind of logs that we're talking about here by doing this here. So we're going to say organization created, and this is going to be interpolated here later on. All right, so that's not all there is about that function. There are some context we need to create about that function. One of the things about a function in this anchor, a function also must have a context. Okay, it must have a context. In fact, you shouldn't create a function first without the context, because this is wrong. I'm going to work on it, because when you create the function first, you won't get the context correctly. That's why we went getting some vital information then. So I need to create a context first before we create the function henceforth. So to create a context, we're going to put it at the bottom. Okay. So, and you need to signify this by saying this info, okay, and a single quote here before it. So basically a structure, but it will give define all that the account needs for this instruction. So all that this organization account needs for this instruction is going to be defined here. So the organization. So let's create one of these, and let me show you how it works. So come here and say this is how you create the account. You say account, all right. This account, this is how the organization's account is going to be. You're going to have init, payer, space, and all of that. I'm going to define them for you and bump. All right. So then this is just the decoration, of this actual account here. All right. So this is what is decorating, is giving extra context to this account that we created called org. You get it? So it is in this org now that it makes sense when we are referencing when we're calling this context dot account dot org. You see, this context, it should now be coming from this. Okay, so you have create org context, so it's going to be referencing here. So this org here, that's what this org is, and it's under this account. Okay, so it's an account. I hope you're getting it. Now for this account, there are some things you need to know, and I'm going to explain them one after the other. So let me put this comment. The organization must be created. The organization's account must be created. So the init here that you see marks this as an account initialization. So that is how you initialize an account. And payer specifies who pays for the account creation. Basically, this is the signer. So that equals the authority. You have space is talking about the allocated space according to the organization init space, which was defined before around 161 bytes. So we call on that organization, and then that init space, which is this actually. All right. So, and this seed has a way we manipulate it. This is how the PDA, how we derive the PDA, which is the program derived address from authority, public key, and organization's name. But that is not the only thing we want. This is org authority dot key, and you call it dot asref, and then also the name of this organization as byte. So this is what you use in forming the seed. So each particular account, organization that is created is going to be always different. Okay, it's going to be different. Okay, and this seed needs to be deterministic. All right, deterministic in the sense that I can regenerate this by supplying all this information. And you're going to see this later when we're testing the smart contract, that this, you need to put something that it is both unique and at the same time you can regenerate it. All right. And then the bump. All right. So the bump is talking about, stores the bump value for reproducible PDA generation. So this is important if you're going to be reproducing this PDA later on. So those are the essential things that we must take note of first. All right, so that is one of the contexts that we want to set for this account. We want, that is an account set, but we want another one called public. We can call this authority. Authority is going to be a signer, and this is how you set up a signer. This is the context. A signer is also an account. All right, it's also an account, but it's a mutable account. Okay, so that's just whom an authority is. All right, and you indicate it by this signer. All right, so here this is an account, this is a signer. They are two different things. And I think we can give it some extra information to help us understand. So the transaction signer must be the authority. Mute allows modification of account needed to deduct rent. Okay, and rent is basically the space that your smart contract is occupying on the Solana blockchain. That's what the rent is talking about here. And lastly, this is very important. This is called public system program. Now, system program is going to be using this program info. So this is important. This system program will be responsible for this system, this account creation. So it's basically a program that is responsible for creating the account as specified, in this context. So now it makes sense that when you call cts.account.org, I don't think Rust is giving me that drop down, all those things that I needed. Okay, so this is it. This is how you create an instruction. This instruction just simply create an organization for you, and the organization is creating is based on this context. Okay, context is that you need an account for the organization, and we need a signer who is going to be the authority of that organization, and then a system program which is going to create this account for us. So those are the things that you need in that part. So in the next part of this video, I'm just going to also create the other instructions. I have like add workers and all that instruction. We'll create all those instructions, then we bring them all together before we go about testing them. I'll see in the next part of this video. Okay, so for now I'm going to close some things so that I have a more open space. Okay, so in this instruction I'm going to create a new one called add worker.rust, and this is what we're going to do. We're going to come here. Let's create a context for it first. Remember what I said. All right, make sure that you bring in this. Very important. I'm going to bring in this. All right, this is for anchor. Okay, so what do we need in order to create an organization? We need this add worker context, and we need to create an account first. The name of the account is going to be called organization. So we need an organization because if you think about it, a worker belongs to an organization. So I'm going to bring it up here. Sorry, I'm getting it from the wrong place. Down below here. Okay, so we need to just grab this, bring in here. Now when you bring this in here, we're going to make some few changes. Okay, first of all, we're not just going to remember in this create org, we are grabbing the name here. Okay, so the name just being passed straight up in from the content from this place, but here we're going to access the name of the organization by first of all getting the organization. So this is important. We're going to see how this plays out as we go for now. And this bomb, you're going to be getting it from this organization.bomb. All right, so we don't need a payer here. I don't need to initialize because we are not initializing anything. We're not doing anything like space either. Okay, and this is mutable. Okay, and this is going to be called our seed, has one, sorry, and I'm gonna say authority at payroll. So let me just bring it in here, and I'm gonna explain this for you. Just hold on. So this is all happening. I'm gonna bring in this error, and I need that. Let's bring in this error. The error I want is called, this is payroll error. Okay. So we're accessing the unauthorized. So what is happening here is that the organization account must exist and must have been created already, right? So that's the condition for adding a worker to, to what's it called, to an organization. This is one of the reasons I like the Solana Anchor very well, because it's very protective, it's very secure, it's very type safe. It does not assume, it's try to make sure that you are very careful and what you're doing is on point. Okay, that is very important to ensure that smart contract, as delicate as it is, is working out exactly how it should. So this has one, it's talking about the authority of the organization. So it ensures that the authority sign matches organization's authority. That means whomever this, whomever is trying to add worker into this organization must be the one that created the organization itself. So that account is very important in this case. And then the seed, ensures this is the correct organization PDA, because this is how you rederive what we created before here. Okay, so that is very important. If you get those things correctly, then you're in good standing. So the next thing I want to do, I'm going to then paste these ones now, because I don't need to type too much. You already know how it goes. This is how it goes. We're creating another account. This is one account we are referencing. We're not creating it, but this one we are creating it because it's the first time we're creating a worker, right? So that's why I have this need space. We have this authority. We have this space. But this space is going to be based on worker, which we haven't in the worker state. We have not brought it in yet. So for you to bring it in, you need to do, okay, so this organization, you're using that, you're getting that from the state module and also the worker. So those two things, you're grabbing them there. Once you get them, this is how you form the space which this worker account, the space it's going to be occupying. All right, and we have seeds. Now this seed, this is how an account, a worker account is created based on this seed. So we have this worker merged together with this organization key, okay, which is very unique to that organization, and then the worker's public key as reference. So the key of the PDA, basically the key of this organization plus the key of the user, plus the worker string. This is how you're using deriving the seed that is associated with this worker, and it's going to be unique for every single worker. All right, so I hope you understand that. So this is how you create the account, and this account is based on this state that is here. I don't know if I still have Rust, let me see. Do I still have those Rust? Let's look at Rust. So Rust extension is already installed. This is deprecated. Okay. So this is supposed to be providing me with all those intelligence, such as linked code completion and navigation, but I'm not getting that anymore, which is one of the reasons I'm having that issue. I don't know which they use now. Use the Rust Analyzer. I already have this installed. Okay, let's try and update that if that will help. Anyway, let's leave it alone. If it can't help me, let's leave it alone. This was supposed to be very easy to navigate around. It's all right. We can do just fine. Okay, so this is the account. Now we need just exactly the same things as we did here before. Before, and let me do some explanation. This is for creating a worker account, initialize, create a new account. This is payer. You understand what the mint authority is, the space. So basically, these are the same things. Now we need the worker's public key. Very important, which is account info, and we're going to need that. Account info is different from account. So the worker's wallet address receives payment because you want the public key so that you can use that to make transfer later. So that public key need to be different. It's not an account, it is a public key. I don't know if you understand. So the string need to be different. So it checks, we validate this through the seed constraints. No data deserialization needed, just used as part of the PDA. Check workers wallet publicly validate seeds. So that is just what it does. Now we have that. There's two more things we need, two more accounts, which is just based on what we've done before. We need the signer, okay, the signer and the program, the system program. Those two are going to be important for the creation of this. So now we have all this together. We then need to create the function itself. All right, so this is the method which we should have used, or the structure, that we be in good condition. Now, here's how it's gonna go. We need to first verify that. Validate that the salary of this particular, because this salary, a worker, when you created a worker, the things that are involved are the public key, workers public key, which is going to be coming within this context framework, but what you're going to be passing inside this hard wallet. Why you're passing it through this context? Because you want to validate it and make sure that it's an actual Solana public key. All right, and then the salary is going to be coming through the function parameter as an argument. Okay, so you want to verify that this salary that you're trying to put in there as what the worker is going to be getting for each payment to be greater than 0. Okay, so that's first thing you want to do as a reference. Second thing you want to do, you want to then create the worker, get the reference, the mutable reference of that worker account. All right, so we say worker is equal to this mutable reference of the worker account. That is what is happening. And once you get that mutable reference of the worker account, you want to set it or save it as part of that worker's record. So this is a different one. So you access the accounts that we created below here. You have the first thing we got is this org. So we're grabbing the org, and the key there is the PDA. Okay, the key is talking about the PDA, just like we did it here. Okay, the key is talking about the PDA because that's the only thing we need. We don't need the entire account. We just want the key of that particular organization's account. So once we get that, all right, we need to set workers' wallet address because this is where they're going to be receiving their money. We want to set it here. So their public key will become the key in this workers or public key right here. So you get that as well. You need to set the salary, paid cycle, the created ad and the bump. Okay, so I'm gonna bring it up, bring this salary. Salary is gonna be taken from here, so we don't need to access anywhere. The last paid cycle is gonna be 0 by default. So this has never been paid before, and you need to set up the timestamp as before, and then the bump, which is based on this context, bumps, and then worker. Remember, when you create, a worker, it has a bump, right? So you should take note of that. There are more things we need to do, just a few more things. The next thing we want to increase the organization's worker count. So what we're going to do is to access the organization's account. Not just here, what we're doing is simply what we're doing here was simply just the organization's ID, PD. That's what we're just recording here. But here is going to be different. It's going to be different in the sense that we want to grab the org, which is this account that was retrieved here, immutable reference to that account. I want to call on, see why I put this mute here. This mute is important if you're going to be changing stuff that belongs to that organization. So I want to say this worker count plus equal to 1. That will increase the total number of workers that belongs to that particular organization. And then at the end, you want to just drop a message. You want to just log a message that will be seen as part of the function. I want to say workers added with salary, so you put the workers address and the salary, and that is it. You're good. So we then proceed to the next instruction, which is to fund the treasury. Remember, when you're creating an organization, it has a treasury, but this treasury is actually 0. We need a way to increment and decrement this treasury. For the worker count, whenever workers are added, it's going to increase this. So we are in good posture. So I'll see in the next part of this video. All right, so need to create another instruction here. I'm going to call it fund treasury dot rust, and you know the drill. So I'm just going to copy some of these here so I won't have to waste time. Bring it here. So we need this payroll errors. We need the organization. We don't need worker this time because we're basically only dealing with organization. We need this anchor prelude, very important, and we need what again? We need to access something called the Solana language, not prelude, but system program, because we're going to be dealing with money movement right here. So because we're dealing with money movement, we need that. So say system program. Great. Now let's get to work. And we need to create the context first. Context, very important. Need to make sure that make sure that all these are having this derived account, this context are added to them. Very important, because if we miss that, it's going to be producing an error. That we missed this one, so let me update it. So this is derive count and instruction. You see why we can use name here is because we are passing name as part of the instruction into this context. This name is not coming from here, but it's coming from here. So you should know the difference. Okay. And I believe that it is just going to be grabbing whatever that correspond with this name here, this argument. That is what it's going to be replacing. So that is very important in there to fix that. All right. So since we are in good posture now, let's come back here. Now I'm just going to paste this whole context because there is not something so crazy about it. Okay. So we'll call this fund treasury context. The same arrangement, the same procedure. Okay. We just grab an existing organization, which is this org. The same thing that we did here before, we're just repeating it. Okay. So that's why all here is just a repetition of what we've already done here before. So all my explanation here applies here. Okay. So we're getting that organization. After we get the organization, what next? You want to make sure that, of course, the same principle that applies there. Want to get the signer. I've already told you how you get the signer, which is the authority. The same thing that we did here. You can see the signer here, and then the system program. These are just important and basic things that we've already done before. So now, once we've been able to achieve that, then we need to create the function. Okay, so the function you want to create is you want to bring a validation. Okay, because now you want to fund the treasury of an organization, and the amount that you're trying to fund should be greater than 0. Otherwise, say invalid amount, right? So that's the validation that we want. Okay, now we want to prepare CPI to system program. So there is something called CPI, which is cross program invocation. Cross program invocation to system program. We are calling system programs transfer instruction because we're going to be transferring money. This is where real money is involved. All right. So in Solidity you have things like payable and all of those things. So this is where those happen. I want to say let CPI account, CPI underscore account. I'm taking my time to write it this way because this is the first time we're doing something like this. Is a call to call on this system program now. That's the reason why we included this system program. And there's which is a module. There is a module called transfer. And when you're transferring from one account to another account, one account to another account. Okay, so basically this is it. We call on from this account ctx dot account dot authority, then you call on this dot to account info. We don't need this dot clone on. So this is the authority. This is where the money is moving from, and this is the account which the money is going to. Okay, now you should understand that this user here that you find here, this is the user or whomever is funding this wallet or funding this organization is a human being. So this is a user account, but this is a PDF, this is a program derived account. So it's going to be funding this particular organization. Okay, so to make it much explainable, I'm going to put some comments around it. So transfer from the authority's wallet and then to the organization's PD account. All right, that is how you send that money. So you've created the variable. You have not yet executed it yet. So there's something called create CPI context with system program. So this is the next thing we want to do, which is going to say let CPI underscore CTX. So the CPI context, we're going to define some extra information that it needs. So I want to say CPI context is a module in itself, and you want to call on this new method within it. And in that new method, we're going to access the account, this system program dot account info, and then the CPI account. So you're using this account to perform this transfer, sort of. You understand that? So that is what is happening there. So you're creating that context because this is what is going to be responsible for making that transfer. So it based on its own rule. It's a program on its own, and it's running. It's running within the Solana blockchain, and you use this module to interact with it. So what you're doing is setting up the instruction on how it's going to be interacting with that program on Solana blockchain. That program is responsible for taking money from one account and sending to another account with all the authorization correctly done. This is why I like, Solana, because it's a very mature blockchain in the development behind it, the brain behind it. I want to say execute the transfer. All this while we're just setting up some things. Execute the transfer. You want to call on this system program, and you want to call on the transfer method. When you're transferring this CPI context, you're passing the context and the amount that you are trying to send. Okay, so you're trying to fund that account. So that's what it takes. Now, once that has been done, you need to settle the balance. Okay, settling balance means that if you're an accountant, you understand when you debit from one person, you add to another. So since we're debiting from our wallet address, which is this, we need to update that in this system to also be a record, not just on the blockchain, but also on the smart contract as well. So we're going to update organizations treasury balance. All right. And to update the organization's treasury balance, we don't need to call on, what do I mean by that? We don't need to do all this. We don't need to get the immutable reference for that. We want to update it directly. So I'm going to call on this treasury. Okay. And just update it with that amount. And once you do that, you log it off. The treasury funded by the wallet by the amount in Lamport that was sent, and then you say okay. This okay is basically a result, and that is what this function is expecting at the end of the day. So yeah, you save it and you are in good posture. But we're done with this particular instruction. So in the next part of this video, I'm going to show you a withdrawal instruction. Okay, so at this point, I think I'm just going to close some of these to make things a little bit lighter. All right, so let's create another instruction. I'm going to call this withdraw. The drill. This withdraw instruction is going to carry all this with an exception of this system program because we're not needing it anymore. Okay, then we need to define the context. Remember, the context is going to be the same as before. Okay, so we're not going to be doing anything new, just changing. The only new thing is that we're just calling it withdraw context, but everything remains the same as it's always been, as you can see right here. So That's good. This is one of the reasons why you teach once and you just, you know, you do copy paste from there so that we don't waste more time, you know. So now this is a withdraw function, pass the context and the amount that we intend to withdraw. You know, please always take note that the amount, you look at the treasury, you can see that it's talking about unsigned integer of 64 bits byte. It has to be corresponding with whatever you're putting in here. Okay. All right. So first thing we want to do is to make sure that just like here, the amount that we're trying to withdraw is more than going to be more than 0. So I'm going to copy this line, bring it here. All right. And unlike the form treasury instruction, we're going to have an extra one here. An extra validation that we need to do is that this context account, the organization's treasury, must be greater than the amount that you're trying to withdraw. Otherwise, it should give you an error that you have an insufficient, funds in your account. So that is very important. Once that is done correctly, then we need to then transfer the Lamport. Remember, the ideas are going to be different here. Here, we're using this CPI method and with system program to move money from a user's account wallet into the organization's account. Now we're trying to do the reverse. Now we're trying to take money from an organization's account and send it to a user's account. So the ideas are going to be a little bit different. So you have to pay attention to these differences because it's going to come. It's going to come back later. All right. So let's write this. Let's do this whole line. So I want to say CTX. This is, this is basically this is what we want to do. This CTX, which is the account, the organization's account, I think this is called a dereference, symbol, and then you call on this account info of that organization's account, and then this try borrow mute Lamport is a way of is a way, and then you subtract this amount. This is how you decrease the resource, that the anchor, or the Solana value or the Solana amount that is available on that organization's account. So CTX, this is the organization's account, and we're calling on this try account information. That is how you get all the information, such as the money that is available in that account. And then you see try borrow mute Lamport. So to try and borrow if it does have this. So it's more like forecasting. You understand that if it fails, there's a way it falls back to us as well without messing up. And then this way, take out money from that organization's account, and then you want to send that money to the organization that the authority or whomever was the founder of this account. So that's what's happening here. See, this time we're calling on account.authority. All right. So the authority here, which is this authority, and only the authority that is authorized to deal with this organization is the one that created it. Otherwise, we say unauthorized. So that's what is happening here. So it's going to call on it and also send that money into its own wallet address, right? So that is what is happening. And then at the end of the day, you just want to say that the withdrawal was successful. Now we don't want to miss an important part. You see, before now here you added, you updated the account treasury. Okay, so in this place, we want to subtract from that account treasury, the organization's treasury. That is how you deal with this organization. That's how you cash out from that organization, in a very secure way. So that is cool. Now in the next part of this video, I'm going to jump into another instruction, and this instruction is going to be called, let's do that in the next part of this video. Okay, so now let's come here in this instruction. I'm going to create another one called process payroll. And for this, I'm going to need these packages. I will be working with organization and worker. This is going to be a long one, but the idea remains the same. So for this context, we're going to be doing something similar. Basically the same thing, process payroll, the same, setup. All right, these are some notes that you should consider as well. You notice that worker PDA and wallet account are passed as remaining account. They must be in alternating order. Worker PDA 1, worker wallet address 1, worker PDA 2. So this keeps the transaction flexible for any number of workers. Okay, so this, we set it up. Now let's go and create the main function. The main function is really large, so let's keep it, let's keep our mind that. So this is process. Need that with the context we're passing are multiple here. So we have this info process, process payroll context. So these are the various contexts. The only thing that we're passing as a parameter is the cycle timestamp. So we want to get the number of workers that we want to make payments to, or that payments are going to be getting to. This is how you get the number of workers all on the CTS account. Organization has organization count, and you want to typecast it as what? Usize, unsigned integer, So once you get that, the next thing you want to do, you remember this principle here that they must be in alternating order. So if we have like 2 workers, that means this array size of the array need to be doubled by 2. So that's why we're going to be doing this here. I'm going to do this, multiply the number of workers by 2 and save it as this number of expected account. So each worker need to account their PDA and their wallet. Calculate the expected number of remaining accounts. So that is just what you should understand there. Now I want to do a validation. I want to validate that we have the correct number of workers, provided. So what you do is this CTX remaining account dot length, which was discussed here. Note worker PDA and wallet account are passed as remaining account. Okay, so that means this is a sub process that we are not seeing right here. So we're letting you know that this is passed behind the scene as what? Remaining account, which is basically an array, and that array you're calculating for the length. Okay, So you're grabbing the length and you comparing it with this number of expected account if they are equal. Otherwise, you say missing worker account, right? So that is the first thing you want to do. So we want to cache organization's key and program ID for PDA verification. Okay, so this is the organization's key, the account, the organization's key right here, and then the PDA. This is the program ID. So you grab those two and store them in that variable. And once we do that, so we're going to be trying out some certain tests. All right, so that's why I say that we should take some time. So the first test we want to do, first pass, validate and calculate total payouts, because you want to know how much you're going to be sending out to all of these people. So we do this separately to ensure all accounts are valid before transferring. So this is total payout, and it's going to be on signed integers base, 64 bits. The reason I'll add this zero in front of it, you're giving it an initial value to be set to zero. Okay, so that's why that's just what it is there. Okay, so now we get it, and we're going to now have to do a for loop. Okay, this is how for loop happens. All right, so for I in 0 to the number of workers, this is a range. Okay, for I in 0 to the number of, so it's going to be looping through all this. So the first thing I want to do is calculate indices. Let's do that. To calculate indices, workers are in alternating pairs, so have the PDA indexes and then the worker indices. PDA indexes are the first, which is I times 2. Okay, so all the even numbers, even indexes are worker PDA, and all the, if you do this, if you just add 1 to the worker PDA index, then you get all the indices, so which are the worker addresses. So that is just some mathematical structuring there to ensure that we are getting the right information. Now remember, this is where all these accounts, they are lying in this remaining accounts here. Okay, so we're going to get into it. This PDA AI, we're getting a reference by passing the PDA index, and also for the wallet by passing the PDA index. That will get us the accurate values of the PDA, which is the account, and the wallet that is associated with that PDA. Okay, this is for the various workers that we have. And once you do this, you want to verify that the worker PDA is correctly derived. Then reconstruct the expected PDA address. So let's check it out. Remember, there's a way we normally derive workers. Let me look at this. For example, this is how we derive workers. Okay, so this seed, that's how you derive the PDA. So now let's do the same here. The worker PDA seed, which is this view worker, similar to how you have it here. Your organization's key, the worker's key as reference. So you see organization's key as reference. Okay, you have view worker's reference, you have organization's key as reference, and worker's wallet address as reference. So these are the things that you need. The organization's key is basically here, okay, which is what we just get, and then you just call on append this as reference to it, and this here, wallet, the worker's wallet address as reference as well, which is basically the public key of that worker. You can see here as we are getting the key similar to how it was done here. Look at the key for the public key here. Great. Now we've been able to get the PDA, the worker PDA seed, and when we get that, we want to now do expected PDA is equal to, while we're doing this, we probably don't want this aspect, so that's why we're just signing into this. So we say public key, which is a module or a class. Then you find program address. Find program address by passing the PDA seed and the reference, a reference of the program ID, so that will give you the expected PDA. All right. And ensure the provided PDA matches the one. Okay, very important. This is a verification process. That's why we're going through all this. So requires keys to equal, to match. You understand that? So this key here, this PDA, PDA AI key is expected to match with this. Is supposed to be equal to this expected PDA. If they match, if they don't match, we want to say invalid worker PDA. This is very important. It's just a security measure to make sure that we are not sending to the wrong addresses or an invalid worker or a worker that doesn't exist or a fraudulent. So anything that would just be an issue to the smoothness of the payment will be eliminated using this method. All right. So the next one, we want to deserialize the worker data from the PDA. Worker data from the PDA. So we want to say worker on the account module, and we are typecasting it with this worker state that we've already created before. You can see here is worker state. So a worker has all this information. All right, and these are the information we're trying to grab. And then you want to say try from this PDA AI. Okay, and that will give you the workers, the serialized information. Next thing we want to do is to say check if worker needs to be paid in this cycle or not. So only pay if last cycle is before the current cycle. So it means that you may pay some workers and then you added a new set of workers. There needs to be a way for you to make sure that you're not overpaying. You understand that you're paying the right amount to the right people at the right time and not double pay. You get? So that is what this angle is about. So only pay if the last cycle is before the current cycle timestamp. So I want to say if this worker last paid cycle is less than this cycle timestamp, so the time that you're actually paying this, then because when you make the first payment, you have to also pass this so that we know next time that this is going to be paying. So because for a worker that has already been paid, then it's going to skip it. Okay, it's going to skip that worker. You want to say total payout, calculating how much you want to pay out. Total payout is equal to total payout dot checked add, and then you add the worker salary, and then okay, or okay is going to return okay, or it's going to return this information saying insufficient fund. Okay. All right, and then at the end of the day, you want to, because what you're doing, you're this is going to be comparing. Then at the end of the day, I want to do this. I want to require validate that these are the treasury, the amount that is in the treasury is greater than or equal to the total payout that has been calculated for all the workers and all of that. So if it is good, you're good. If it's not good, it's insufficient fund. So that is very important. That's the first test that we are projecting. Now we're going to do another test. I think this one is not going to be lengthy anymore. So let's do another test, another verification, sorry. So in this verification, this is what is going to happen. Also, we're going to also get exactly the same thing as we did before. All this up to this place. Want to get that same thing. In fact, I want to get up to this. Okay, let's get this part first. Okay, we'll paste it here. Then I don't think we have any need for. We'll just leave it like this, right? So that will get you all the worker, those information that you need. Then you also want to deserialize the account. So you come here and you do this. To deserialize accounts, the account worker try from AI, and that is it. So now you want to check if payment is needed for this cycle. So if the worker will need to be paid in this cycle, okay, if payment is needed to be paid in this cycle, so if you think about it, it is just the same thing as this. Okay, this is where the payment is really happening. So if this is true, you want to get the salary amount before updating. Okay, salary amount, which is the worker salary, get the salary amount, and you want to serialize updated worker data back to the account. All right, you remember we did a deserializing here, so basically you want to reverse what was done. So you need to look at this step very closely. So this is how you deserialize. I want to say data is this PD, dot tribal remote. You take data. So this is data. And then once this worker dot try serialize, you pass in mutable references, and then you pass in the data and all its content. Then you now drop that data at the end of the day. So then once that is successful, we now start disbursing the finances, and so we're going to decrease the amount of money that is in this treasury. So the treasury, we're going to reduce it by the salary amount for this particular worker. And once you do that, then you want to increase the worker's wallet address. Okay, so the amount of Solana token that is in the account. Okay, so you're moving it from the organization's treasury into the specific worker's wallet address. So the reference, the worker's wallet address, and tribe, just give it that lamport. All right, so at the end of the day, you want to update the organization's treasury tracking. So basically what you're doing is saying you want to update the organization's record so that we know how much, so that it will be balanced properly. So say this organization's treasury, we're going to saturating sub. So basically it's the subtraction that is going to be happening here, and you then update after the subtraction has happened, you update this treasury with the new balance. Then at the end of the day, I'll make sure that I'm in the right place. So, oh boy, I think I made a mistake. Okay, so let's correct that mistake. So the mistake is that I'm putting this whole second phase inside that same loop, for loop. It needs to be on its own. So I'm gonna do this first. I'm gonna just shift it out. Okay, I'm gonna shift all of this out. Hope I'm no, just shift it out. Okay, so that we have this is for the first loop and this is for the second loop, so they are different. Okay, so that is one correction that I needed to make. Great. And then at the end of the day, you want to do this as outside this for loop. Want to spread in words, say account, organization name, payroll process for the organization, and there is a total number of Solana token that was carried out for the total number of workers, right? So you save that, and that is what that particular function entails. If you have any issues, please consult the finished version of this application. You find everything to be in alignment. If there is any error that we encounter here, the cost of testing it out is going to be reviewed and we're going to have it resolved. All right, let's finish it up in the next part of this video so that we can proceed. And because we've done so many chunks of them, we need to create a module for this instruction, and then we merge everything together in this library function here. I'll see in the next part of this video. Okay, so in this payout instruction, I'm going to say mod.rs. Okay, what we're going to be doing, we're going to get all this, we're going to gather all this instruction and then also re-export them, all right, that it can be used outside of this place. So we're gathering all this module, making them into module, and then re-export them for public functions. This is for convenience, you understand? Because Rust is very crazy sometimes. If you don't do things accordingly, you're going to be suffering from it. So I don't want to be suffering from it. Okay, so let's fix that. This is the very first this is the bundler. This is where everything is going to be bundled together. And one of the things I want to do is I want to say allow unexpected CFGs, because if you don't do that, you're going to be getting a bunch of errors. Okay, now I want to import all those modules that we created. Okay, so I'll say here, these are all the modules, the errors, the instruction, and the state. Great. We want to give it a proper name. We're going to call this hello about program, payroll program, and payroll program, and we don't need this here. We can remove this function. So what we're going to be doing is the first instruction. Okay, the first instruction is to create an organization. The organization has a parameter, which is the organization's name, and it returns success. So we're going to just create it using this. Maybe I should type it for now, then next one I'll do it a lot easier. So we say function create organization is going to be exactly the same name as what you used during those functions that you're creating. So the context is going to be this create organization's context. It's almost red, but I'm going to do this instead. Create organization context because it's been imported here. So it's part of these instructions that are here are going to be available for me to utilize them. And then the name string. Great. Now that you have that, the next you want to do, you want to then invoke inside this instruction. There's a function called create organization. You understand that? And you don't need to repeat this because the way we bundled all this together here enables all this to be available, okay, without having to namespace it again. So we're having a little bit of an error here. It's expecting more than these two parameters. Okay, so let's look at that to see, okay, this bump here, we didn't have any use for it. We didn't even use it, so we should remove it. This is what is causing the problem. Remove that, and that problem is gone. Okay, that's cool for now. So that function has been taken care of. I'm going to do another one here. You already know the drill. I'm going to say add workers. Then he's using that add worker context, have a salary, and then we pass it in. So the worker salary is in Lamport. So we're going to be converting it when we're working with it on the front end. Okay. And you also need another one for depositing fund. So this one is for funding Treasury. The amount is going to be in Lamport as well. And then we have the fourth instruction. This fourth instruction is for processing payroll. Parameters include cycle time, when this payroll cycle started. Okay, so that is what that one means. And then remaining account for workers, PDA and wallet. Okay, and return success. So that is what is happening here. Remaining this is passed behind the scene. I'll remember. All right, and lastly, this particular function, which is to withdraw, make sure that it's bypassed. Let's see that we're having a little bit of a warning here. So what we're going to do is to build this project because I'm not sure if what it's complaining is accurate. I'm going to seed into that anchor and do anchor build. Let's see. So obviously this is happening. Okay, so I've tested it in multiple ways. It isn't yet working. So some of the time, one of the things that you can do to try and see if you can change this is to run anchor clean. Okay, and also do anchor cargo clean, and then let's do anchor build again and see if that will help. So let's give it a moment to complete. Okay, so we're still having the same issue. I don't just know where this problem is coming from. This is one of the issues that you have with Rust. Just a little bit cryptic. So I did some further digging around to check why that was producing an error. It turns out that I missed one line here, which is called use instructions, and actually this one line is quite important to combating these errors that we're seeing here. So that is what was primarily responsible for it, and it makes sense since it's only one line of code. It was very difficult for me to detect, so we're going to compile it again and see, how it goes now. So let's do anchor clean, okay, and cargo clean, want fresh build, and want the anchor build, and let's watch it. So why this line is very important is that it brings all this create all context, add workout context and fun. All those contexts, it brings them together. So if it's not here, it it definitely gonna be what producing that error, you know. So that is what we discovered. Okay, congratulations. We've been able to build the entire project successfully, no bug. And if you check this anchor, these are the program. Okay, these are all the instructional error. And look at this target. It generated even the IDL. We have the IDL now. We have the types. It's basically another a camel case of the same idea. So those files are going to be very useful when we're going to be doing the test. So in the next part of this video, I'm going to be teaching you how to test each one of those functionalities. We're going to test it for various conditions and make sure that we all pass successfully. I think we're going to do up to 20 something text. So I'll see you in the next part of the video. Okay, so we're done with writing a smart contract. So we want to test out those smart contract functions and various cases to ensure that we are in the right, everything is right. Okay. Please, before you test the smart contract, I would like you to look at this file, because this file is very important when it comes to Anchor development, Solana development. This recurring file is both in the front end and in this Anchor directory. You can see this version. Make sure that it's very consistent. I think that's the same version, that is here as well. Yeah. So the same version on the CLI, the same version on the Anchor program, and the same version when you check your front end. So make sure that it's kept consistent. So this is Anchor SDK for interacting. Is the Anchor framework, for interacting with Solana smart contracts. Okay, very important. And this, we use Chai and Mocha, very crazy names, right? These are the testing frameworks I'm going to be using for assertions, for assert test cases, and of course all tests are going to be written in TypeScript, not JavaScript purely. Okay, so I think those are just the most basic things that we need to do, right? And for us to, I also need to explain this little package. This one here you see is a very simple script, deploy.js. It will help us. The way it's also using that Anchor framework. So this is just a simple placeholder that Anchor, makes available by default. But if you want to do some special deploy tricks here, this is where it is all accomplished. So you should take note of that. Now we're going to write our test cases, and you need to write that under a new file, the test slash the program, payroll underscore program .ts. Alright, test, or just call it .ts. Okay, so we have payroll program.ts. So this is where we write all our tests inside that one script. The first thing I want you to do is to let's import the necessary packages that we're going to be using in this application. So the necessary packages include this Anchor framework and Web3 JS libraries. So this is Anchor framework. This is, Web3 JS libraries. And of course, this Anchor, remember, is imported for smart contract interaction. This being, is a short form for big number, for handling large numbers, such as salaries that are described in Lamport. Lamport is the smallest unit of Solana token, just like in Ethereum is actually WEI. So in Solana is referred to as Lamport. So we also want to import these types that is generated. So this is a type generated. I click here, you see that this is literally a type that I can use. In Camel case, is automatically built up during compilation and building phase of Anchor. So we need that so that we can have understanding how to interact with this smart contract effectively. So we need public key and key pair for for Solana account management. So this is how we need those two, very important. And this Lamport parcel is a standard that is a standard comparing one Solana is equal to how many Lamport. So that's just what the idea is. And this assert that is coming from Chai helps us to verify test results. So when we're going to be doing test result verification, that's where is going to come into the picture. So now I want to initialize a test case. To initialize a test case, we use this describe function. I'm going to write it just one. You see describe, this is basically a function. And then it takes in a callback function, which is what we're passing right here. Okay, so this is where all our configuration is going to be going in. This is where we write all our test cases. This Payroll program comprehensive test. So the first thing you want to do is to connect. You need to connect to the provider, the blockchain provider that you're interested in interacting with. So it could be localnet, it could be devnet. All right. So if it is localnet, devnet, all of them are the same way. What you need to do is to say once provider is equal to this anchor provider.env, right? And then you say set anchor, provider with this current provider that you got from the environment. That is how you set it up, and then your application then will be able to proceed. That's first initialization. Second initialization is to get the program instance that to call its method. We need the program's instance called its method. So how you do that is by saying const program anchor workspace, then you call that Payroll program, and then give it a typecast it as this program, but this one here, so you just wrap it around this type so that you can easily work with it. Very important. And then one of the last step that you need for initializing this is to the authority is whoever is running the test cases, wallet. So that's why you need this authority right here. Authority is going to be provider.wallet, but not the public key, see as anchor.wallet. And that's one of the reasons why we're importing everything as anchor. So this program is going to be allowing us, this provider is going to allow us to communicate with our connection on Solana. This program is going to enable us to call the smart contract methods. This authority is going to be whoever the runner of the test is. So very important. Now, what you need to do, organizations we need to specify some important details, that like variables that we're going to be using for this particular application. So I'm just going to paste them one after the other and then explain. So, that is organization's name, the organization's PD and organization's bump. I think I should just bring in all that I want to bring in at once. And I'm just going to close this to give enough room here. These are just various variables. We have organization name and its derived account addresses, which are the PDAs. So this is an organization derived address and these are just the variables. Then we need to create 3 workers. All right, so we use this key pair to generate fresh wallets for each one of those workers. And we need to also specify the PDA, that is the program derived address for each one of those workers, because it's important. And then you want to specify the salary for each one of those workers. They are in big integers or big numbers, sorry, because Solana uses very large numbers. So you want to make sure that all of these are in large numbers as it is sent. Okay, so those are very important. Now let's define some helper functions that are going to be, very great. Are going to assist us a lot in the course of this development or testing. So this is the first one. This one is called get balance, which you pass in the public key, and it just simply returns you the balance of that wallet address, which is the public key. And you also want another one called airdrop. Okay, and what airdrop does is to pass in the public key an amount of Solana token that you want, but by default is 2, and then it will send it to that specific wallet address. Okay, so that is what is happening here. You see this C, which is for signature, and you call on this. Let me see which this. They say that this is deprecated, and there's a new way they handle it here. I don't want to go into that now because this works just fine. So you request the airdrop, for public key and the amount. So those are the very 2 functions that are going to be necessary. Please, you should understand that this function only works on DevNet, localnet, or DevNet. Okay, it doesn't work on mainnet. So don't think about getting a free airdrop on Solana mainnet. So we need to set up a hook. This hook is going to be called repeatedly across various test cases. That's what hooks are for. So we're saying this one is called set test account. So what it's going to do is to derive the account, the organization's PDA using program specific seed, and which is the organization, the authority's wallet, and the organization's name. So this is how you derive, a seed for an organization. Okay, and I'm going to open up this so that I can make some comparison to show you what is going on. To create an organization, if you see, to create an organization, this is how you derive the seed, which is the org keyword plus authority, and then plus the organization's name. So that's the things that we're doing here to derive an organization. So yeah, take note of that. And yet you need to do it very correctly. And in order for you to do it, you want to say this public key, so find program address sync, and then inside this we want to pass in a buffer. Please, this should not just be a string, but should be a buffer, and all of them basically should be in buffer format. So you see that I convert this keyword, this organization, to buffer. I convert this authority public key to buffer, and then also convert the organization's name to buffer. So those are the various things that are required. Okay, and then you also want to pass this program ID inside here. If you check this program, there's something called program ID, there. But if you look at it, you think we had, and then Kaka is defined it here. So, but you get the idea. When you instantiate this program, you have access to the program ID. Just know that. So these need to be stored in the structure, okay? Because it's going to be coming with the organization's PDA and bump. So this is how we get the PDA and the bump value. That's very important. Now I want to do something similar for each one of those workers, to derive their PDA as well. I'm going to derive the PDA of this worker. Start with that. So this is worker PDA 1, and the same procedure. Remember, let's look at how we form worker. We create a worker. If you're creating a worker, this is how the PDA of a worker is formed. The string worker, the organization's public key as buffer, and then the worker's public key as well. So we're going to do this for each one of those workers. This is worker 1 that we're doing, which is this worker 1. You can see the worker 1's PDA. Okay. So worker 1 the public key. We need to do 4, and then we're assigning it to this worker's PDA. Okay. Or grabbing there. This is for 2, and we just need to do the same thing, or just changing the that ID, and lastly worker 3. Okay, these are the various workers. Now we have their PDA, so we derive the workers PDA for each one of those. Okay, so we're in good condition. Just going to describe it very well. It is equal to worker, organization's address, the public address. Organization's address, which is the PDA, I will go from here, and you just want to easily convert that to buffer instead of redoing this entire thing for redoing this entire thing for each one of these lines. You don't need to do that. Okay, so that is it. That is it for the hooks that we're going to be using. What else we need to do? We want to start working on each one of the various test case. This test is basically going to be categorized into organizations, workers, and all of that. In the next part of this video, I'm going to start showing how we're going to be categorizing these tests. We're going to put them into various categories. We're going to start with the organization. Okay, so and then once we're done, we can proceed to the rest of the development. See you next. Okay, so let's go. We're going to create another describe function. So organization creation, we're going to define the first use case similar to how we describe a group of tests. We also use that same setup. So this is a unit of test. A unit of test is described as an IT. Okay, IT. So this we test specific thing about the smart contract. So you should be able to successfully create an organization. So that's what it is. And for us to create an organization, we need to say await. Remember, this is an asynchronous function, so you need to be, and the blockchain has it needs some time for you to communicate, especially if you're doing a write function. A write function means that you're writing something to the blockchain, so it takes some time. You need this program.method. You want to call on this method called, let's say we are doing this ourselves. We do this, you find out that it gives us access to all the methods that are in this blockchain because of the type annotation that we have incorporated with it, which you can find here because of this wrapping here. So we'll be having access to all of those information, which is a great deal, So you pass in the organization's name, which is this tech prop, and we need to pass in an account, and then call on that RPC. So for accounts, you can only pass one because if you look what is required to create an organization, the only account that we need is one account. So among the many accounts, there's only one account that we're passing. Okay, so pay attention to all those tiny details. They're very important. So what is being passed here you see that we don't pass the context, it's only the name that we're passing. You can see here, and then the context can be passed under these other things such as the accounts that we're passing in, and we're also passing in the authority, the signer. Look at here, this authority here, that's what we're passing. So when this organization is created, you see, so this step here, we create the organization for us. Then the next step we want to do is to fetch the created organization. How do you fetch the created organization? You see org account equal to that same await account dot organization dot fetch PDA. You fetch and then you pass in the organization's PDA. Remember, the organization's PDA is the one that we created, we defined here. Okay, so that's the organization's PDA. We are doing that to check if by this PDA that we've defined here, if it matches, the account. So this is how you confirm, you know. So let's verify that. The assert to verify that all data are correct. So I'm going to do assert organization's name is it equal to the name that we specify there. So you want to, the organization name is mismatched, saying the one that we got from this is the organization's name. Where is this one? Org name TechUp. Is TechUp equal to the one that is coming from the blockchain now, from this account name? If it mismatches, say organization's name, it doesn't match. Okay. And we have definitely have other um assertion to make. So we're gonna do them all at once here. So this one here, you're saying you're asserting that these organizations, the treasury, you need to make sure you convert it to number first because it's in big number. So by you converting it to this, then it will just be in number, which is a lot easier to work with. And of course, because we have not deposited anything to that, we expect it to be the initial treasury value, which is 0. Okay, so that is another test. And the number of workers is expected to be 0 as well initially. And I want to say assert the bombs, account.bombs is equal to this bomb that we derived here as well. Okay, otherwise I want to say bomb mismatch. So that is one of the tests I want to create. So once you've written that test, for you to check it out to know whether it's working, you need to do anchor test. You run that, and then it's going to go ahead. So I think we're getting this error because I'm supposed to write this in a test folder, but this is singular, so I'm going to rename this folder to test and S right there. So let's play that and check it out again. Let's execute that. Okay, it was successful. So that just verifies that our test setup is all good. I was able to create successfully and verify that each one of those records are the same as what was sent into them. So now we have other kinds of tests I also need to bring in. So we'll bring it up here. Now I'm not going to be typing each one after the order because that's just going to slow my time down. And I'm going to paste it and I explain. Maybe I could break this down. Let's explain this one. So this, should fail to create organization with name exceeding 100 characters. Remember that we put that as an essential record, an essential thing to consider. So this is a long name, and we just use this character A and repeated it 101 times, just one character extra, and then we did this try to create it with that long name, the same thing, and we expect it to fail as fail, should have failed with the name length error. If there is any error about it, then want to convert that error to string and want to check accept either invalid name error or PDAC length error. So we want to check, assert dot is true this error include things such as invalid name, one. It include things such as max seed length exceeded, or it include things such as maximum, or include things such as seed. So these are various things that we use to test against this failing. I think we should just run that test to see what it is. So run that. Okay, failed. It failed. Let's just log out some of these things to see, you know, log console. Okay, and I also want to log this so that we know exactly which condition is succeeding here, or is working out here. So let's run that. So you can see this is the error, but so it's an error. It's expected to fail. That's why error is actually expected. So you can see reached maximum depth for account resolution. Reach maximum. So this error string contain unresolved account, or so it contains the keyword maximum here. So because of that thing, we included maximum here. Then and you can see because of other keywords such as okay, say reached maximum, not exceeded. So this will what pass because of this line. Very important, and that behavior is indicative of the fact that the number of character that is being specified is more than 100 100 characters. All right, so that's what you should take note there. Okay, and that is for creating making the error, testing for that length of character. All right, so let's try and check for duplicate organization. So it should fail to create duplicate organization with same name. All right, so this is the same call, because remember, before we even run this particular test, okay, at this point we've already created an organization with this specific name. So trying to recreate it, should produce an error, saying their search should fail. We expect it to fail here, and this case, the string or the error string that is returning should include a keyword already in use, right? So, and if it passes, that would be cool. I think it would be cool for us to also log out. All right. And so, okay, so let's test this out and see how it's going, because we expect it to fail. So it's failing with this message. Okay, so this is a message, and within this message, transaction simulation fail, error processing instruction, and there's a lot of blah blah blah. But what you want to check for is this thing called already in use. Clearly tells you that account address, that particular allocation is already in use based on the PDA setup. So you can't rewrite it. You understand that? So that is very important there. So that's why it's working, right? So we can create duplicate account, aka organization. Yeah. So of course, these test cases are all part of the finished work that are incorporated in the GitHub branch that you downloaded. So please check it out there, so that check it out there so that you can get it. Okay, so you will get it that way. If in case you're not able to follow line to line, or you can pause the video and be able to recreate what I do on the fly, because I'm not trying to wait up to code these things one after the other, because they are quite repetitive if you ask me. So this we are trying to test for failure again. So should allow different authorities to create org with the same with same name. So this is correct. Uh, if you're another worker, another person, you can have the same organization in your own account, under your own account, but one account can't have the same, organization twice. So that's what is happening here. And to have this happen, you need to generate a new key pair, which is a new wallet, and that is a new authority. And then we fund that authority using this airdrop means a public key. We just send it about to a Solana token so that it can be used for this operation. So we create a PDA for it, which we include. The only difference between this PDA and the other one is that the authority is going to be different. And then we use that to create the organization, and we expect, this is the number of the signers. I think you cannot. This is one way to express it, and this is another way to express it. Okay, now there's a difference here that you need to know. The difference here is that we introduced this thing called signers here. Meanwhile, in the other one, we only were using accounts. Remember that an organization has accounts and has, so this signer has account, okay, and has a signer. But in the previous ones, we didn't include that signer. This is because by default, it's already passing that signer to be the default wallet address here. Okay, and default wallet address, you cannot default wallet address by just calling Solana balance. Okay, that network is not online. So, but there's a default wallet address which Solana uses to interact, with the smart contract. Right now that you're using a wallet address that is not the default, then you need to specifically pass it as what? Signers. Then you pass it in this array-like format. The signer could be more than one. Okay, so that's why they are making sure that it is in this format like this. So this is the new authority that you're passing the key here. So that will be the signer, and we create that organization. Now, once the organization is created, hope I'm doing this correctly. Okay, better. So, once it is created, we want to verify, this is a new organization. So the authority of that organization converted to base 55, 8, and the one that we use in signing that transaction, when compare it, we expect them to be the same. So what I'm going to do is I'm just going to log it out for you. Okay, so let's test this and see. Anchor test. So it passed successfully. Both of them are basically the same. Let me be more precise. Authority, and let's say authority origin confirm. Let's see those two. Let's see how it goes. Okay, you can see this is the authority right here, and this is that the both of them are the same, so that is how using testing it. So I'm not going to be any much time trying to prove to you that these tests are legit, as you can see, anymore. I'm just going to go a little bit faster and finish up the test. Okay, I think we can finish up for what is it called it, for organization management here. So this is enough for organization. The next part of this video, I'm going to be working with workers now, managing workers and all of those things. I'll see in the next part of this video. So now this is all we got to do with the tests that are associated with the worker. So let's get the tests that are associated with this is for organization. Let's get the one that's associated with the worker. So this worker management, and we have this first test here. This first test simply creates a worker for us. So it says it calls on that add worker method and passes this first salary. And the first salary is about 1 lamport. So, and then you have this thing called account partials. So account partials are important because account partial is talking about that it needs other accounts in the course of making this transaction. Okay, it's not just all about itself. Remember that a worker belongs to an organization, so it needs an organization's account. So that's why we're using account partials. And now for the organization, look at adding of worker. You need both the first of all, you need the account for the organization, which is the PDA, and you need to pass that org PDA here, as you can see, ORG. Has to be exactly that, ORG as well. And the next one you need to pass is for this worker. So you need to make sure that you pass it correctly. You have worker as an account. This is going to be, since it is being created, it's going to be done within the smart contract. So you're not doing it here. Okay, it's when you want to retrieve it, then you have to pass in the PDA according to how you have worked on it before. If you look here, this is how a worker's PDA is being created. So just be aware of those differences. And you need to pass in the worker's public key. As you can see, this is the worker public key, but it has to be in camel case when you're interacting with it on the front end. From this test script, so that's why it's like this. Authority needs to be there, and system program. All this record, system program, authority, all of them has to be represented. The only one that is not currently represented is this, because it is. And why so is because this is the first time you're initializing it, so it's being taken care of from smart contract itself. Is when you're accessing it, then you can then manipulate to get exactly how this account is going to be. Okay, so, and this is how you get the system programs, anchor.web3 dot system program id. You need that. So this is what you use in creating a worker. And once you do that, you want to start making your assertion. Okay, so the first assertion, once you get the worker account and you fetch it, first assertion is that you want to assert that the worker's account, the salary of this worker is going to be exactly or the same as what you specified here, which is about 1 lamport. Okay, so when you convert a lamport to number, it should be the same as what you registered it with when you convert it to number. So that's one of the assertion. We want other assertions as well. I'm just going to update it here. So what I'm updating is, I'm not going to only need a worker account, I'm going to also need the organization's account as well. So let me paste that, and so I grab the worker, this will be passing the worker one ID, and also grab the PD as the organization as well. So I have both accounts here, and now we're having this is for making sure that the organization which this worker belongs to, because a worker belongs to an organization. So if we come back here, you see worker.org is actually the organization's key. So we're using this to test, the organization's key. All right, this worker.org is equal to that org PD. All right, so otherwise a worker org mismatch, so it's not in the right organization. This, you're checking the worker's public key. Okay, you want to compare public keys are the same. You want to compare the salaries if they match. You want to compare if the life cycle is 0, because it should be 0 at this point because there is no payment that has been done yet. And the organization's account number of workers should increase by 1 because the work has been added into this. So we want to test that as well. So let us run this and see if it's all good. Okay, so you can see that is actually working. We are in good condition. Now let's add more tests. So the next test here, I'm gonna close this one, give it enough space. The next test here, you should add multiple workers to the same organization. Multiple workers to the same organization. I want to check for that because many workers can belong to one organization. So we create the second worker, okay, which is worker 2. Also create a third worker, which is what? Worker 3. Then we check the count. How many number of workers do we now have in this organization? It should be 3, right? So that's what we just did here, and this should work. That's all about that test unit. Also want to also make another test check. On the saying should fail to add worker with zero salary. So you're trying to add a worker like this is where the salary is supposed to pass, and the salary, as you can see, the salary, if the salary that you're passing is 0, then you should produce an error. The error should fail. We are expecting something to include what? Invalid salary. So we're testing it, and it should produce an invalid salary, because one of the criteria or requirement is that the salary must be greater than 0, otherwise you scream out invalid salaries. So let's save that. Let's run this to see if it is obedient. Okay, so it's actually obedient, it's obeying. All right, so let's add more tests. This will be the last test for this group. Let's break this down. All right, so this should fail when unauthorized user tries to add a worker. So let's say you're trying to add a worker to an organization that you don't own. Okay, then it should fail. That's why we have this unauthorized user is a new key that we created. We even gave it, some airdrops, that is some Solana that it can be able to do its stuff, and it's trying to add a fourth worker by into that organization. So we pass in the salary of that salary 1, and we pass in the worker public key, and the authority is that unauthorized guy, and which is also the signer, and see what happens. It should fail with unauthorized error. So expected an error to be thrown, okay, of course, and the error that is being thrown should be you have something related to include something like insufficient fund balance, or should be unauthorized related, not balance related. So what we need to do to verify this is we can just do a console.log and let's see what this error contains. So let's test it out and see. So you can see the error that has been produced. The AC constraint was violated. Correct. Error constraint. Okay, so it's not logging exactly, but it's not logging exactly what we did it. But this kind of solves the problem. This kind of makes sure that we are actually seeing what we're looking for. Okay, so what I want to do, let me come here. I want to instead do this, log out this, sorry. Okay, that's one I'm supposed to log out. Basically, they are the same thing. So it's all good. At least we know that it's failing. Okay. But if it's a lot more descriptive, there will be, amazing. So that is the error that we are expected to fail. It should fail with that issue. Now that is it for the workers test. Now in the next part of this video, I want to show you a test group for funding the treasury. Okay, this is treasury management. Now we'll do that in the next part of this video. All right, so let's get that done. I'm gonna do this. All right, I'll be back. Okay, so treasury fund, and the fund amount, how much do we want to fund this treasury? Let's say it's 10 Solana tokens, and it should successfully fund organization's treasury. I'm just gonna remove this for now. Okay, and see, we want to get the balance of the organization, and the balance of the organization is org balance before funding. Okay, and then we also want to get the balance of whomever is making the fund is funding the account before they actually fund it, right? And then I want to fund the account now. We fund it easily by saying await. It's basically this. So but is a lot better than this. We're not using account, but we're using account partials. So account partials, you need org, because you can't fund an account without what you can't fund an organization without its PDA. So the PDA is important. And if I come here, instruction to fund account here, you can close this. Fund account, you need this account, which is the organization. It needs the signer, which is done by default. That you're using a different person altogether. And I think anyone can fund the account. Doesn't necessarily need to be the owner of the organization. I think in this case it has to, otherwise it's unauthorized. Okay, so the authority is the owner of that organization. All right, so there we go. And you want to get the account, the org account that has been funded, and you want to get the balance. The balance is after as well. So now that you get all the necessary records that you're looking for, let's make two assertions. So the first assertion is that This account treasury, when you convert it to number, is equal to the amount that you use in funding it. Okay. And secondly, you want to check that this is true, that the organization's balance after is greater than the organization's balance before. That means balance increased. And you also want to check that the authority's balance is greater, is less than the authority's balance after is greater than the authority's balance before. That means there was a decrease in the authority's account wallet balance. Okay, so that is what we're using to test, and we run that test, we should be good. All right. The test could be very tedious if you don't have a very sharp computer, because it's looking really fast on mine because the machine is really fast. Okay. So now that we've created the first test, we need to write other tests that are associated with this as well. So this is another test here. So what does this test do? It would accumulate multiple funding transactions. So additional fund of 5, we can still fund the account afterward. So you expect the total fund, the funding amount. Okay. This add here is a function, is this function that comes with this type of big number types of data or values. So instead of doing plus, you can actually do add, like using the name this way, a natural way of adding it, like add like a function. So you add additional fund to this funding amount. The cool thing is that you can actually, the funding amount, we made it available at the, we package it at the description level, so these two tests have access to them. So we're giving it an additional 5, which make it 15 now. So when you funded this now, it should be 15. All right. And the expected total, remember here that when you add this, you're not overriding this. So this funding amount will still remain 10, but the additional fund now will be what? With 15. The same with here, the expected total 15. So we expect the one, we expect that the account treasury is equal to the expected total. That means it actually accumulated a new fund. Let's try this. Now we have another one. So this is the fund. Fund should fail to find. Okay, should fail to fund with 0 amount. To fail to fund with 0 amount. You can't fund with 0 amount, otherwise it should pay with message invalid amount. Simply, that is what that does. And lastly, for the test here, it should fail when unauthorized user tries to fund the organization, because an unauthorized user should not be able to even find this organization. These are private. All right. So you make sure you get unauthorized user and you give it an airdrop, and then use that unauthorized user as the authority and also as the signer. All right. And it's expected to fail. Should have failed with unauthorized error. So, I said, expected an error to be thrown, and this is an error around this record, but this basically does it, okay, for us. So these are the various tests that is associated with this group of tests. Okay, you can see 12 tests in total, all of them passed it correctly. For that group, we have 4 tests, you know, treasury funding, all of them passed successfully, and that is good. How many group of tests we have? We have 2 more group of tests that we need to test. So in the next part of this video, we'll go to the 4th group of tests and we test it. So we're testing this application all around to make sure that it's in alignment, it's fortified, it works just as we expected it to. Okay, let's close this now. So let's test payroll processing test. Okay, I'm gonna do this payroll processing test. So circles time, saying date.9 divided by 1000, to make it timestamp valid, because we're going to be sending a timestamp into the blockchain. So let's come here. We're going to create a test. All right. So let's create this test. So what does this test do? To successfully process payroll for all workers. Payrolls for all workers. So first thing you want to do is you want to check the organization's balance, before this transaction takes place, and you want to calculate the total salaries of this. Remember, when we are managing workers, we were able to, add their salary, create their salary, so they already have this. So basically, the total salary is going to be that first salary plus the second salary plus the third salary. That is the total salary I was supposed to pay in. And you want to say dot process payroll. And in this process payroll, you're passing in this, this cycle time, the timestamp that you're passing along, but you're using this account partial, you're passing the organization's the authority here and the program ID, which is cool. But there is an extra what do they call it? An extra parameter that is supposed to be passed. Remember that in organization there is something called remaining. Okay, let me try. I'm trying to find that place again. There's something we passed in as remaining something. Let me try to find it. Remain. Where do we have that? Okay, I can't find what I'm looking for right now anymore. So, but let me try my best to explain this. There is a concept called remaining account, which we are supposed to pass in the various accounts, that are also going to be part of that transaction. So we have something called dot remaining account, which is going to be an array. This array will be, I'm still trying to find that. This should be here. There's a way it was defined. I don't know where that is. Oh, I'm in the wrong place. We're actually in the wrong place. Sorry. That's why. So sorry, I'm supposed to be in this payroll. Process payroll. So this is what I'm talking about. Sorry. Now I'm here. Okay, so if you look at this process payroll, there is a concept called remaining account, which is part of the context that you're passing. You're getting it from context. The remaining account should be in this format as described here below. The worker's PDA and wallet account are passed as remaining account. You can see the way I'm going to be passing them now. And they must be in the alternating order, the worker's PDA1 and the wallet, worker's PDA2 and the wallet. So that is what we want to do, So this keeps the transaction flexible for any numbers or any number of workers. So that's what we're trying to achieve here. So for this place now, what we want to do, before we even do this, we want to bring in some workers. The worker want to trade, want to check out their balance. So this is their balance before. Okay. So the public key of the first one is worker 1PD is writable, is signer is false, is writable is true. So you want to do that. And the public key now, is signer is false and public key is true. So I will just copy what I have here and paste, so I won't have to confuse anybody. So this is what we get. The worker PD is signer is false, is writable is true. The same with the public key. So this is for one worker, this is worker 2, this is worker 3, just in the right order and sequence that was described here when we were writing the smart contract. So you need to do this before you even call the RPC. So now that we have that, we need to confirm that that was successful. And how you do that is by grabbing this report, the account of the organization, you get it. The treasury after, you also get it. Once you get that, you want to do your first assertion, aka test. So the first assertion is that the treasury after is equal to the treasury before minus this total salary dot number. Okay, so the total salary when we've deducted it, because the total salary is not, we didn't have to pass it into anything here. It's automatically calculated by the smart contract. But what we're trying to do is that we're trying to equate whether what was deducted from this treasury account is equivalent to the total salaries that we are expecting. Okay, so this is what happened here. But if it fails, say treasury should be reduced by total salary, so the total salary must be equal, right? And once we do that assertion properly, we want to get the balances of those workers after. Remember, we did it here before. So here again, balances of the workers after, after that payment was made. Okay, so the balances before that payment was disbursed, balance after payment was what disbursed. So that is what we are testing for. I think we can just move this here. Okay, so that they'll all be in the right order. So I'm going to also test for this other session. All right, so there we go. We have, okay, maybe let me just shift this here because of the order and the context that we're testing for. This is for treasury. This context is talking about workers, so we don't mix anything together. So first of all, the worker balance after, when you subtract the worker's balance before, it should be equal to the salary of the first person. So this is just mathematics here now. So the worker 2 balance before, after, if you subtract what he had before, it should be equal to what is now in his account. So those are the various things that we do. So if you had 0, basically what I'm trying to say now, if this worker had 0 balance before, and if you subtract that 0 balance before from what is in salary that has now been paid, then he should have like whatsoever that is there, which whatever they paid him. So it's just a mathematics, but basically there is really nothing that was left from his account. Okay, that is cool. What else do we need to test? Let's verify the last paid cycle. So we want to get the account of the workers now, not their balances. So the account, this time, at this point, we're talking about their balances. This time, we're actually getting the account by passing in their various PDAs. Okay. And then we want to test for some certain information. So we want to test for the cycle time. Worker one last paid cycle should be updated to the last time, should be updated to this one here. So that's what is being specified here. So all of these, their last paid cycles have been updated. That's cool. All right, so that is basically, I know that test is lengthy, but that is all that we need to do about that particular test. There's another test I want to run now, and this one is called, let me just bring it up here. So this is called should skip workers already paid in current cycle. So what is going on here? We have the account before, similar to what we did here, similar to what is being done here. Okay, so we have account, organization's account before, an organization, the treasury before. So how much is left, how much they have in the treasury. So, and then they try to pay workers. Okay, and you fetch the organization's treasury later, and you should see the treasury should not change or already paid worker. So the treasury before and after are exactly the same. So this transaction will not incur money. Money will not be spent. I don't know if you understand that, but it won't go through, it won't pay them until the next cycle is met, because this is the cycle that you're passing in. Okay, yeah, and the last time that they were paid, that cycle has not reached. So because that cycle has not reached, if you try to pay them again, not like month has not ended, and if the month has not come to an end, you're trying to pay a worker before the time the system rejects that. That is what is happening this year, and it's all part of the logics that makes for the smart contract. All right, as we already designed it when we're working on it. Okay, I have another test here. All right, so let's look at this test. What is going on here? This test should fail when treasury has insufficient balance. So let's say this is an organization. You create a new organization with minimal fund. We have new organizations, PDA, a poor organization, PDA. Okay, cool. And you create the new organization, and the poor workers, the poor workers, you generate a poor worker, and of course you generate their PDA. Is that you generate their PDA, same thing that we've been doing, system pattern, and then you create that worker, or you add that worker. You add that worker into that organization. A poor organization will produce it's just about equal to a poor worker, right? Because now the worker is subjected to whatever condition that is running within that organization. So you want to make payments now. So we're trying to pay this amount that you're trying to pay. Meanwhile, the salary of this worker alone should be more than, okay, it's about one Solana, token. You're trying to pay what you funded the treasury, sorry, with 0.5 Solana token, which is way smaller than the what it could what you can use in paying that what you can use in paying that worker, okay, the poor worker. So you try to process the payroll by calling this method payroll, and then this is the cycle time that you're passing, okay, and everything seems to be all right, and then you even pass in the right partial for this particular the remaining account. You pass in the correct records, and where the assertion should have failed with insufficient funds. So we are expecting it to fail with insufficient funds. So that is one thing you must note here, because what you're trying to pay that worker, the fund that you passed into the organization is not sufficient to pay for even one worker, right? So this is what we must be aware of. Now let's write another test. I think the last test for this category, okay? The last test for this category is it should fill with wrong number of remaining accounts. So if you're passing in the wrong remaining accounts, it should fail. That's what it's simply trying to say. So let's say you're trying to pay an organization, but you see, remember what you created here. You created a new organization, did that, it's per worker that you actually added. So now you are not using per workers now. Okay, it's not talking about the per worker. So now it's missing two of the remaining accounts. The remaining accounts are supposed to be 3, but you're only passing in what? Only one of the worker. So because of that, it fails, right? And saying missing worker account. So all the workers needed to be passed down if it's going to work succeed. That is the goal. That's the idea, around it. All right. So let's save this and run our test to see. Run test. Okay. So we have problem there. Should successfully process a payroll for workers and you'd skip workers already paid in cycles. That is the problem that we have. So this issue is coming because of something that I may have missed out in the course of developing a smart contract. You see, this is payroll. This is a long process, and in this second pass, you see this place here, which says check if payment is needed for the cycle, which directly affects the purpose of writing these two tests here, which should successfully process payroll for all workers, should skip workers already paid in the cycle. So because of those requirements, there is a step that I missed here. This step is supposed to be about updating, update worker data. You get that? So for each worker paid, we should be able to say worker dot last paid cycle is equal to this current time. So they say worker cannot mutate because it is marked as immutable. So this we need to see, we need to put mutate in front of it so that we can change it. So this is very important. We need to recompile, review, or let's just hope that when we run this test again, is it's going to do the recompilation for us at the same time. So let's run test and see. So it's rebuilding the application, and then before it starts running the tests, okay, you can see that all of those tests are passing now. So those tests are very instrumental. That's why we have to be very careful when we're coding smart contract, because it's very delicate. And also you need to make sure that you have test-driven development. You need to be able to test that smart contract for every of the conditions that you want it to have. You understand? Because if you don't have that, then you're not sure if when you deploy this online, it's not going to produce a bug. So that is it. So we have one more test group to run, which is talking about withdrawing of resources. So in the next part of this video, I'm gonna work on that. That includes about I may be wrong. I think I will have about two more, which is one is Treasury withdrawal, and the last one will be integration and edge cases. Okay, so I'm going to get on with you and continue doing that with you in the next part of this video. Okay, so let's jump into the fifth test group. I'm going to be testing for withdrawal this time. Treasury withdrawing. We have Treasury funding. So let's try and get some things out of it. So the one managing the system, if you put money into something, it should also allow you to take money out of it. But it's particularly also important that the system is secured so that others or unauthorized individual won't come and hijack your work, steal money from you or any one of those. So that's why we're doing this. So of course, this is the withdrawal amount. We'll plan on withdrawing like 2 Solana token. So let's get the first test that we're going to be writing. So this test says you should successfully withdraw from Treasury. So this is the organization's balance before and the Treasury balance for. Okay, this is the account before, sorry, and this is the balance of that organization before, and this is the authorized users balance before as well. So we are trying to observe if there is some form of an increase. You understand that? An increase to the wallet size, that is amount of money that is in the wallet. So you call on this, you access the programs method and call on the withdraw method. In the withdraw method, what you're looking for, you need to pass in an amount. All right, so what we're passing is the withdraw amount, and the withdraw amount must always be in Lamport. That's why we are setting it up this way. Don't just pass in 2 there. You need to pass in the equivalent of 2 Solana token in Lamport. That's the reason why we do it like that. Makes things really easy on chain. Of course, you need to make sure that you grab the PDA, the org PDA. Okay. In case you are a little bit confused where this org PDA is coming from, it's coming from this hook. Okay, this hook, before any test is run or group of tests is run, this PDA is already provided for, and these workers are already set up, so they are there by default. Okay, so that's how we are accessing it from that place. And was the right authority and make the RPC call. So after the call has been successful, that means money has been sent to the right account. Next thing I want to do is to say get the account after, get the treasury balance after, and the authorities balance later. Then you now compare it. So this, this is the treasury after. If we subtract the amount, that means what we had before, I added something to what we have had, before. What we had before, how am I doing this? Sorry. Trying to explain it in a very natural way. So this is what we had before. What we had before in the treasury, when you subtract the amount that you're trying to withdraw from it, okay, then that should be equal to what is left. This was what we had originally. Is definitely larger than what we will have after withdrawing. That's just it. So what we have after withdrawing, which is this, if I subtract the amount that I withdrew from, from that before state, then what will be left should be equal to what is left after withdrawing. So that's just it. And this authorities balance as well after should be greater than the balance of that authority before the withdrawal happened, because he's the one getting credited. Meanwhile, the organization's account is getting debited. All right, so that's just the logic behind it. Okay, so let's test out another situation. So the next situation I want to test out for is this. It's called should fail to withdraw zero amount. Should fail to withdraw zero amount. So what does that mean? We try to withdraw with a zero, so it should fail, assert fail, and that's why it's being wrapped in this try catch, so that when it fails here, we can then attest that failure condition in the catch, in the catch area right here. So we're testing that it has some form of a string called invalid amount, which is obviously what we are looking forward to. Okay, so that is it for that. Now let's also test for you should fail to withdraw more than treasury balance. Okay, so you can't withdraw more than you have. So you say also you get the account of the organization, you get an excessive amount, so the organization's account, that is probably they have two. There's two Solana token there, so you just add an additional one as an excessive amount that you're trying to withdraw. And when it fails with this error as what we are expecting, insufficient fund, that condition we're also testing for it. So that's just what that does. Very simple, straightforward, no hiccups. And let's also test for a condition where it should fail when unauthorized user tries to withdraw, right? So we're getting the unauthorized user sending a specific amount, I just give them like two to Solana token, and then try to have them be the one withdraw from that system and sign the transaction. Then it should fail because it's an unauthorized user. So we throw this error. Basically what we're looking forward to is things such as insufficient fund balance, and all that. Okay, so I think that is it for that group of tests. So let's run this and see how it goes. Save that, waiting for it to be completed. Okay, 20 tests so far, and all of them are accurately being executed. Good. Doing things this way will make your smart contract really more matured. You understand that? So you stand a chance of of not, ignoring something very important. So in the next part of this video, we're going to run um, the last group of tests here, and then we'll move to the next part of this video. Okay, so let's describe the last group of tests. So integration and edge cases, it's used to verify the entire workflow. Edge cases test ensures edge cases don't break the program. This catches bugs that individual tests might miss. So let's get into it and see how it goes. The first test we want to run here, this is a very large test. I'm going to take it one step at a time to guide you. So it should handle complete payroll lifecycle. That is what we want to do. Complete payroll lifecycle. So first we want to do is to create the payroll. Okay. So we're going to say the organization's name will be lifecycle org name. That is the name, lifecycle test. And we want to create a PDA for that particular organization. Okay, so we're doing everything scratch. So once we do that, we want to create the organization itself. We do that, this create the organization. And then the next thing you want to do, you want to create a worker. So we're going to call this lifecycle worker in a way. So we do this. So we create a worker by assigning the key pair to read, and then create the workers PDA, which is the workers account. And after we've done that, you want to actually create it by calling the workers method in the program. So we do that, and that we create the worker for us, and see we're passing that lifecycle org PDA, and the workers public key authority is the current signer and all that. So next thing, after you've created a worker, you want to fund the account. So fund an account, we just use this. So you specify the amount, you want to fund 5 Solana. So I almost mentioned it. Okay, and then you fund the treasury with that amount. But you fund the treasury with that amount. Next thing you want to do is to process the payroll. Okay, process payroll. All of this function you already used to read. Okay, so processing payroll is what it involves. Process payroll. You pass in the cycle time and all that information. Then you pass in the remaining account for number of workers that payroll does have, and yeah, those are important, so that you send it. It's very interesting that later on there's going to be a lot of things that you will see when we start dealing with the part where we're having blockchain interaction from the front end, and the part, especially the part where there is an MCP server that takes care of this. And you can see how OpenAI is going to be working this out, running this thing, supplying all the data without us having to type everything ourselves. Okay, so now we've processed payment. Payment has been sent. Let's withdraw the remaining balance. Okay, so withdrawing the remaining balance, we need to get the organization's account. All right, and you call that, because you want to withdraw everything that is left in that account. That's what we'll say treasury dot, account dot treasury, to get all that. And once we draw everything that is remaining, we verify that the treasury is completely, paid out. So this is what they call life cycle, life cycle / edge cases test, integration test. So you just get that entire thing. It's really cool to have it like that, so that you know that the entire workflow works. Okay, so at this point, you fetch, the account, the organization's account, and this is the final treasury. You know, you expect it to be zero at this point. That's why we're having this. Okay, and we still expect to have only one worker. So that is just what it is. Okay, that's for one of those tests. Let's write another one. Another test. This one is not very lengthy, so I'm just going to paste it one time. So this is what is. So this one should handle PDA derivation consistency. So for example, this is for creating an organization. So derived org PDA, you make sure that it's in buffer, make sure you convert the authorities key, public key to a buffer, and also the name of the organization to a buffer. And once you create that, this is a derived organizations PDA. You want to see this derived organizations PDA in plain, character. It should be equal to this organizations PDA, the original one that we created here. So we want to ensure that it is consistency. I mean, it is consistent in the way it is being derived. But if it doesn't match, we want to say all PDA derivation should be consistent. And then you want to also test for worker and making sure that the string worker is in buffer, the organization's PDA is in buffer, and then the worker's public key is also in buffer. Okay, and you want to compare that with the workers. Remember, this is derived workers address. There's another one that is based on this worker PDA one. So that is how we use in handling or comparing those. So at this point, let's save that and run this whole test one more time to see if everything is working. Okay, this should be the longest, this should be the test that takes the most time to complete. Okay, it took almost 2.5 seconds into this measurement. So all the test cases have passed successfully, and we are confident that this smart contract does all these activities that we have programmed it to. Guys, listen, test-driven development is very important for smart contract businesses. If you're going to be doing smart contract, you should make sure that you are able to test this. You can't guess your way through. This is very important, because even for the most or a seasoned developer like me, for example, you can still miss a whole lot of things and elongate your days in the field or in the wilderness. Okay, you don't want to spend so much time in the wilderness, right? So that's it for this part of this tutorial. In the next part, we're going to dive into what we call we're going to make all these various functions that we've tested, we're going to turn it into a service or blockchain service. It will be from that service which we can then hook it up to the front end. Without this service, it will be difficult to interact with it. I like making it that service because it makes sure that all function calls that are related to blockchain interaction are on one file. And if there is any need for maintenance or changes, then we know exactly where we need to go. So that is one of the reasons why we're doing it that way. I will see in the next part of this video. Okay, so now we need to start coding that script that I told you about. But before that, we need to make sure that we have just have these things up and running. Okay, so these are some script. So don't worry about this. When we need it, we're gonna bring it in. these are the things we need first. First, we need to create a new file into a new folder called services/blockchain.tsx and then paste this. Okay, now this is obviously coming from Anchor. This is coming from that build file. If you come here, look at target, check IDL and check types. So this is where we're getting this. In this from types, and we're getting this from IDL. So take note of that. So those files are available, and this is coming from Solana SDK, the Web3.js for interacting with the Solana, ecosystem. Okay, so these modules are very important, and we need these two packages, two interfaces that you should take note of. Now we need the organization interface. Remember that if we go back to it and we're looking for organization, an organization has an authority, a name, a treasury, a workers count created at and bound. So what we're doing is mirroring those information here as well. So the public key of the organization, the authority, the name, the treasury, the worker count, they are created and above, but everything has to be in camel case. Okay, so that's one. I also want these workers as well. So this workers is going to be taking the same thing. Let's search for worker, okay, from the states. So worker has an organization, which is the public key of the organization, the worker public key, the salary, the last paid cycle, the creator, and the bomb. So if we come here, that's why we load those two. Now I've not created this helper function yet, so that's what I want to create, and I will not like to waste much time on that. It's just, let's create that, create it here, call it helper.ts. Okay, so what does this do? I'm gonna paste it here. This is what it does. We just have like 3 function, exportable function. So the first one truncates a wallet address. Okay, so this is just what it does, slice it, so that in case we want to display the wallet address, we don't display the whole lengthy thing because it's very lengthy and won't be very fitting for our front end. So whenever we need that, we do this. So this one here is called get cluster. These two, they work together, this get cluster and this get cluster URL and the get cluster. So this is how they work. The first one, we have a record where if we pass in, the key, we want to be able to get the URL that's associated with that particular key. If I say testnet, you should get me the testnet RPC endpoint. If you say devnet, you do the same. If you say localnet, you do the same. So it's all based on that structure. So all I need is to pass the name of a cluster and it will handle that for me and returns it. Now, when you do this, it's going to return not the name of that cluster, but the URL of that cluster. Then I want to be able to pass in the URL of that cluster, okay, through this get cluster to get me the actual, cluster name. I don't know if you understand, but they just work together, and it helps us to make sure that if I type in devnet, it just get me the URL of the devnet and will not make me to struggle about it. So I need that, and that is where this comes in. Okay, so now we have that. So let's get busy with this development process. So Hope you understand this. These are just the various anchor tools that we've always needed. So we need some types. Okay. I need a raw organization, structure. It's different from there's a it's different from this. You can see this is more of a JavaScript realm. You understand? We have string or numbers. But this is talking about big number, public key, and all that. So we want to make sure that we have this and everything is displayed as camel case. So this is going to give us the raw version as how it is being pulled from the blockchain. All right. So we also need, I could just do this like this for you to make it a lot easy to track and read through. And we need a raw worker as well. A raw worker, these are matches the data structure for employee record on chain. So this is basically how it is on chain, because when you bring it up, into your work, you need to refine or fine tune it so that it can flow with your, with your application. So once you get that, you want to do something like this, similar to initializing the program. What we want to do is want to load the IDL from the program types, which is, this is the program types here. Okay, so we're going to get that and then give it a type of payroll program, and this type is coming from this anchor type. So we have type, we have IDL. The type has all the information about the IDL, so we just need to make it obedient. All right, because we don't want it to be giving us issues. So the next thing you want to do is you want to get the name, you want to get some details about the cluster. So for example, you want to get the program ID, and how you get the program ID. Remember, this is payroll. If I call on .address, it will give me the address where of that smart contract or the program. So I'm just converting it to public key because it's in string format. So convert it to public key, and that is what you assign to this program ID. Okay, this is the cluster. You grab it from the from the environment variable, or you make it, you give it this default of devnet. Now we need to create that. Come here, create a new file called .env.local. Okay, and you paste this, give it to be local host. You're giving that exact name so that we can match what we will give it, we'll pass in here. All right, so good. And the next thing we want to do is we will use that cluster, whatever is in this, to pass it into this get cluster. Okay, and then to give us the RPC URL. Very important. So that process, and then at the end of the day, we just want to log out these records. Just we log it out so that we know what we're doing. Now we want to define a signer wallet. Okay, let me define it here. This is a signer wallet. It's going to be necessary when we are signing transactions. So we want to have it ready. So a signer wallet is an object. It's an interface that has key to be public key, sign transaction to be a function, understand that, a promise-based function, and sign all transactions also be a promise-based action. So you just a type interface, or is know what to say. So one of the important things before we start doing it, we need two functions. These two functions are going to be serving for different purposes. One is going to serve for read-only purposes. One is going to serve for read-write purposes, okay, but mostly write purposes, but can also be used for read-write, okay. So the first thing we want to do is get provider. Without the provider, we can't do anything, okay. The provider is very important. So how do we get the provider? We say export const provider or get provider to be equal to, this is going to be large, I'm going to break it. Before we get the provider, I need the provider's public key. So it's going to be equal to public key. So you want to give it public key type. Is a public key type or null. So you want to do that. And the reason I'm taking my time to do this so that I understand how it goes. So we say sign transaction is equal to, of course, we're going to give it this. Okay, so we have sign transaction is this type of promise-based, function. Okay, so that is what it is. We don't want to make it null. All right, and we want, at the end of the day, we want it to to return a program, okay, because this is how we initialize the program, and the program must be a payroll based program, okay. So must be a payroll based program or it should return null. All right, so it's looking a little bit messy now. Okay, that's okay, we'll get there. So first thing we want to do, we want to check for wallet if it is connected. Without this, we can't sign transactions, so we need to make sure that the wallet is connected. This is very important in this step. I'm going to remove this, we don't need this here. So to check if the wallet is connected, without this we can't sign transactions. So wallet, if there is no public key passed in here or there's no transaction, say wallet not connected or missing transaction, we need that. The next thing you want to do, you want to validate RPC format, okay. That is what we want to do. You want to make sure that the RPC format is necessary. Say if there is no RPC URL, okay, or the RPC URL starts with HTTP, if it does not start with HTTP or HTTPS, you should say what? Invalid RPC URL. Okay, so that is very important to also check for the RPC. Just being very, very careful. All right, at this point, if that is okay, we then want to initialize the connection. So this is how the connection is going to be. Create a connection to Solana cluster. Confirm commitment means we wait for block confirmation. So in this connection, there will always be a waiting for a block confirmation. So if there is any interaction that is taking place using this connection, it's going to wait for confirmation. So after this, we want to create a user wallet or a signer's wallet. Okay, we're not creating it, basically just modeling it in a way that we can use it to easily sign transactions. So we say passing the public key, the sign transaction, remember we have that, and then this sign all transaction is going to be based on, these two are based on whatever we're receiving from the top here, and then the last one here, which is this sign all transaction, is if we have multiple transactions pushed as one. While I was preparing this, I wish I had, there was a situation where we needed to create 3 workers in the go. So that would have been cool if we just design the system to handle all of that operations at once, so that you just sign it at once. But we had to approve for the 3 different transaction or 3 different worker creations. So that would have been very fantastic to just capitalize on this. So this helps you to add multiple transactions into, but this is just for cosmetic reasons, in the sense that we are not actually using it in that way, even though the wallet itself has that enablement. Okay, so that's what is happening. So this wraps the user signing capability. Create a wallet object compatible with Anchor. Then this wraps the user signing compatibility as well. So just a wrapper. Then what are we going to be doing next? So once we've created that connection and the wallet, wrap the wallet of the user that is currently interacting with the system, then we want to say provider, because all this while I've not actually returned the provider yet. So say provider is going to be equal to anchor, new anchor program, we're passing the connection, which is this, we're passing the wallet address, okay, which is this, the way we set it up, wallet, but you want to pass it as unknown, and then as what, wallet type, and this wallet type is coming from Anchor. So you need to do it like this, otherwise you start having some, really annoying issues. Saying commitment level, you want it to be processed at this level, because if you're able to submit it, there is a very high likelihood that that is going to what, succeed. So processed and confirm are two different commitment level. I don't know which, processed has a lower commitment level, because you first of all process the transaction before it is confirmed, or is it confirmed before it is marked processed? I don't really know which one is. So if you know which one it is, you can drop it in the comment section, okay? And I'll be more than happy to. I know we can just easily check it out online, but I don't want to do it for now. So then at the end of the day, what you want to return is, this is what you want to return. You want to return a new program. Now this program is, you're going to pass the IDL and then this provider here. So this is what you're returning, after everything. So we're having a little bit of an issue saying program IDL is not assignable to program IDL. Maybe I'm making a little bit of a mistake. Let's look at it. Okay, so this is not how it's supposed to be. I'm going to cut this off. Okay, this is how it's supposed to be. So it's either you're returning this program or you're returning a null value. So that's why it's misbehaving. It was misbehaving. Okay, so this is how you get a provider, but you don't only want this one, so want another provider that is called read-only provider. It functions almost similar to this, okay, but the major differences are in the way the wallets are configured, because in read request, wallets are very essential. I mean, in write request, wallets are very essential because of what, signing of transaction. But in read request, it's not very relevant, except that it just needs to be there because a read request in the blockchain also requires what, a public key. So as a result, we're not going to need any one of these. We're not going to need any one of these. We're going to create everything fast. Okay, let's just do this. I'm going to duplicate this and just mix the necessary modifications. So first I want to say get provider, the read only. Okay, so what is this read only about? Let's get into it. So in read only request, you don't want to check for wallet connection because it is irrelevant errors. We don't want that. So we want to check for RPC, of course, and you want to check for, the connection. You want to establish a connection. This wallet is going to be different instead. And remember, we are not going to be using any one of these public keys. Okay, so I'm going to remove this. All right. So now here we need to make some changes. So public key is going to be based on a default public key. Is a public key dot default. All right. And this signing of transaction is not going to be what we're not passing anything there. So we're just going to define it ourselves. And how you define it is through an asynchronous request. So let's do that. Say async, and you do this. You just say true, because you only want a new error, and then say throw new error. Let me write. Okay, I don't think it's vibing very well, so I'm going to bring it here this way. Okay, so it's okay. And then we also want the same thing for the signing of the transaction. So I'm going to replace it with this. We don't need that either. So those things are going to be empty. And then at the end of the day, these ones will remain exactly the same way. Just moving the. So this is faster than confirmed because the commitment is just processed. So that one is kind of answer the question I initially asked. So this is what, whenever I want to read something from the blockchain, we just use this, to get the provider, or whenever we want to write to the blockchain, we use this. So those are the differences. So in the next part of this video, I'm going to be helping you write. I'm going to be writing, just about. We're going to be writing some of these functions, okay, that we communicate with the blockchain. All right, I'm going to write it, do it in the next part of this video. See you next. All right, so let's come here. Remember, we're going to create different functions. So the very first function I want to create is called let's say export create organization. Okay, create organization. Let's work on it. To create an organization, you need some of this information. You need the program, because without the program you can't interact with the blockchain. You need the program. Program is based upon this, not here. Okay, let's do it ourselves. Yeah, we can use this. So you need the program is based on this type. All right, you need the public key of whomever. Let's say public key, and then name is a string. Those are the things you need. And then the type that you're looking for to return is a promise that is based on transaction signature. Okay, that is what you're expecting. So say const transaction is equal to await the program and call on methods, and then you call on create org method, and you want to pass in that name, and then not just that, you want to call on account. Okay, and within the account you want to give the authority is going to be this public key you're passing. This public key is going to be whomever you are passing in here. Okay, you're going to pass it here by default, which is the currently logged in user, and at the end of the day you want to call on dot RPC method, sorry. All right, and then return that transaction. Okay, we can break this into more lines. So this is how it works in a very nutshell. All right, you already understand the drill. So I'm going to just do something similar for add workers. It's going to be a lot easy. So we come here, see, this for adding of worker, you need this. All of these functions are going to be anything that is a write function is going to be needing that. You need to pass the organization's PDA. Very important, because you will need that in order to create a worker or add a worker to an organization. You need the worker's public key. You need to pass it, and then you need the salary in Solana token, and you're expecting to receive a transaction at the end of the day, which is this. So this salary, you need to convert it to Lamport. So that's what is happening here. And then you add workers salary in Lamport. You do account partial. Then you pass in you convert the PD into a public key, because that's how you want to pass it. The workers public key is this, and the authority is the person that is currently signed in or interacting, and then the system program is what we are using from here. Okay, so that is it, and we can proceed to the next one. The next one is to fund treasury. Simple functions, fund treasury. You need these three, and then you need the amount that you want to use in funding the organization. So you make sure it's in Lamport, and then there is a difference you should know between account partials is talking about a situation where we have an existing account, or we are creating a new account based on what is already existing. For example, here you see we use account because prior to this, when you're creating an organization, it is not tied to anybody or anything, creating it completely afresh. But if you're adding a worker to an organization, you see, this is where the account partial comes in, because you have this organization's PDA that is already there. So an organization has an account, and you're just linking that account to that organization, that account of the worker to the organization. So we're passing the Lamport into this method to fund the treasury. We reference the organization that we intend to add this worker in, and then the authority, and then you just sign the transaction, and boom, you're good to go. So that is for funding transaction. What about for payroll processing? This is just going to be a little bit more. So I'm going to take my time to express it more. So this is what we have here. So we're going to need public key. So these three are needed. But the fourth thing we need is a cycle time, which is cycle timestamp. All right. In this cycle timestamp, you need to create a timestamp for yourself. So we do this. Okay, timestamp, cycle time, or if the cycle time is not passed by default, then it should just create one, which is based on the current time. All right. And the first thing we want to do, we want to fetch all the workers for this organization, which is very wise to do. Okay. So we're going to do that, and it's going to, be in an array format. Okay. So when it returns, it's in an array format. Okay. So we'll call on await program account the worker, then you grab all the worker. This returns an array, as in this format, which is public key, an account, which is in raw worker. This is where that raw worker comes into play. All right. Now that we fetch all that, we need to also do this. We need to filter to only workers in this organization. Okay, so only workers, we do filter to only worker in this organization. That is all workers, which is just got the filter for each worker. You want to do that worker dot account dot organization. You want to you convert it to base. It is it equivalent to this particular organization? Does it belong to this organization? If it doesn't belong to that organization, you skip. But if it belongs to this organization, you add it to that organization's worker. Otherwise, you let it go. Okay. Now, after you've done this, you need to build the account remaining array. Okay, so this is how we do it. To build remaining account array, smart contract need all workers account to update their payment status. The format, remember, is PDA wallet, PDA wallet, and standard. PDA is basically account, wallet is the public key. Okay, so you go by account meta, which is one of these record that we get here. An account meta includes public key, is signer, and is writable. So it's basically a type. Okay, a type, and that type is gonna equal. Is gonna be. We're gonna assign. It's gonna be what this account remaining is. So we say workers.flat map. You go through each one of those workers and you give it a public key. The public key is going to be this worker. The public key of the worker is signer is false by default, and because these are not signers, they are just account, and is writable true. So we get that. Okay. Now this is going to look through all the workers, and if there are 5 workers, we're going to have 10 of this. If there are 15, we're going to have 30 of this. So that is just what is happening here. And now that we have that completed, we can then make the call and return the result. So the call, which is the transaction, we call this payroll process payroll. See, the timestamp must be fed in big number. Anything that is number must be translated into big number format. Otherwise, it's not going to translate well on the smart contract. You need to do that, and all this stays the same. Remember the drill. And then for this time, you're adding account remaining, which passes all the workers in here, and then you execute. So that is how you get it done. And we need another one. So we need another function. We're going to call it withdraw from Treasury. The same thing, just amount that we're taking, make sure that the amount is in Lamport, and then you call the method responsible with it, passing in the amount, and then return the transaction. Very simple, no brainer. So these are based on what we call, these are going to be the programs, these are going to be based on read, write, or anything that has to do with write operations. Okay, operation where you need to sign transactions. But then these ones that I'm about to say provide for you, which is fetching functions. Fetching functions don't really require any form of write operations. All right, so let's have our first fetching function. Fetch user organizations, which is equal to an async. You have a program. Remember the public key. So this is just standard, just expected throughout the application. So, but we are expecting to return here. All these ones we're expecting to return a transaction. All right, or here we're expecting to return not a transaction but a data type. So the data type is, for this one, you are expecting to return organization. So it's a promise, and in this promise, we're going to say, we're going to give it a type, not raw organization, but this organization here. Okay, we'll say want it to return organization array. Now, this organization array, we're gonna call the organization. How you get everything? Remember this: the organizations is equal to. I'm gonna put this in bracket. Await the program dot account dot. I'm gonna call on that organization dot all. We grab you all the organization. What as this is how accounts are normally represented. You want it to be represented this way: public key, public key is going to be based on public key type, and account is going to be based on raw organization, not raw cards. Okay, so that's how the account is going to be. Account is going to be having all this information in this raw format. Okay, and of course you're typecasting it as an array because that is what it is. And so once you fetch all organizations, the next step you want to do is to filter only organizations where the currently connected wallet address matches. So only organizations that what you're looking for. All right, so we see user orgs is equal to this organizations dot filter, looking for where the authority is equal to the public wallet, the wallet that is currently connected. And once that is true, then there is this last step that we need to do. It's called serialized organization. It's not yet available, so we need to create it. So this is what serialized organization looks like. I'm going to create a function down below here. Call it serialized organization. Let me break that into. Okay. So this is a serialized organization. Get this an organization, and organization is going to be based on this serialized format, and it returns an array of it. So this is an array of organization that is returning. So we want to return in here, want to return the map of that organization, and want to return an object, an array like base object. So we want to close this. So make sure you do that very carefully. And then let's do this here. So the public key, we're going to make sure we convert it to base. This 8, authority the same, name remains the same, treasury, make sure that is in what number, and you divide it by 10, the exponent of 9. So you divide it, you reconvert it from Lamport to a regular number. That's what it's doing here. And then the worker count remain the same. You make sure that it's a number. The created timestamp is a number, or you give it 0. And then the bump. So these are very important. Then at the end, you just want to sort this. Okay, you want to sort it so that the most recently created ones will be at the top. So the most recently created organization will be the one stacking on the top. So we are sorting it based on the timestamp. Okay, so the most recent one are the top ones. So that's what is happening there. So we can take this and say return. So you see return, convert raw blockchain data to UI friendly format. So we pass on this organization into this, and it will format it for us and return the result. That is what we're talking about here. So that's for fetching user organization. Now let's fetch another all organization. This is us fetching all organization regardless of who owns it or not. So it's basically the same thing here, except that it doesn't have this part. So This is for fetching all organizations. Now, what about fetch organizations details? So fetch organizations detail. I'm going to come here, copy this. Okay. So you see that it's not returning an array of organizations, but just one organization. That is what it's returning. So it's going to need the PDA of that organization. It's going to, if it's going to return it accurately. I'm going to copy this part and just modify it a little bit. I'm going to call this org, right? And say account dot organizations. We're not getting up, but we're fetching fetch, the organization PD. Okay, so that's how you get it. But to be more secure, you need to make sure that is a public key. Okay, so you get it, and then the result that comes to be as raw organization, just a singular form. All right. Now, once you get that, you want to serialize it. So basically, what you did here, you want to do it here as well. So this whole thing, you want to say const serialize is equal to this, or you want to remove all this. The public key this time is just going to be the same thing as this, because that's the public key of the organization. So you want to be this PDA. Then this account, all these accounts, we're going to remove them because we don't need to that depth of checking those accounts. I'm going to remove that. Boom. So this is what you get now. This is serialized organization. Now, once we've serialized the organization, what do we need to do is to return the serialized, just return the serialized, and that fixes the problem. All right. So what next we need to do? We need to get the workers of an organization. So you need, these are what you need. You need this organization, and the PDA of the organization is very important. And then you're returning a promise of worker array. So you're returning multiple workers. You can just copy this line. I'm trying to make things a lot easier for you. So you can just call this workers, and accessing the organization column worker, and then say fetch all, and this should be now raw worker. Okay, so this exists, raw worker as a type. Okay, so that is it for that step. Now, just like you have here, you want to filter, so let's do filtration here. So in filtering, similar, I'm going to just copy this and paste this way. So organizations worker, you want to say that all workers. So all workers dot filter, and you're checking the organizations. The workers organization is equal to this current organization. If it is true, then it should remain, otherwise it should be discarded. And then of course we're going to need to write a worker serialization algorithm as well. So I'm not going to type everything like I did here, because you already know the drill. The drill is this. I'm going to break this down a little bit. I'm going to break it down so that we have a stark resemblance with the other one. Okay, so we have serialized worker, which takes a worker array, a raw worker array basically, and once it takes the raw worker array, it loops through it and format it, prepares it in a way that it will be UI friendly. All right, so that's just what is simply happening here. And once you get that, once that is so, you can then return serialize. Make sure this is the one. So you return this, you pass this in there, and that is it. That is just the process. So you'll be able to fetch all work, the organization, the workers that belongs to a specific organization. And now, what if you want to fetch an organization's details? I think we can just easily follow from this step. Let's, clean it up a little bit. Instead, what you're looking for is you want this worker, fetch worker details. So you're looking for the PD of the worker as what you use to get the worker's detail. And then this is not what you're looking for, of course. So you're looking for worker, call it worker here. And you want to pass in this worker PD here. And you want to return it as raw worker. Okay. So then you have to serialize it. You can serialize it. It's very simple. So you just do this. So the public key is the worker PD, the organization's key. This is worker.org.pd. So and then you format. You just make all these things well formatted, and then you return the serialized value. So that is how you get worker details cleaned up and ready for usage. So what else do we need? We want to get fetch workers by wallet. Fetch workers by wallet. So to do that, so you're also going to be returning an array of wallets, but this is just wallet public. So these are your public wallet. You want to get all workers, that's for sure. So let's see, want to get all workers. Okay. And I think it's just the same thing as we did here. Okay. It's just the same thing. There is not much different at all. So in this step now, I think this is where the difference lies. So user workers, you're checking for where the users, the account organization's public key is equal to the wallet address, this specific wallet address. Okay, so that will mean these are the workers belongs to that user, which is basically the organization. And of course, we can't compare with this. It has to be this thing called worker public key. Okay, so what this means is that if a worker came into this platform and then connected, they want to be able to see you want to be able to read their records if they want to be able to read their records if they are in a specific organization or not. So these are just some interesting additional context. I don't think we're going to be using this a lot in this, but you understand that there are situations where this is needed. Okay, so we want to be able to calculate the next payout. Want to calculate the next payout, the next payroll date based on a cycle, each month, weekly, and all that. So calculate the next payroll cycle. The cycle type could be weekly, bi-weekly, monthly. If it is weekly, you understand, you do this switch, then you set the date, the next date to be with an additional 7. If it's weekly, bi-weekly, 14 days. If it's monthly, then you have to set it this way. So we're just using this to calculate the next payout date. Okay, and you can use this to check payroll due. So you want to check if a payroll is due. And this is just going to be useful by just, you know, when you call the payroll, the AI can help you to read information about the payroll if it is due or not. So you get the workers of that specific organization, and you pass the program and the organization ID. Get this current time now. And then you get the circles, and what you're doing is this worker due? So you filter through the worker and compare it, okay, and then you check the organization's workers, the last time that they were paid, and if you subtract that last time that they were paid from the current time, then that if that last time that they paid is greater than the cycle, this is called cycle in milliseconds. Cycle in milliseconds. So you just pass in the cycle type, which is whatever was also passing here. Then if it's due weekly, bi-weekly, monthly, or whatsoever, okay, so otherwise the default is monthly. All right, and then it will get you only workers that are due for payment. So it returns the due workers, the count, and then it also returns you an array that contains those workers that are due for payment. So that is what that entails. Okay, next, we need to be able to find organization's balance. Very simple function. So you pass in the organization and it so you call on this org, account organization, then you fetch that public organization by its PD, and then you get the raw record. Then what you're looking for is how much that is remaining in the treasury. So that solves the problem, and it gives you the balance that an organization does have. So we also need another function to calculate total payroll cost. So you fetch all the workers that belongs to a specific organization. What this does is to sum up the entire salaries of all the workers. Okay, so that's what it does, and it just returns it for you, period. Okay, and let's do, I think we have two more functions and we're done. Is to derive organizations PDA from authority and name. Like I said, most of these are not really necessary. We don't really need them, but I think it's a good thing for you to understand how they work. So for you to derive organizations PDA from authority and name, so you pass in the authority, which is the public key, and then the name that is using deriving an organization's PDA, using this format. And lastly, you can also derive, organize a worker's PDA using this method through the worker's PDA, through the organization's PDA and the worker's public key. So these two, and then you use that to convert this to buffer, convert the PDA, each one of these PDA to buffers as well, and then you pass in the program ID. So those are all functions that is required, to interact with our blockchain. So basically ready now. The next thing we're going to be doing is to integrate this to the interface and start communicating with it. We start seeing it in action. So we'll start by doing that from a test interface first, and after we've locked it down and we are sure that it works, then we can move forward to we will now build an MCP now. So all these functions we created will then be arranged with that MCP tools. There will be like tools to the MCP, which the MCP will then make available as tools to OpenAI. So these are just the flow you just understand the flow of what I'm doing here, it will be easy for you to build any application where it needs an LLM to interact with the tools. So in the next part of this video, I'm going to show you how that works. Okay, so it's about that time that we connect what we had done to the front end. Okay, and let's do this first. Oh, well, hold on. Okay, let's do this first, and let me show you what I'm talking about. Okay, let's open this in the browser. Closed. All right. Let's come to this playground. Okay, so this is where we want to work on. This place is basically a provision for helping us to test out our smart contract. Currently, there is nothing. This is just the behavior. Okay, these buttons are not working yet. They're just dummy buttons. Okay, so we're gonna connect it and have it all functioning. So that is it. So if everything works out here, then we know that we can hook it up to the LLM. So that's the purpose of this. We're gonna hook up all these buttons together. And to get that started, we need to spin up what is it called, the Solana validator, which is the blockchain, local blockchain for Solana. So we need to start it up. Solana-test-validator -reset. Right. So once you get that functioning, you come to your code. At this point, I'm going to set it into Anchor, and I will do Anchor. We've already built Anchor, but I'm just going to rebuild it. Okay, I'm saying Anchor deploy, and this should push to the local chain. I have an error here. So it have an issue, and we don't know exactly why that issue is saying it's having problem with the program ID probably. So because program ID is a little bit different, come to this Anchor, find out that this program ID is different here. So what we're going to do, let's try replacing this with our program ID, this one that is generated, and see if it solves the problem. Also need to look at the smart contract, and let's give it this, and let's build, and let's deploy. Okay, you see it was successful. It had deployed successfully. Okay, so that was successfully deployed. As you can see, the keys are the same. Look at the key here and look at that key, the same, and it's the same with the smart contract key here. So we're good, and this has been deployed. We can actually check this on the browser. You open, this is one of the things that is cool with Solana blockchain. I could actually just toggle to custom URL, and custom URL of course is going to be this 8899. That's the port, and I could just paste this, check the key, and now okay, so you can see that this is the smart contract that was deployed 4 minutes ago. You see the transactions that were carried out there, and these are all the things concerning the smart contract. You can even see the upgrade authority, which is talking about the wallet address, the default wallet that is responsible for deploying this, or the transaction fee was charged. So those are the things you need to understand about deployment. So now that you've deployed this, you can now go back one step and do yarn dev to start up application. And now that the application is started, the thing we need to do is to come to this here, is to come to what's it called, application, then playground. All right, application playground. Now this playground has already been designed. We're not doing any HTML related stuff here, HTML or CSS. We're not doing any one of those. All we're doing is just hook up the functionalities. If you want to develop a project yourself, you have to work on the front end, which is all those design stuff, the UI stuff, which you can do on your own. It doesn't take much, but if it has to do with blockchain, I normally just narrow down the teaching to the essential and the most important thing, which is to make sure that the functionalities are working. So we have multiple steps that we need to take care of here. So we're going to have a lot of steps coming. And now I would like to import all the major functions that we're going to be using in this application. So these are the functions that we want to incorporate into our application. I have all this, okay? But what will happen is, we can just keep it like this so that it will be easy for you to read through for each one of these. So this creates a program instance with wallet signing. Meanwhile, this creates a program instance without wallet signing. So those are two different ones. So let's get into the meat of this project. That is the first step, that you need all those packages, but you don't necessarily need them immediately. You can always auto import them as you in any place that you're using each one of those components. So the second step we need to do is to add wallet hook to the component. So we'll replace the component function declaration. So this is let's come here. So this is the current, declaration, which is talking about all this information here. It's okay. We're gonna upgrade it. Okay, I'm gonna upgrade it, and let's upgrade it here. I'm gonna need to bring in this. So this hook is actually a wallet hook component. Sometimes it doesn't auto import, so I have to manually import it. It will have information about the public key that is currently connected, and it will enable you to. You also have this transaction function, for signing transactions. Very important. So we need those. So we need to import this wallet component, and we import it from the import from Solana /wallet adapter React. Where are you? So what are we importing from here? We want to import use wallet. Okay, so next time I'm just going to copy and paste that, but that is what it is. So we imported that. It's now available, so we can use it for carrying out our operation. So that's a step. So this step is very important. The wallet hook. This wallet hook gives us access to the connected user's public key and their ability to sign transaction. This is really required for any state changing blockchain operation. State changing blockchain operation would mean, adding workers, creating organizations, paying out workers, making withdrawals. So that's why this there. So the next step is we need to update a function called this test create organization. create organization. So this is the function that is responsible for doing that. So we need to update that. Okay. So what are we going to be updating about it? The first thing we want to do is to place a check at the very top. So right here we say check if wallet is connected and can sign. So that is very important. So we make sure that public wallet is available and the signed transaction is available. Otherwise, you will add a log saying, please connect your wallet first. If you look at this add log, is a function here, okay, that is used for some, operations like to display logs right here. All these logs that you're going to be seeing here, these are various logs. So that is how we're using keeping tabs of it. So right here, we'll come back here. Now that we've checked, the next step we want to do, we want to set loading, set loading and the creating log, set loading, create log. So this is what is happening now. And once we do that, the next thing we want to do is to come here. That is before we even log out this creating organization, we want to set this up here. So this is new, get the program instance that can sign the transaction. This requires both the wallet connection and the signing capability. So you see this, let me open this again. So this is the function that we're dealing with. We need the public wallet address and the signing transaction. That is the two things we're passing in down here. So that will give us the program's instance. Fantastic. Now that we have the program instance, we check if there is program, but if there is no program, we say fail to get program. Very important. Now after doing that, we want to modify this. We want to actually make the call to the blockchain. Okay, so I'll make the call. Now we call the actual blockchain function instead of generating dummy data like we are doing here. We're not going to be generating any dummy data. We're just going to call the blockchain, and we're using something called test data, which is a use state basically that has information about the name, whatever random name that we're generating. Because if you look here, there's a function that I'm going to bring in back later. That function enables one to generate fake data. Okay, so but just understand that these are things are form records that we are having access to by this testdata.org, and you can see that here by this test data. Okay, so and send the transaction to Solana to create an on-chain organization, and whatever comes back is going to be stored in this EX right here. Okay, we're waiting for it because it's an asynchronous request. So after doing that, I'm going to replace this here. Okay, so what is happening is that we're going to calculate the organization's PDA. Okay, then this is the deterministic account address where the organization data is stored. This is the formula, which is a hash of the program ID, the organization, keyword, the authority, and the organization's name. So that's why we're passing this derivation PDA. Is this function is used to derive organization's PDA, passing the authority and the name, and it will just derive it for us and return the public key, which is what we are expecting. Okay, so we have the PDA here, and we use that PDA to set test data, to set the test data. So we set the test data, so that we can further further work with it. For example, there are some things wallet address for organization will be PD of the organization will be auto filled here, and we can then do things like add workers to it, which will then appear. So it's going to help us to do all those things. And then at the end of the day, you want to log out, the records, the information, whatever thing, which is the result. So I'm just replacing this organization created with this transaction, which is the transaction key here, and the PD of the organization. Okay, so we do that and we are good. So at this point, let's save that and try it. Let's say create organization. See creating, and it launches this wallet, and now requires me to prove. Now I need to cancel the produce error and make sure that you click on your phantom wallet. Okay, I need to come here, click here, go to settings, select developer settings, and for Solana, click Solana, toggle from devnet, not testnet, to localnet. Very important, so that we can interact with this application. So I want it to be in localnet, just confirming. So localnet, great. So there you have it. Disconnect, reconnect. All right, collect this. Now let's create that organization again and say fail to simulate result this request, confirming and save. We confirm, and it's saying that organization simulation message, so it failed. There's a reason why it's failing, and I'm going to show you soon. It is because this wallet has no Solana token on the dev net. So if I copy this wallet address, come here, check the balance here, you find out that it doesn't have any record here. So we need to get it together. We need to add something to it. So this is how you transfer some token. I'm going to open another instance of this terminal. So if I say Solana balance, I have this almost 5 million or thereabout. So, but this particular wallet doesn't have anything. So this is the wallet Solana balance. This wallet, and want to specify. Let's try it first. It has 0 Solana token, so it cannot create the organization for us. So what we need to do instead, to say Solana transfer, and you paste this, how much you want. I want 100 Solana token, and you want to say that dash allow unfunded recipient. Okay, and you do this. I'm not going to add, you have the right to add URL, you can say HTTP, so the particular chain that you are looking for. But this isn't, necessary, because my default, what's it called, blockchain has been toggled to be local net. So by default, I don't need to add that last step, which is this part. But I'm just doing that in case. Okay, so now you can see that I have 100 Solana token here, and if I should check this transaction that occurred on the chain, if I should refresh this page, find out that there is a transaction of 100 Solana token. So that particular wallet should not have some token, but normally it doesn't get listed here, because this is local connection, so this is local connection. But let's try it again now. Say connect, confirm, and see that it was not successful. Created that, and you can check the transaction here. You can see that transaction was successful, very fast, confirmed. This is the entire operation that took place. And you can see the logs that happened. The log is that instruction is creating org. And you can see organization tech corp created. Very interesting. So we can see that that works. Fantastic. So let's integrate other distinct abilities, because only one button is working here and we have many more to go. So let's get it done. And for test for that, we are done. Okay, so we need to add workers now. I'm going to search for add worker, this function called add worker. I'm going to close this one that I'm done with. So in adding workers, these are the things you need. Because the same step, you need to make sure that this key, you have your wallet connected and you have everything there. Otherwise, you shouldn't proceed. And okay, you set this loading to be add worker. Fantastic. So now you of course need to get that provider again. All right, before we proceed, first step, get the provider. And once you get the provider that can sponsor the operation, if this is going to be like in a family setting, this should be the father, that is making the provision that sponsors the operation of the family, So going back here, we then need to address this. Listen, currently now, the worker public key or this operation is, this part of it is actually random dummy stuff right now. So we don't want any dummy stuff. So I'm going to, change it. Okay. So how we get this used to be random keys, but let's change that now. So what we have here is that we convert worker's address to a public key. So remember here, when we created this organization, you see how the PDA of that organization automatically appear there. So that will become available in the course of us using this, because we're going to be generating some PDA. So there you go. So if it's saying that if we have worker address, currently we don't have any worker address, then it needs to generate a new one. I mean, if you already have one, you should just convert it to a public key. Or if you don't have any, you should import it. So this is not yet available there. So we need to import that key at the top. And you get that from Solana Web3. So if you come here, we'll go back here. So that error is gone, right? So we then have to use this. So if user didn't enter an address, generate a random one, for testing. So the salary also need to be specified. But if you look here, by default, we have salary that has been set to a default of 0.5. And the funding amount for that organization is also being set up. So let's get moving. So the next thing I want to do is to perform the transaction. So after adding worker, this is where transactions are done. Right now, this is dummy PDA. We're just using that in form of adding a transaction. In fact, no transaction are added yet. So let's add a transaction. So send blockchain transaction to add worker, program instance. These are the parameters. Program instance, public key or organization's owner. This is the organization's address, which is the PDA, and this is the worker's address, and this is the amount. So it will be converted to convert string to number because it's in string format. So that's what is happening here. And once that is successfully done, we need to convert, it to worker PDA. So here we need to do this. So we say calculate the worker's PDA. Formula is program ID, worker, organization, and worker public key. So see what this is what is going to be passed, and then this function is actually coming from here to pass the organization's PDA and the worker public key, and we generate this for us. Now the program ID is not going to be passed by us because we already coded it as part of that operation. So once we get that PDA, we can use that PDA to update this record. So instead of dummy PDA, we can use worker PDA, convert it to a string. So, and then we're good. You want to make sure that you actually check this properly, right? So that you log out the right records. Now, if I click on this add worker, there's nothing actually working so far, or it's just the dummy stuff that is happening here. And see worker added, but really there is no worker that has been added. So let's save that. Okay. Otherwise, it should have shown me a wallet to confirm it. So I'm going to say click add worker. You can see the way you just pop that. Click on confirm, and worker was added. All right, to confirm this, we can check it out here. So the instruction for adding workers was successful. You can see that a random, workers address, which is this, was added to the, with salary of 0.5 Solana token. Pretty decent. Okay, so we have three more buttons here. So let's get those buttons running. Let's be a lot much faster at doing this. So we're going to fund Treasury now. Close this. Let's fund this Treasury. The drill. I don't need to explain myself here anymore, which is for setting up stuff. So, and we need to know the drill of getting the program's instance. We don't need to explain ourselves there as well. Okay, so you know that what comes next is to carry out the transaction. Okay, so there is a transaction for funding wallet, and the next drill is to make sure that we log out the information accordingly. That's cool. Save that, and let's fund this organization with a 10 Solana token. So say fund Treasury, and click on confirm. It happened. So let's check it out here. Okay, so this transaction went through, and you can see that in this transaction, this amount of tokens, which is 10 Solana token, was sent from this wallet into the smart contract, into that organization. Sorry. So because this is the organization org, if I come here to this org and see that org now has 10 Solana token. Very important. So that is it for that. What next? We need to update payroll processing. Is another function. So which is this function here, payroll processing. So let's look for it before we proceed. Okay. So this is the next thing we need to work on. The drill here. No much hassle. Everything is just almost repetitive. So you know how it works. I'm gonna grab the instance, and I'm gonna make the payment. Process the payroll. Okay, so fetch all workers for this organization. These are things that this function does behind the scene. It's going to fetch all workers for this particular organization. It's going to check each worker's last payment date. Then it's going to transfer salary, which is in Solana format, from Treasury to the worker's wallet. Those are the things it does. All right. And at the end of the day, you just want to log out this, information accordingly. You save that, and if you click on process, please say process payroll, and you click on confirm, and boom, that happened. So let's look at it and see what happens. So when we look at it, you find out that this particular address received money because there is only one worker inside, so that worker received their money, which is great, and everything is all good. So money was debited from the organization Treasury. It used to be 10, but now it's 9, and then funded to the dummy or default wallet address. All right. So one more button, which is response for withdrawal. So let's test withdrawal now. Okay, this is withdrawal. So to withdraw is pretty simple, just as we've been doing with the other function. Make sure that I have this there, and you have the instance of that smart contract or program, as it's called, and then after this you actually perform the withdrawal here. Okay, this is what the withdrawals do under the hood. Only the organization's authority can withdraw. You need withdrawal wallet, organization's address, and the amount that you're trying to withdraw in Solana tokens. So once you do all that, you should get this. All right, and then at last you log out the information correctly. Okay, so let's withdraw 2 Solana token, or let's say 4 Solana tokens. Click withdraw and see that is intending on withdrawing 4. Confirm that and see. Now, okay, looks like that record has been removed for now. Let me do this instead. Copy from this wallet address. Okay, so this is a minute ago. What happened? About 4 Solana token was transferred to this account, as you can see here. Just a little token was removed out of the virus stuff. So all good. So in the next part of this video, we're going to be dealing with the read-only functions. As you can see, for every one of those activities, it was only with the read-write function or the write function, provided that sponsors occurs on the occurs on the wallet to be signed before money is moved. Right now, there's nothing these other set of functions do. Okay, so we need to fix that. So for displays, we have 8 other functions that we need to work on. So let's do that in the next part of this video. So let's get to this user fetch. All right, so this is where it is. So let's get it together. You see, this time around, we are only interested in the public key, not the signed transaction, because we only want wallet connections. Right. So we don't need to sign any transaction. And this time, we are not doing that thing where we have to check. Okay. We need to, I think we need to also do that. So right here, I'm going to get the program. Okay, and also want to do this as well. We don't want to do this because we don't want to do this since it's a read request. We just want it to don't want it to spoil the flow of our work, by introducing some rigorous things. So, but one way or the other, if it's not there, if the program is not there, it's not going to proceed. All right. So now we need to fetch the organizations, the users' organizations. Users' organizations are all the organizations under that user. So that is where this comes from. Okay. So we get that. This is read-only operation, as you can see here. So the program coming from here, going to here. Now you can see what is happening. This is why I said we needed to do this. This kind of provide a form of security to make sure that the program is not null, because it is freaking out that this could be a null value, you know. So let's try and add this here. You can see the way that error disappeared. Okay. So the next thing you want to do, you want to calculate based on the number of organizations. So instead of dummy orgs, you are using actual orgs. So found this number of organizations, and then you do your for each loop. Okay, and yeah, there you go. For each loop, you loop through each one of them and you add the name of the organization, Treasury, Solana work, and all of those things. So that is quite important. Let's save that and see. Let's see, click on my orgs. Clean this first. My orgs. You can see that we found one organization called TechUp, and this is how much that is currently on that, organization's treasury, and this is the organization's PDA. Okay. PDA sounds like public display of affection, but it's program derived address. There's not the difference. Okay. So now let's come here. There's many more functions that needs to be, taken care of so that we can proceed to the next level or the next step. I'm going to copy this line. Let's paste it here. Okay. And let's get the organizations. Just the same way we've done before. So we'll get the organization and we log it off here. So that is what it is. Grab the organizations, all of them in the platform, and then just list them all here. Very important. So that is for setting organization or fetching all organizations. Let's do other ones. Okay. Next one is talking about fetch organizations details, which is this. Okay, and we want to do the drill, and in this drill we're gonna get the organization details, and then we'll display each one of the records that's associated with the organization. As where you have this, instead of dummy, we'll now have this. Okay, so that is how you do it. See, everything is just pretty straightforward. You're just talking to functions that you've already worked on. So the next thing you want to do is update, that is fetch organizations workers, which is fetch org workers. Now you want to make sure that you get that, and you get the workers, and then you format and display. You get the workers, then format and display it. There you go. Boom. Everything is just the same structure. You understand that? This form, this test data selected organization is just referring to this key because all the data are stored in this form here. What else do we need? Fetch workers detail. So we're going to fetch workers details. We're going to do the same thing, fetch workers details. No, sorry, fetch organizations workers, not this one, fetch workers details. Yes, right, this one. And after you fetch that, you want to get the worker details, and then you display their information. Okay, so we're going to fetch the workers detail and display their information such as salary and last paid, correctly, not from dummy test data. All right, and once you've done this, we're going to write another function which is fetch worker by wallet ID, by workers, fetch workers by wallet. All right, so it's still the same, construction. Okay, so while we get this, we want to make sure that we're getting it is currently connected. Okay, so it is connected before you proceed with that. The reason why we're not currently connected to these other ones because they are based on this provision. Before you get to this point, it means that you already had connected your wallet address. So that's why we're not including it. For this one here, we need to make sure that we have a public wallet address there. Okay. And you grab the workers. When you grab it, you format it and make it available. Grab the workers, select and make available. Boom. This is what you get. Okay. And now this is first, check for payroll due. If a payroll is due, okay. This one already has this validation sequence. I don't need to do that again. All I need is to bring in this, okay, and then we will make sure that we grab the workers, the result, the payroll result, and then we determine if it is due. We do that. If it's not due, we do this other one. So this is what is happening here. So the default is monthly. So we're doing query the blockchain to check payment status for all workers in a specific organization. Now the function checks each worker's last payment timestamp versus the current time. Cycle type, which could be weekly, bi-weekly, monthly, determines the payment frequency. And then what is returning is the due, which could be true or false, okay, and the number of workers, list of workers needing payment. So that's what this function does, and that's what the result that comes, does. And then if we check if result is due as stated here, then we want to say payroll is due, and then the workers, you due, and then you show number of workers that needs to be paid. Otherwise, payroll is not due yet. Okay, so that is how you deal with checking for payroll due date. And now the next thing you want to check for after copying this, you want to check for get organization, let's get organization's balance. So come here, get the organization's balance, and once we get that, we get it, and then just log out the balance. This is dummy balance right now. We want to get the real one. How you get the real one is, you query the blockchain, returns number representing the balance in Solana, not in Lamport, right? And then just display it for you here. Okay, let's move on. All of this is just pretty simple and straightforward. So you don't need much hassle to, to cope with it. So this helps us to calculate the cost that it will take to sponsor or pay the workers. So you want to do this, okay? So before we have dummy cost be artificial 101 10 tokens, but now you're getting the actual payroll cost, and this is how it does it. Queries the blockchain to sum up all worker salaries in an organization, and then this shows how much so is needed each each in the cycle. Returns number representing the total number of salary cost in Solana tokens. Then you now display the result as well. So basically, those are all the functions that needed to be worked on. All right. So save that, refresh. We can see get all. Let's see. You can see that it fetched all the org and this one is there. That's pretty great. Okay, so let us look at this line 756. Very funny, 756. It countdown. Not countdown, it's not countdown. Yeah. So 756, saying that this ID is not unique. I'm gonna add this I and just do okay. So that should solve the problem. Alright, get all orgs returning correctly now. Let's try to do everything from scratch. There is something here that is missing that I'm trying to bring back. Okay, so let's say we want to create another organization. How you do that? This button kind of provides that window for us. We can just click on this button here and it will generate a new stuff for us. So let's say we're good with this. We can call this Amazon. And now let's create that organization. Confirm. Organization created. You can see the PDA here. So let's fund the organization and funded. Let's add worker. Okay, add another worker. All right, add another worker. It's 3 workers. All right, and then start adding workers. We can now do check organizations record. I'm going to clean this. Just leave it like that. So check my record. You can see the record now contains 2 organizations, which is TechUp and Amazon, which have 3 workers. TechUp has 1 worker. All right, and check this current organization's details. I'm going to clean up this place to make it easier for us to follow. To do that, you can see the current organization have 3 workers. Treasury have 7.5. The name is Amazon. That is just what it is. What about its workers, organization's workers? And find out that it has 3 workers totally. So each worker is paid 1.12 Ethereum Solana tokens. And let's check my workers. Let's see if it's going to be up to 4. In my workers, that didn't quite fetch it correctly. No issues. Let's check payroll due. And payroll is due, for 3 workers. So, and let's check the payroll cost. You can see that it's going to cost us around 3.3 Solana token. So let's make that payment. So let's process that confirm and payment is processed. Let's check it out. You can see the number of workers were all paid equally. Great. So now let's check this payment due, payroll due. Payroll is not yet due because the cycle has changed because payment, these guys have been paid. Okay. So what about organization's balance is about 4.2. My workers, that particular function, that particular operation didn't get us what we want, but it's okay. All workers, so all of these buttons are working, except this one doesn't just get us exactly what we want, but it's not very instrumental to what we want to do. The only one that we need to do now is withdrawal. So we've tested it before. We are able to withdraw. Let's withdraw 2.5. Yen, and there you have it. So if I check my balance now, it should be 1.7. So that is how it works. So we are sure that every single function that is important in this application has been tested and they are working and they are good to go. We don't have any issue when we integrate it into the LLM. So in the next part of this video, we're going to be coming here, exactly this place. We're going to start displaying all the record here and communicating with our LLM. I'll see you in the next part of this video. Okay, so now let's get to the next step. I'm going to close all these things. So let's open the dashboard page, which is here. All right, let's go to that place on the browser. Okay, so here it is. I'm gonna close, refresh. Let's launch this. So this is the place where we want to be. There are some things we need to do. First of all, we need to make sure that these records are correct. They are coming from the blockchain, and this also is correct. It's not dummy. Right now, everything looks dummy, so we need to, make it non-dummy. Okay, so let's jump into the program. So this is the page for the dashboard page, but we're actually going to be working with this dashboard component as primary one, and we're also going to be working on chat panel a component and also organization panel component. So those are the various components we're going to be working with. Just follow me and it will be all good with you. So the first thing I want to do, if we look at, I'm going to search for it, or has this is dummy. This is very instrumental. So when you come to this use effect, we're using this to determine if the project has a, what is it called? It has an environment key for OpenAI. You understand that we need that OpenAI, key in order for us to utilize this. So I'm going to open this. Currently, we don't have OpenAI key here, so we're going to bring it in. Now, it should be noted that we're going to replace it, replace it with real content. Okay, so now it should be noted that I'm not going to I'm not going to expose this key, of course. So one of the things you must know is this is OpenAI, right? And this chat feature that is going to be used here, this chat ability, it can be for Gemini, it can be for cloud, depending on whichever you want. But since this particular OpenAI is very versatile, it's very, is used by a lot of people, and and I actually have some free tokens on it from a subscription that I did, or some purchase that I did quite. So I don't have for cloud. Otherwise, I would have used cloud. You can also use Gemini. They have this free quota which you can also use. So that is very important that you do. We need to head to OpenAI's API website. So look for OpenAI API. So we need to get there, search for it. Okay, you come here, or you can come here, look at this, create an OpenAI key. And of course, if you're not logged in, you'll be required to log in. So I'm gonna log in. This is where this is different from the main chat interface. Okay, remember, whatever LLM model that works best for you, you can use that. You can even use what's the name, DeepSeek, or just make sure that whichever model you're using has function calling enabled. Function calling, if it does not have that ability to call tools which are functions, then it cannot work with MCP development. That is very, very important, and I can't overemphasize this. So here we go. So these are my various keys, that I've created. So you can create new one by simply clicking here and type whatever you want to type here and create a new key. Then you copy it immediately. When you copy it, you bring it to your application and then you place it in replacement of this. So now I'm going to bring the one that I'm using, the key that I'm using, and replace it here. But I'm going to pause the video and do that. But just know that I've done that. Okay. So I've done that, replace that. So I can move to the next step, which is to actually make sure that I'm getting that key from um, the back end, from my environment variable, rather than just putting a dummy stuff here. So this is the OpenAI key. Check if the API key exists in environment. This reads from this local here, right? So done my own as the first step. All right. So this double pound symbol that we put in the front is making sure that it returns true or false if it is present or not. Okay, so that's what it means. Now we need to modify this line that is producing dummy. We need to use an actual public key. Okay, so first of all, I'm going to find everywhere that I use that dummy public key and then use public key, because I'm going to make a replacement now, because there are many places that it's being used. So I want to make sure that it reflects in all of those places at once. So that's why I'm doing this. Where are we? Okay, so here we are. And let's replace it with this information. So I'm going to do that one time. But before I do this, in order not to get confused, all right, I'm going to import this. This is what we want to actually use. We want to use this dummy key, this public key that is coming from the connected wallet address, and then we want to get or import that from here, from this location. We can bring it up here. So use wallet. Okay. So now let's replace dummy with that. We'll replace it for every place that it is found. Boom. There you go. And then you can remove this one. Good. We are in good condition. So that will make sure that this current version is now making use of the currently connected wallet address, which is this one here. Great. So the next step I want to take is there's a function called, let's look for that. I'm looking for an area where messages are initialized. Okay, so let's find the location where messages are initialized. So let's look for the dashboard. Okay, this is area, which is this area, and this is where message is initialized within here. So we need to work on it. So basically, let's find a place and add this function. Now this function, we can do it at the bottom here, or we can do it at the top. Maybe let's do it at the top here. So what is this? This is a function called get active API key. Now this helps to first check if user entered a key manually, right? And falls back to environment variable if or returns empty string if neither exists. So the first thing is returns the user's API key that he entered on the interface if that one is available. Otherwise, it should just grab the one from the environment variable. Okay, so those are just the logic there. Bias returns an empty string. All right. So we can then look for this function called dummy choice. This is dummy AI response simulator instead of fetching of data. Okay, so what it means by that is that currently if I type hello, there just seems to be some simulation going on there. So we want to replace that entire block, which is from here down to here. Want to replace this entire block with something real. Okay, so what is the real stuff to replace? We're going to start small. First step, replace this. So we're making an API call to OpenAI and making sure that we're passing in the active API key for OpenAI. We're using GPT-4 and making this to be conversational. So it's going to be taking note of the previous things or previous communications that you have and tools. These tools is later, we're going to later use it, for now, not yet there. Okay, so that tool is going to be, we're going to use it to list available tools. I don't know if I can just put an empty array for now. Yeah, and then this active key. Okay, so talking about user API key. So we can say user API key instead. Okay, so now we got that. That will bring a response for us, which we want to use next. So before we proceed with that response, we want to check if there was any error in the process. So if there's any error, we want it to fail with that error message. Okay, and once we verify that, then we want to pass the response from OpenAI, and it has to be in this way. Okay, so pass the response from OpenAI. Call on this OpenAI response and say await JSON. So this is the type of response. Okay, just the type, and install there. We can grab a choice and make it available. Okay, so to recap, we're making a fetch request. Okay, we're stating the model that we want to conversate with OpenAI using GPT-4 model. Okay, we're passing messages which are like the previous conversations we already had, and passing tools which will later be a list of tools from our MCP server, but for now we're just keeping it empty. And then the tools choice is auto. The AI will decide which tool to call. Okay. So I'm seeing that there's a little bit of an issue here, saying public key is not assignable to a type of string or no. So this is because of this chat panel. We're going to look into it soon. So let's open this chat panel. And inside the chat panel, we have this interface. Where is it? So this is the chat panel prop. Okay, this public key here, we need to change it. We want it to be public key or null, not string or null. Okay, so I'm going to replace it with this. Make sure that this is imported. Now import it, you can just simply see with the error that I was facing is gone. That error is gone. So, but you want to make sure that you import it from this use wallet. All right, make sure you get it from use wallet and find where it is used here. Okay, then you come, this is where it is. Okay, that's not how we get it. Okay, we're gonna get it a little bit differently, and I think the best way to just get it is to go back to what we had previously done in the playground. Look at that playground, we should be able to have this access to this public key, Solana Web3. So that's where we want to get it. So see, get it there. Fantastic. Okay, so now in this place that we're having this error, because this is not a string, this is still a public key. We need to first convert it to string before we do this. So to convert it to string first, I want to make sure that it is dot go base type 58. All right, so once we do that, then we are in good standing there. All right, and now you're done. So we want to create another use effect. We have quite a lot of them now, but I want to create another one here. Okay, so this use effect runs whenever the wallet changes. Okay, for now it just sets the wallet context for later use with MCP tools and all of that. Or we're going to leave all these things. We're going to have this one called that will load organizations for us. Okay, we're going to update it. Before we update it, the first thing I want to do is I want to make sure, because all of this right now is based on a false record. These are not real information, so we need to play it off. All right, and we need to bring in accurate information. Okay, I'm going to put that try here. Okay, so first thing I want to do is to make sure first that we have a public key, that is, it's connected to a wallet, before we proceed to the next step. So if it is connected to the wallet, then we can use it to grab our MCP tools, which we'll do later, because right now it's not yet ready. Okay, we've not yet created the MCP enablement for doing that. We'll later come to that, and want to make sure that we want to call this method only if the wallet is connected, and we want to make this part of the dependency array because it's being used on multiple occasions. Okay, so for now, let's save this. Okay, and let's connect our wallet again. So this is where we are. You can see that our actual wallet, address is showing up here, and of course we don't have anything going on here for us, which we'll come back to it later when we are bringing the MCP tool. Right now the MCP tool is not active, so we just want to test if we can communicate with the network. I want to say hello. Something went wrong. API feed, you didn't provide an API key. Okay, so that is an issue. We need to fix that quickly. Okay, so let's come back here. When we're making that call, that API call, all of these other extra instructions, I'm going to remove them for now. Hold on, I'm going to remove it for now. Come back to it later, because we need to explain more details there. Okay, so I'm going to make sure that I have this. There is a function that we needed to make sure that we bring in. I thought we added it here. So that function, this get to for now, let's leave it. I'm looking for something. Maybe I removed it, but I thought I pasted a function above that we called get, what's it called, active API key. So I think I'm gonna have to bring back that function. It's quite surprising that I thought it was actually there, but it was removed. No problem. Let me find it here again. Okay, it is here. Oh, I see the problem. I added it within a use effect function. It's not supposed to be inside a use effect function. It's supposed to be on its own. So I'm gonna bring it out of there. I'm gonna paste it here so it's on its own now. Okay, so this, now let's go to the place where we wrote here. So instead of calling using this user API key, we are using this active API key. All right, so we're going to save that and just refresh and say hello. And let's see, say hi there. You can see that, saying that can we assist you today? Let me ask, do you know anything about my organizations? Say I don't have access to specific details about your organization. If you provide me with the organization name or any specific information you are looking for, I can help you retrieve details or manage them. So currently it doesn't have any information about my about the what's it called, doesn't have any information about the MCP servers yet or the MCP tools yet, because we have not yet included them. So in the next part of this video, we are going to start including it. Right now, what we're able to successfully achieve is to integrate these interfaces to make sure that it is connected to OpenAI and it's having those messages working out for us. So that is one thing you must bear in mind. Okay, so in the next part of this video, we jump into the next thing. And in case I didn't quite explain the whole OpenAI thing properly, I want you to take a look at this package. We're using this package called AI, okay, and AI React SDK, all of these things. So those are the packages that we're using. And if you come to this chat panel, you find out that we're using, what is that? Oh, I think I actually got rid of all that. Okay, that makes sense. I'm not using any one of that, package. I'm actually going hardcore because why I'm not using them anymore, because of my unique design. That package kind of have its own design and its own way of doing things. So I was going to do things in a way that it will be very much fitting to our specific use case. So what you need to do is these OpenAI messages is relatively similar to how you're going to be doing it if you want to use, let's say, cloud or Grok or any one of those tools. Okay, so you need to arrange it. Of course, you may need to make some tweaking here to make it to be much more unique to how that ecosystem or that LLM handles this message processing. For OpenAI, this is how you communicate with their platform using this whole sequence. So if you can make all those smaller adjustments, then that would be nice for you, including how you respond to the message, how you package it. You see the way we use this type. Okay, so I just wanted you to take note of that. For these other packages, we'll find out where they're actually coming into use. If you do a search here, find out we didn't use it at all, it's just there. But apart for this, we'll find out that we didn't use it either. And what about for this? Find out that we didn't use it either because it's only on our it's only on this package.json. It's not here, it's nowhere to be found here. So we don't even bother doing that. So we've done that search. In this place, this is where it's found. So those packages, we're gonna have to remove them. Okay. So we'll remove them after we're done with this whole thing. I can close this one now. So let's get to the next phase. Now, okay, so let us close these files. We're gonna create a new file here. I'll call it lib/library. Then we want to call it payroll-mcp-tools.ts. Okay, so this is where we're going to be putting all of those MCP tools. Now it should be noted that I finally found a place where we're going to be using that AI tool. Basically is here. So I'm going to paste this here. This is where the tool is coming from, and as before, we're using all these functions that we created in the blockchain service. Okay, also using Zod. You understand that we're using this Solana public key. Those are the tools that we're going to be using. So let's proceed and want to create a wallet context. Now this wallet context is going to assume that you are connected to a wallet. So the wallet context will look something like this, where we have wallet context. The wallet has a public key and a signature and a signed transaction, which is just that function that we normally pass in. Okay, so it is needed for us to have it this way structured. It is never reassigned, but we will soon. So the first thing I want to do is we also need to create another function that will help us to set the wallet context as well. So this is how the wallet context is, and then this is us setting it up. So this is another function to just help us to set the wallet context. So just have those two in mind, very important. Now the most important place for the project is the MCP tools. All right, so call it blockchain MCP tools. This is where a bunch of the code that we're going to be creating is gonna go. So, and these are how you create tools. So for example, we want each two is going to be a function, okay? So we want a function called create organization, and it's going to be a tool, right? It's going to be a tool, and what it does is a tool need a description, right? And a description, and it also need a name. Okay, so let's dive in deep into that. So the description, we're going to say the description is talking about what this tool does. So this tool, for example, create a new organization on the blockchain requires wallet connection. All right. What about the input schema? That is why we're using Zod now to make sure that whatever we're passing here is accurate. So the input schema is gonna be that Zod all ons dot string and describe. What are we describing? We're saying that name of the organization. So we're describing. Okay, we've not done this well. Sorry. Is it for this Zod gonna be object? For that object, we're passing this. The only thing we're passing in here is name. And this is how the name is gonna be. And how we describe this name is that the name, this is the name of the organization. So this is very important for to create this. I just want you to understand the pattern recognition here. We have description, input schema, description of the tool, and the input schema we comprise of the various arguments or variables that need to be passed into that tool. So that is very important. And then you need execute. Execute now is talking about a function that is going to call on. So it's basically a callback function. Have a sync. So in this sync, we're going to pass in the name the name of the organization. So once you pass in the name of the organization, the first thing you want to do is to check if the wallet is connected and this transaction is passed correctly. All right, so those are the two things I need to pass. Otherwise, a wallet not connected, please connect your wallet first. Great. And now, if that was successful, we can move to the next part, which is the try catch now. So let's work on this try catch. So if we're able to get this, that our application is connected, the next step to make sure that we get the instance of the program which is coming from the blockchain. So this, since it's a create organization, we're going to be using the right, the right request provider, the blockchain provider that enables us to sign, transactions. The other one, we won't need to pass that, but for this one, we really need that. And then we want to make sure, oh my god, let me change that. It's supposed to be here, not below. Okay, so once you do that, I want to confirm that the program is available. Otherwise, say failed to initialize blockchain program. Great. So the next step is to call on the create organization method and pass in the relevant information argument. So this is coming from the blockchain, of course. Remember this here. This is what happens when you want to create an organization. And we pass in the program, the wallet public key, and the name. Remember, you'll be prompted to sign a transaction. So once that is done, we want to derive the, when this happens, it's going to create organization, right? And then we want to derive the PDA of the organization by passing in the both things that were used in creating the organization, which is the wallet public key and the name. That should give us the PDA of that organization. Once we get the PDA, we just return a message or a record. So we return successfully through message to the organization's name has been created successfully. We pass in the signature and then the PDA of that organization. So those are the records we are returning. Otherwise, we want to bring about this result. I want to say catch the error which is unknown. The error message, we'll check if it's an instance of error or convert the error to string and then just return a fail to create organization with that error message. So that is for 1, 2. Okay, so it's good that you've understood the flow of creating a tool. Now I'd like us to go a little bit faster and create the rest of the tools, because we can't do we can't do it just being too slow about it. So I'm going to do this. So this is for fetching organization, and then we have that execute function. What does it do? Of course, the very first step is always to check the wallet connection state, and then you have this try catch. Fortunately, the try catch is not just catchy, very, very, very catchy. I'm not getting the intelligence that I need. Okay, let's see catch. Okay, so what is going on here? The drill. How do you do this? It's pretty straightforward. You come here. Okay, you first of all get this program. All right, get it from this read only because you're fetching from the blockchain, and then you want to pass it here. So in order to resolve this, we need to just do a check. We need to do this. Okay, so we're gonna check for that, and then you call on this fetch users organization, and it will return all the organizations that user has, which is the length and the organizations themselves. If there is any error, you just drop it here. That's good. So this is a second tool. I'm just going to duplicate this because they are just really, really similar. So this time around, I want to create a next tool. The next tool is fetch all organizations. We'll do this now, and what is going to be fetching is all the organizations, not just the one created by this wallet. And then okay, so fetch all organizations. So for organizations here, we want to fetch all organizations, and the only thing we need is a program. We don't need that specific users organization. So a wallet address. So we do that and send it, and it produces, it get it for us, and that is it. That is just it. So we don't need to do much there, and we don't need this either. Okay, since we don't need a wallet address or anything for this particular function, so we're keeping it simple. And we're going to duplicate this now and do for the next one to fetch organizations details. All right, so I'm gonna place this and make sure that I give you the right description. And it's gonna need the PDA of that organization. Very important. I'm gonna pass this. This is the PDA, which is the public key of the organization. Okay, and then I will need to pass that organization, fetch public key that and this, get it together. But now it should be known that you also need to pass the PDA here, okay? Because you are this function should pass the PDA of that organization in there so that you can get it. Okay. So this is this is where the real content of this whole development process, is based on. It's very important that you understand this part. This is where MCP development is happening. So now you get that, and you just want to say, okay, you just want to say success to an organization. If you're just passing there, that's just all it takes for this particular one is to fetch organization details. What else? So now that is all for organizations management. Okay, let's get to the next set. The next set will be for the next set of tools will be for workers management. I'm going to copy this because this is just quite similar. All right, we're gonna want to add workers, so I'm gonna call this to add worker, and I'm gonna also bring in this, modify this. So this is what it is. Description: add a worker to an organization with a specified salary. And what you're going to need for that is you need the organization's PDA, workers public key, and salary in Solana token. Monthly salary in Solana token. And this execute function is going to need those three, parameters or arguments. Okay, so you need that. So afterward, you want to make sure that your wallet is connected. You get the program. Okay, make sure that the program exists. Then we can proceed to the next step. The next step is to make sure that the worker's public key is in public key format. Right? So that's how we're converting this to a new public key. We don't just want it to be a string, even though it may work if you just pass it like that. Okay, so there you go. Now, after you've done this, you want to call on that function, which is where we're passing the signature. So this function now, which is add worker on the blockchain, you look here, you find it here, will pass the program the wallet context, which is public key, the PDA, the organization's PDA. So it's saying that argument of public key is not assignable to a type of string. So if we come here, look at this here, the PDA needed to be not a string but a public key. So if we save that, which if it is a public key already, then we don't need to do this anymore because we don't need to reconvert it again to another public key. So block scope used before declaration. What does that mean? Okay, here. Now I'm gonna cancel this. Yeah, I'm gonna fix that. So we need to make sure that we also are converting this PDA into a public screen. So let's just use this. Let's just convert it right there into this org PD. What's the issue now? Okay, I'm just passing it exactly how it is. So I just reverted what I did here, and I'm passing it exactly how it is. I'm just making sure that I comment this out because we don't need to derive that to derive the organization's PDA. What we need to derive is the workers PDA. So I'm gonna do this instead. Worker PDA is gonna be called from this worker derived PDA. Remember, it is right here. Okay, and it will just return the accurate PDA for us. So that is what you must take note there. So after that is successful, what else? We want to return this record saying that worker added successfully with salary of specified signature, the worker PD and all that. So you save that. Okay, so that is what adding the worker entails. So now after adding that, we are going to just make this a little bit faster and you know paste these functions themselves. So this is fetch organizations worker. What is going to happen here is that we're going to need to fetch all workers for a specific organization. Fetch all workers for a specific organization, and it's giving this issue because we need to make sure that that the program is not null. Okay, so we instantiate the program and make sure that it's not null, and then we get the worker, which is fetch organizations worker. We pass in the program and the PD of that organization. It gives us the workers, and then we can just return that worker record, to the front. All right, so that's just all it is about that. And we'll need another function. Okay, so this function is going to say fetch detailed information about a specific worker. So if you're planning on getting a specific worker, you're going to need to pass in the worker's PD. That's what you have here. Okay, meanwhile for this place you only need to pass the PD of the organization. When you pass the worker's PD, it returns a record for you, but for that you need to make sure that the program is available. So we're going to do this. So and then you say fetch worker detail, you pass the program and the worker PDA, and it returns that information to us. It's pretty straightforward. All right, so want to fetch worker by wallet address. So let's do that too. Very simple steps. We need to make sure that fetch all workers record for a specific worker address, wallet address, and that wallet address must be a string, and it's optional. And the wallet public key defaults to the connected wallet address. So in case you're not sending the connected wallet address, that's why I put optional. In case you don't have any other address that you send, it's going to default to the one that is being sent from, is being connected to. So this is what it is. The target key, if there is wallet address, okay, then you should just convert it to a public key. Otherwise, you should return the wallet context. That means the one that is currently connected, and then make sure that that wallet exists. Okay. And once you have been able to do that, the next thing you want to do is to make sure that you instantiate this program, and then make sure that this program is available. Then you call on this worker fetch worker by wallet, passing the program and the target key, which is based on whichever wallet address that you want to check their employment status or their records on that organization. Okay, when you do this, you get the workers that belongs to that wallet. So yeah, that's what it does and returns the count for us. Okay. So what we're simply doing is we are wrapping all our blockchain functions in an MCP framework. Okay. If you don't wrap it, you can't interact with the blockchain. So this is the wrapper. And if you understand this, then you can build any kind of MCP with Next.js. All you just need is to understand how to wrap it around this executable and you'll be fine. So there we have it for that same function. Now we need another set of function. This is going to be treasury management. So what does this treasury management does? Okay, it's the same thing, just the procedure is just straightforward. That is why once you've done a good job in developing the essential functions, all of these things become a lot easier. So fund treasury, to what it does is add fund to the organization's treasury. And what does it need? The organization's PDA, okay, and it also need amount in Solana token that you're trying to add. It must be a number and it must be positive. That means it cannot be a negative number. Okay, and then you call on these PDA. These are the two arguments that are going to be passed. Make sure that your wallet is connected. Invoke the program, ensure that it's available. Then call on that fund treasury, function, blockchain function, passing the program and the public wallet, that will be used for signing the transaction. Then the PDA, you pass the PDA and the amount in Solana, then it will just return it. Meanwhile, you should know that all of these things are going to be operated by the AI. You're not going to be entering anything yourself. You just paste in the words in natural language, and the AI will be the one filling up all this information because the AI understands these languages, these two systems. MCP, which literally means model control, is it model or model control protocol. So it's basically the ABI for LLMs or the IDL for LLM. You understand that it just gives the LLM context about the functions that your application or program is running on. So, like I say, once you get that, you return this message and the signature, which is the signature in what's it called, or where you can locate it on the block explorer. All right, so once we got that, the next function we want to work on is the withdraw from treasury function. Let's get that together. Now this is how it goes. Withdraw from treasury function. It draws from funds from an organization's treasury, and you need the PDA and the amount, and so quite similar to what we did above here. And those are the two things you're also passing in here. And you want to make sure that you have your wallet connected, and you instantiate the program, ensure that the program exists and is okay. And you call on that withdraw from treasury function, passing the relevant parameters, and then it produces the result for you, which it will return to the front end, and then the AI can pick it up from there. Okay, so what else do we want? Now let's do one fetch function. So call on this. All right, so get organizations balance. What does it do? So you get the current treasury balance of an organization. All you need is the organization's PDA, right? And you want to just do this. one step. Okay, so once you instantiate that and you ensure that it exists, you get the organization's balance. This is a function that is also available here, very short function that just gets the organization's balance for you and represent it in Solana. Okay, so you once you receive it here, you just pass it on. Okay, and this is the balance, and you make sure that is the balance in formatted format. Okay, so that is just what that function does. So let's deal with the payroll processing tools. Payroll processing tools, remember, all of this just use the same format. There really isn't much things to do here. So you make sure that the rules are you describe what the tool does, precise and very clear, so that the AI will not be confused. Right? So the tool, what it does is to process payroll for all workers in an organization. Then you specify the organization's PDA and the circle of timestamp circle, which is optional. So you need timestamp for the payroll circle. Default is now. Default is the current time, right? And then these are the two things that you're going to be passing. Instantiate the program, all that function, the same step. You get that you pass in all this information and you return the news. Okay, so that's just what it does. And now we need another function for this is called check payroll due. So we're going to be checking if a payroll, any worker are due for payment within a payroll. And then you pass in the organization's public key. And the circle type is an enum of weekly, bi-weekly, or monthly. The default is monthly, and they describe the payroll. So all of these things make sure that the AI knows exactly what to pass in here. It doesn't just pass rubbish, it passes exactly what will work. Okay, so that is what MCP does for your program. So the payroll circles type, which is either monthly, weekly, or bi-weekly. And now you want to confirm this. So you want to initiate the program, make sure that the program is available. Call on this function called check payroll due, and you pass in the relevant parameters, and then it returns the information, the due result, which could either be true or false, the number of workers that are due, which will be length, the workers itself, which will be an array of those workers. Then the message, result, if it is due, say some number of workers are due for payment. Otherwise, no worker, the workers are not due for payment. That's just what you need. Okay. And after this, you want to create another tool. Okay. Each function just understand this. Each function in your smart contract, we have a representation of a function as a blockchain service which you can interact with using buttons, and then to have a representation with a function as an MCP tool. Okay, so everything that we created, we are making sure that we have their corresponding tools that we interact with them. All right, so this tool calculates total payroll cost, which that is what it does, and calculate the total monthly payroll cost for an organization. And we just have that there. Call on that function, passing this program and the organization, and then just return the information. This is total cost. This is total cost formatted, in Solana token, of course. So there you go. And then lastly, for this group, really to calculate the next payroll, you know, so then calculate the next payroll due date. So what this does is to calculate the next payroll date based on last payment. Then we need the last paid cycle as one of the parameters, and last payment timestamp in milliseconds, and then the cycle type, which could be weekly, monthly, or bi-weekly, but the default is monthly. That's the payroll cycle type. So when you get that, you run this calculate function. Let's see. Now this calculate function doesn't interact with the Solana blockchain. It just gives you when next payment is due based on a certain date. Okay, based on a certain date, which is this last paid. So this last paid is a timestamp that you pass in here, and then based on that timestamp, it can calculate also based on what you want, whether it's monthly or weekly. Then tells you next time that this payment is going to be due. All right, or is due for payment. So succeed. Say next payment date will be what we get here, and then the next payment date formatted will be in this format, and then the cycle type. That's just what it does. So that's why I don't need to initiate any program. So lastly, for the tools that we need is basically around 3 tools. These are utility tools. Okay. And even though we're not going to be using all these tools, but it's just very important that I put it here for your own learning purposes. So this is a derived organization PDA. This is a tool if you want to use it, if you want to derive an organization's PDA. So derive the program PDA for an organization. So for you to be able to do that, you need the authority's public key. So the owner of this organization, you need their public key. All right, you need the name of that organization as well, because those two keys are what we use in deriving the PDA. So now you have authority in public key format, then you pass it into this derived organization function, which is the authority and the organization's name. Then you just return the result, make sure that the PDA is in base 58 string, all right, and the bomb. So that is just what you do there. And you also have the same thing, something similar for deriving the PDA for worker. The same sequence, you need to pass in the PDA, the organization's PDA here, where you use the authority as a reference point, authority and the organization's name. Here you use the organization's name and the public and the worker's public key. So those are the things that you need to know the PDA of the worker. Okay. Now, once you get the worker, you make sure you convert it to public key and the organization's PDA also a public key. Then you derive the worker's PDA, which is here. Okay, which takes the worker organization PDA and worker public key. You get all those things, and then you get your PDA and your bomb. Let's see this. It actually only returns. Okay, I think it returns both PDA and the bomb. All right, so that is just what that function does. And lastly, a function that isn't just a no-brainer is to get the connected wallet. So get information about the currently connected wallet And what it does is it doesn't pass any schema, doesn't have any variable. So if the wallet is connected, then it should just return connected through, wallet context and all of that. So it's just very simple, straightforward thing. So at this point, we've been able to create all the tools that we need for this our MCP server. In the next part of this video, I will then connect these tools to the existing chat interface that we have. Right now, you can't call on any tools yet. So we'll be able to do that in the next part and also list the correct organizations here. I'll see in the next part of this video. So coming back to this, you can be sure that we have this function ready for export, and we'll be using this wallet context throughout the entire application, throughout this entire payroll, a payroll MCP tool. So now let's come back to this dashboard component and complete it because it's not yet done. We've not yet integrated the MCP tool, so it's time for us to do that. First thing I want to bring your attention to is this particular function here called dummy blockchain tools. Okay, this is where the kind of tools we're using before is just a dummy tool. Okay, it's not really a tool. See, just for hard worker, do this, do that. These are dummy tools. So let's bring in our real tool. Okay, the real tool is coming from it's gonna be coming from here. Let's make sure that this okay. All right, so we need this MCP blockchain tools, which is a compendium of all the tools that we created, and then we also need this set wallet context as well, because that will give the MCP the insight into our wallet situation. So this we update this information here and then make it available to our tools down the road. So there we go. Now that we have that, let's come to this place and make some modifications. So the first thing I want to do as a modification is to find wherever I'm using these domain blockchain tools and replace it with this instantly. And maybe I can remove this one here. Okay, so let's move that. All right, so that's the first step. So now let's go to this function called, is that function? Not generate response, but get all tools here. It's still working with the dummy stuff, so we need to update it. Everything inside here, I want to remove it for now. Okay, and I want to bring in two interfaces for now. Okay, this one is not used. Okay, so this is type name, identifier shape, object shape, description, field description value. This is a generic definition of the type, basically the type of tool that we're using, because yeah, so these are just ZOD definitions. Okay, and once you do that, you need to first of all get the tools input schema. So you want to access the tools input schema. Remember, we're getting all this from here, and for each one of them, if you're mapping through all the function, you can literally extract all their, each tool gives you access to the schema, input schema. So for example, you look at this tool has an input schema, so we're trying to get all these input schemas. That's what we're going to do as the first step. We'll say const schema is equal to this two, okay, dot input schema. So we get the input schema of that particular tool. Once we get that, honest, I want to make sure that that schema exists. One, the type of that schema is an object, and definition is a schema, because all schemas here, if you look at them, they are all objects. Okay, so we want to do that as step 2. All right, then the schema object, okay, will be that Zod type we just defined here. Okay, so we want to say the schema object will be the Zod type, because that's how the schema object should look. All right, so and then we want to call on the definition of it. So we're accessing this define, which is, this definition is going to be a type of Zod definition. Okay, all right, now we get that. The next step we want to do, we want to make sure that the definition type name is Zod object, and that definition has a shape. Okay, here is optional, but we want to make sure that you have a shape here. So this is what we're doing, and then once we get that together, we want to make sure that we're getting the shape the right way. And so the shape is equal to, if type of this def shape is a function, then you should just pass it on as a function, otherwise pass it on as a variable. So that's just what we're doing there. We want to loop again through each one of those fields in the object. So on here, through each one of those fields in the object, I want to say it's optional fields and it's actual definition. We have these two fields, is optional and actual definition. Then I want to say is equal to inner depth. But before we get there, we want to say this thing, want to do this check. I want to say if the Zod type, if there is no Zod type, okay, and the type of this Zod type is not an object, or it is not the definition, which is, there is no definition in Zod type, then you should just return. If you don't understand all these things, this part is, you should just copy it basically, but it helps to make sure that we're calling the right functions and the right tools, when we are interacting with it. So that's just the reason for this whole step that we are taking. This, remember, what it does is to help us to get OpenAI tools, to get the correct tools. So you need this deep inner depth as Zod type, and then you want to call it definition and pass it into this actual, and maybe you can just do this like that, and you want to run a check down here. The check is doing if the inner depth the type name is Zod optional, then you want to say we actually found an optional key, and then the actual definition will not be on this depth, inner depth dot inner type, and then you call on this depth or this inner depth. So this is just it. These steps are not, you don't need to be very, worried about them. You don't need to be very worried about this step. Just understand what I'm doing, or just follow what I'm doing, and you'll be with me. Okay, so now we have this JSON schema property. I think this is where this one comes into use. So JSON schema property in various types are string, number, boolean, object, array, and it has a definition, description, and an enum. This description and enum are optional. So I want to say if the actual def type is Zod string and the type is equal to string, if it is actually Zod string, then the type here should be assigned to be a string. The same, you test for number, boolean, object, array, and make all those modifications there. That's what we're doing, making sure that we're passing in the right arguments as well. And then for these properties, we'll go up here, the top, and all this I'm going to wrap it in a try catch block. Okay, I'm going to come back to wrap that. For the catch, I want to make sure that it has this error. Okay, so now we have this try catch here. Now here we can then say properties, because what we're trying to do is to define these properties. So these properties is going to be a record of string and their JSON property. So we have record of string, string to JSON property is more like a mapping, structure right here. And then you also want an array of, that is called required. These are going to be used for required properties or strings or fields. So that you should bear in mind. So let's get back to this place. So for each one of those keys in these properties, you want to assign the type and the description. Okay, so this will be very dynamic and it will save us from having to type for each one of those tools. Okay, so it's difficult we want to make sure what we're doing, we are extracting all those. Remember, this MCP tool has various descriptions for each one of the tools. Each tool has a description, so we're just fetching them or fetching their various schema inputs so that we'll know exactly what to give to the LLM, what the LLM should pass in. So all of those things, these are what we're doing. We're checking for the arguments that are passed in the function. We're checking for the schemas. We're checking for the description of each function, the description of each tool, and we're checking for anyone that has number, anyone that has optional, all of those things, and that is what we're passing at all these steps. That's why it looks a little bit freaky, but please don't be freaked out. Okay, so now want to also check for enum situation. So I have enum. So if actual definition type name is Zod enum and then the Zod def.value is present, then you need to pass that enum. You want to say .enum, for that specific key. Okay, give it .enum and then you pass. You want to check if this is an array or not. Is array or not will read true or false. And if the actual value, so if this is an array, then you should pass the actual value. Otherwise, you should convert this record into an array. So it creates this method array.from creates an array from iterable. So if there is an iteratable record, it's going to convert it into an array. That's what it does. And then lastly, for that step, you want to make sure that you have if not is optional, you should put required to put required, and then you push that specific key that is required. Okay, so that took a while, but we are through with that specific function. Let's look for this use effect that has this, which is this here. This is a use effect. It never had anything in it before, so at this time all we need to do is to have it set the MCP's awareness of this public key and signature, transaction signer. So we need to come here and remove all this in case it's becoming too noisy, and replace it here. Okay, so basically what we're doing is this: setting our wallet public key or no, the transaction or no, that's what you're passing in there. All right, once you do that, you want to look for this other one that, remove this here, other one that we're loading organization. Then you want to do some modification. So what are the modifications that I want to do here is that we want to grab all the tools from the blockchain, or the fetch user tool only. Let's comment this out to be so let's do this. We'll get the tools. So the blockchain MCP tools dot fetch user organization. We want that tool, and we want to make sure that tool exists and that tool has an executable, which is this executable function. What I say, fetch user organization to not available, can then returns. All right, otherwise we can then call the tool with no parameter. Let's call it tool here with no parameter. So the result is that tool here, we'll call on the executable, this execute, no parameter, because why? If you check, fetch user organization doesn't require any tool, so that's why I'm not calling with tool. And we'll give it tools, all IDs, load organization, and then message, messages an empty array. Okay, so check if tool is successful. So we need to check if the tool calling is successful. If it is successful, is what we want to do to test that. Result is an object and result is not null, and success is in that result because it's an object that is being returned. Then we want to go one more step by saying it is successful, result of success, and the organization, remember the organizations here is supposed to be an array, so it's an array. So if that was true, then you want to convert the blockchain data to a UI format. This is very important. Convert the blockchain data to a UI, right? So how do we do this? So we need to get the organization's data. The organization's data is in this format. This organization has record of string and unknown. Okay, and then you want to get the workers count, which is basically this organization's data dot workers count. This is part of what is returned. Okay, that is for each one of those organizations, it will have a workers count. Okay, that's one thing you must know. It must have a workers count, or you give it 0 by default. Okay, and then at the end, this is what you want to return. You want to return this formatted data in this format. So ID will be the public key of that organization. But if you can't find public key, you can also use the organization's name or an empty string. Organization name, make sure that it's passed in correctly or unknown. Treasury is what the organization treasury or zero, created at or zero. Workers, which is the total number of worker or worker summary. I have that worker summary which include the public key, the salary, last paid, and created at. So this is an array that we return all the workers belonging to that organizations, but in this worker summarized format. Okay, and then there is a certain mapping. So we need to update the UI of that organization now. So after this mapping is complete, I want to update it. This organization, there's a function here, a use state here called set organization. We need to update that there and be happy. Now I'm looking for where this problem is coming from here. So this one probably dealing with big data, so we need to also modify it a little bit. But for the place where we were, which is here, and then at the end of the day, you want to do this. So let's look for the other place where we're doing this as well. You see this place, we're also doing something similar. Okay, so we should take note of that. And we can just, okay, you see what we did here. We want to do something similar here. So let's copy this. Okay, let's come down here. When you're down here, or let's go back up. Let's just go back up because it looks like the way tool was being called here is different. So I'm going to call the tool this way. I'm going to copy these two places. Come down here. This is the way. Just want to make sure that I'm getting everything correctly. Okay, so it's in this area of result. So make sure that we're grabbing the result correctly. Copy that result. Come here. The way this result is, let's update it with this new information. So you can see this is how you call a result now. And you save that. This should populate this with the right record. Let's refresh. And see now it's populating it with the right organizations, and the right organizations and the right details are appearing now. You know that this is a lot, so I'm going to allow you to take time to go through what we just finished implementing again, and then we will finish this up in the next part of this video, which is to make sure that the rest of the tools are available for the LLM to interact with. I'll see you in the next part of this video. Okay, so we're going to do the last aspect of this thing. So we're almost through with everything that we needed. So we need to come to this dashboard. Currently, not every tool in this dashboard is the system or the prompt. The machine is not aware of every tool, and so it's not going to be effective. Okay, so we need to fix that. So the first step you want to do, you see this place where we're making this call. Instead of passing an empty tool system, you want to pass in those tools that we're getting. I'm going to do tools, and currently it's not locating it, so we need to make sure that it is accessible. So we need to modify this a little bit. We need to make use of this option now, this function called get OpenAI tool. Basically just get tools, okay, which you can use in place of any other LLM that you're using. And then you come to this generate response. So in the generate response, This is where you make sure that this tool is available. So you're going to put it above here. The const tools is equal to generate, OpenAI tools. So this will become the tools which pass in here, which list all available tools, for later MCP or for MCP. So you fix that part first. And that thing we want to fix is this system prompt. We want to enhance it so that it will be precise to what we want. So right now, the only thing saying is that you are here for payroll managers, a management assistant on Solana blockchain as all, but that isn't enough. There are many things that we need to specify here to make sure that it behaves accordingly. One of the things you want to see is that I want to give you this instruction. Okay, you want to tell it that your available organizations, and then you list all those organizations, which include their name and their PD, which is this ID. Join them in new line. Okay, it's an array, so you list them for the LLM. Okay, and then you want to do another thing. You want to inform it when user asks you, or when the user asks to the organization or list an organization, use fetch organization, no parameters needed. Just indicate everything that is going to be needing. Another one is show details for a specific organization. Use the organization, fetch organization with org name, org PDA from the list above. Create organization name. Use create organization with the name parameter, add worker. Use add worker function with add worker tool with org PDA, and so you just specify all the various information that it needs in order to function well, and that is very important. And then you also have another set of instruction that you want to give to this LLM, which is a critical rule. You want to say critical rules when a user mentions an organization by name like Tesla. Look it up in the list above to get its PDA/ID. Always extract all required parameter from user request. For fetch organizations detail, you must provide organization PDA parameter. Use the ID from the organization's list. If a parameter is missing, ask the user for it. Be conversational and friendly in your response. After tools execute, provide a brief, natural summary. The tool results are already formatted nicely. So those are some things that you need to take note of. And then lastly, you need this instruction here as well. It's called available tools, and then you list all the available tools that are here. Okay, so you can put that there or put it on and use a new line to break it, just like it was done here. Okay, using / new line, for each one of those tools, or just leave it the way it was. Okay, so here we go. This is great, although I may need to update this just a little bit later on to perfect it. So let's see what else we need to modify. Okay, so let's look at this get OpenAI tools again if everything we need is complete there. So I want to check returns is okay, this is there, required is there, schema, there, this if statement is there, this is there. Okay, we are confirming all this, making sure that we're in good position. The shape is there, well determined, and the object entries, each one of these is also there. So we're good for that. All right, so there's one more step that we missed here, which was very important. You see, after this try catch, we're supposed to return a value. Okay, that value is very important, later on when this is being called here. Okay, otherwise nothing is being returned here, which defeats the whole purpose of writing this huge function. We want to return an object here, and the type is going to be function as const. Okay, function now will also be an object, and each function is going to return a name. Okay, it's going to return the description of that function, basically, which is the description of the tool. Okay, so description is tool.description, and the parameters, which are what the object is going to take. So the type, properties, and required status. So these information are necessary to put in here, because that is how our LLM is going to have access to them. Very, very important. So otherwise, the purpose of this is defeated already. So we have that fixed. Okay, let's look for this location. This is talking about okay, just after here. Now this is important. We need to make some updates before we set organization. We want to improve this if statement. Okay, so before it's able to communicate with the blockchain and all of that, we want to make sure that it's has what's it called, is on the server. No, we are connected. So I want to say, after setting assistant message, okay, we want to first check if there is a public key. Then we need it to get the blockchain tools. Get the blockchain tools called fetch user organization, and then get the message result by making the call. Okay, and then we can shift this. Basically what I'm doing is this. Okay, but let me shift this first. I want to shift this into this instruction. Then at this point you will not need these here, okay, because what we've created here is serving the purpose. To save this, let's confirm that everything is working. Alright, everything is working as it should. Let's see if there's any more thing we need to do. Make sure that the wallet context is being set correctly, which is true. Okay, so this is okay. This is cool. Now let's try and there are 3 workers here. There are only 1 worker here. Let's try something. Let's see, can you, how many orgs do I have? Let's see if it is behaving correctly. All right, this is cool. It's displaying exactly what I want. Now, the thing is that while this is cool, I could make sure that I am a lot more precise, because what if I want to view this record on the chain and I just want to click on it, then it should lead me to where I can find records about this on the Solana, Explorer, and it should be able to take account on the current what's it called? It should be able to take account of the current cluster that I'm working with. So we need to make some adjustments to achieve this goal. Okay, so I'm gonna come to this place where we have the utils. I have helper. So there are how many kinds of, you see this right here, or these are the name of the cluster. So if I want to get a cluster, this is very important that we get it together. So I want to get a cluster, then I have to pass the correct name to get this cluster. So we need to get that cluster and make use of it. You're going to see how important it is right now. So let us format this system prompt that we had going for us. System prompt, here you have it. So in this system prompt, let's make some improvements. The Explorer links, I'm gonna call it Explorer links, which is here like this. I want to say when displaying transaction signature or addresses, always provide clickable Solana Explorer links based on the current cluster. For example, we give transaction format to a Explorer TX, and then the signature, and then the cluster, put that there. The same with the address, do that the same, similar. All right. And for the current cluster, we have, let's do this. We're going to modify it a little bit. For current cluster, and then we have supported cluster, which we include custom, devnet, testnet, and mainnet. For this place, we want to pass this entire stuff inside the function called get cluster. I wish this is auto importing, would have saved me a lot of time. So get cluster, because I want to use that to get the current cluster. I'm going to come all the way here and import this at util as helper. I'll get that. Okay, not just that we need to also look at that blockchain function or service, that will see something. Blockchain service, the way it's being used here. All right, so let's find it. This way it's being used, and yeah, so basically it's the same thing here, just passing this straight up into this cluster here. Make sure that it is not empty. So when I come here, this is what is happening. I'm passing in the current cluster, which should be in my environment variable, or the supported ones. These are the supported clusters, making it a lot easy for this application to know you know, afterward you can do this in example. You can say we can use custom here. Okay, example here. So this is my example, and then you give it an extra, information. Example, an organization address. Okay, let's look at this first. Then you want to give an extra caution here. Important. So important, replace cluster with the actual cluster value. Always include cluster parameter in links. Okay, so you save that, and let us come here, refresh, and let's say I want to see, for example, click want to see details, show details of organization Amazon, and let's see. That's fantastic. We have it here, and you can see saying you should click here, and let's see if it got it correctly. Okay, so it's making a huge mistake. It is actually going for DevNet instead of custom. Okay, what about we give it that, make sure that it has this custom, and if it's an address, we want to make sure that we have that address there. Okay, now let's refresh this, let's check it out again. Okay, this is a lot better to look at public key, but for some reason it is always defaulting to DevNet, and this is what I'm being very cautious about, to make sure that we only get. This is what I'm going to do. I'm going to get this cluster. Probably the name of the cluster has been wrong. So let's look at it. We have a way where we have what we're doing here. The get cluster URL. Okay, different for get cluster. Okay, this cluster URL. Pick cluster URL. In fact, we can remove these logs. And let's come here. Okay, this is cluster, and let's log this at console.log, and let us see the cluster. Okay, I'll say get cluster. Now let's see if we can find that. So it is showing that custom. Okay, so if I should change this cluster to custom, then it's more accurate. That's the only difference, that our application isn't yet nailing. So we need that custom thing to be honored. For this place, just gonna do custom cluster here, custom. So what is going on? It's just getting something confused here. Even though I'm not the only place I'm mentioning DevNet now, is just this one place. It just default into DevNet. Now, that is one of the things about this. Maybe we just need to make sure that this is placed in more location. let us see if that will help. Okay, let's say, can you fund Amazon with an additional 5 SOL? Okay, funded, you can see it increased here. And let's look at this. Yep, this time around it actually gave us the correct cluster. You can see that it's going to custom. You can see this is where that took place. I don't know how reliant this could be, but let's look at the details of this and see if there is any improvement about it. Okay, it's actually providing us the accurate description now. So the right is what about this? Okay, so all of them are linking up to the right Solana Explorer. This is good. This is really good. This is great. What else do we need to test? Do we need to test all the tools again? Let's create a new org name Tesla. Let's chain multiple stuff. A Tesla, fund it with 9 SOL and add. Let's look for a worker that would like to add into this. Just one, and add this as a worker to be paid 1.3. So let's see if we can execute all those commands. Let's see. So let's confirm this first. And let's see, confirm this again, and confirm this. Okay, so it creates Solana, and it was also funded with 9 Solana tokens. But let's check if it succeeded in doing all of those things that we gave it. So this organization Tesla created, Treasury fund funded with 9 Solana token, and worker, so for us to confirm this, all right, let's look at this. Can you fetch the Tesla org details afresh on the blockchain? Okay, turns out that those other of did not succeed. But let's check this out. Say created an organization, Tesla. That is correct. An organization named Tesla was created. Okay. As you can see, organization created. What about, and this is the organization's address. Okay, you can clearly see that it has no funding. Now let's see, you see that it funded, there is a funding transaction. Maybe let's see what happened. There is a specific amount of money that was debited, but I don't think it actually credited it in the right place. As you can see, this went to a different result. So it's always good to make sure that you execute one kind of instruction per time, and don't try to execute multiple at a go, and then it's claimed that it also added a worker. So all of these are not accurate to the not very accurate. So Instead, let's refresh this place. For any benefit of that, you can see that there is nothing added there. So let's try and see if we can run Tesla org with 9 and add this thing and add as a worker to be paid. Let's try this. One of the things also is that probably the organization is not yet ready, so trying to execute this chain command all at once on it, you see that it works now because the organization is available at this point. But at the time when we're executing all those instructions, the organization wasn't yet created. So we click on this and see the transaction was successful and the fund of the organization has been fulfilled, as well as the worker's address has also received view transaction. You see that we've created a worker, and this is probably the worker here. All right, so those are the things. Now if there is any need for fine-tuning or making things a lot more cleaner, I think it actually added that transaction to this place. You can see here, this is the this used to be three this thing three workers, but now it's only four, is four now. And I understand why this happened, because at the time we were given the instruction to add that worker, the Tesla organization has not been created yet, so it's still on transit, and secondly has not been confirmed on the blockchain. So this is one of the reasons why if the transaction that you're chaining together is dependent on, for example, an organization, that means you need to make sure that the organization is created ready before you start adding stuff to them. Otherwise it may just add it to a different organization, and that might mess up with your chain of thought. So that is it for the build of this entire application. This is really great. What is remaining here now is for us to publish this work online, which is deployment. And once it is deployed, you are completely through with this. So let's get it done in the next part of this video. All right, so I'm going to close from all this and this. Okay, and I'll come here and maybe I can just end this. Okay, I'll come to this place. Now what I want to do for us to deploy this, there are basically two ways you can deploy. You can deploy this to your own. It's very simple to deploy because it's just a front end thing. The only place you need to deploy other than this will be the smart contract, and then you deploy the front end. But now we want to deploy the smart contract first so that we can deploy the front end. So the first step you need to make sure for this particular project you deploy it online is to ensure that your key pair is preserved. So each one of these programmers is on key pair destination. So if you do ls if you do ls-la and then target payroll, deploy, and then you have this payroll program -keypair.json, then you need to make sure that you cd into the anchor folder, and then you run this command, and it will tell you that this thing is actually available on your device. So this is good, and this is different for each one of those programs that you're running. So you need that to be confirmed. After you've confirmed that, please do not delete that file. That file is very important, and it controls your program ID forever. Okay, so do not delete it except you want to lose access to your ability to control the program that is online. Just imagine that that program has a lot of resources on it, and then you lose this. That means you've lost your ability to control it, which is really, terrible. And that is one of the reasons why I will encourage you to find a way, and you know, um, make or add this that wallet into your non-custodial wallet so that you can easily recover it or still have access to it to authorize transactions, and serve as the authority later on. So the next thing you want to do, since you have this, you want to, if I do Solana, config get, you find out that I'm still on the local host, connection. This is not where we want to be. Instead, we want to be in the devnet. So we want to switch to this devnet by saying Solana config set URL to be on devnet. As you can see, now it's now on devnet, which is fantastic. If I say Solana balance, you find out how much I have in this is just what 6 Solana tokens. So what if I want to airdrop? So I say Solana airdrop. Okay, 5 token seems to be the max that you can do per day. All right, so let's run that and see. For some reason, it's telling me that I've reached my rate. Okay. All right, so you can see that it has increased my Solana token by 5. So I have 11 now. If you use this to check online, you'll find it is confirmed. If I run Solana balance, yeah, so I have that. But if I try to, I try to airdrop a second time, I don't think it's gonna work. Yeah, talking about that I've reached max for the day, which only allows you to use 5 Solana token per an account like this per day. Okay, so you wait for tomorrow or so. So now that we have that set out, you need to make sure you confirm this. Open your anchor and this eye here in your anchor. You want to make sure that that address for devnet is the same as the one that you have for this local net. So it's very important that you have that. And then you can change this cluster now to devnet. Okay, now that you have that, you can deploy this to the anchor deploy or do dash provider to be that cluster, and then you have devnet, or you just simply run anchor deploy. Since you've already set it up here, I like using this to make sure that I'm very precise about it. Okay, so you run this and it is deploying. Wait for it. So it actually failed the first time. Let's run that again. Some of the time it takes more than one attempt to get this thing deployed, depending on the strength of your network connection, your Solana balance, and all of those things. So you have to be patient. Okay, that was successful. Okay, so it has successfully deployed this on the blockchain. So we can use this to even confirm Explorer and make sure we switch to DevNet, and then you search for this transaction, find out that a deployment happened here successfully. Okay, so that is successful. Now we need to deploy this to the front end. Now we need to deploy it to Vercel. Now the cool thing about this would have been where we have challenge. Okay, this place primarily is a place we would have had challenge, and the challenge would have been this, but because we've given it a default of DevNet, you can be sure that online we don't necessarily need to have any form of what is it called, environment variable added, since it's for public consumption. So we just use the default that we do have. I'm going to come here and say, go to Vercel. You need to log in if you don't already have a Vercel account. Okay, so we have a bunch of projects here. Not all of them are useful anymore. A lot of them are older. So I'm going to add a new project. Please make sure you sign in or sign up if you don't already have one, and then you are looking for, okay, this is a problem. We need to deploy this first to the blockchain. We need to come here and initialize this project. All right, initialize it. Make sure you don't have any one of your environment variables here. Okay, yeah, you don't want to have your environment variable here. So there are some things you want to make sure that is present. So we need to look at that. Before we even move further, I would like to first address that. So I'm going to do rm remove -rf.get. I want to make sure that everything I want to push to the server here is correct. Now let's look at that together. Okay, I need you to come to this anchor directory, this git, this anchor git ignore is a different place altogether. Fantastic. So here we want to really remove some things. Okay, we want to be able to push our anchor projects. Okay, but if for example, let me initialize this. Initializing this project, if you're observant, you should find out that not every module, not every package in this anchor is listed here. So for example, there are important things in this anchor, this place here called target. You see that it's completely excluded because that was the instruction here. So you can have your IDL, which is important. You can have your types, which is important. These things are going to be needed when you're deploying it to Vercel. I struggled with it, so I need you to make sure that you're taking note of this little change that I'm talking about here. All right, so what you want to do, you want to exclude that folder, and you want to exclude this. Okay, and you want to exclude those two folders. All right, if you exclude them, it may not still list them here, which is one of the reasons why you also want to exclude the particular file itself. Okay, but that is not all. You see, they are still not included in this record that needs to be deployed online. So what you need to do is to make sure that when you are initializing that project, these exemptions have already been set in place. All right, and it's very important you also know exactly where you are initializing this record. I do git status. There shouldn't be any repository here. Okay, now if I do git init, I'm looking for that file. It's supposed to be captured. We can't push this thing successfully without it being captured. It's so important to the success of this deployment that we can't play with it. Let's the initial commit. Okay, now let's try and remove it again. All right. Okay, now we have all these files here. Okay, so let's initialize it again. Hopefully this time it's going to capture everything. All right, so it still doesn't capture everything. So let's commit this. We're going to manually work on that. All right, and now you can even publish this branch. Okay, you want to make sure you can keep it private for now. We'll come back to it. Okay, so this is what we want to do. Let's tell Git, okay, to start tracking the key pair again. Okay, so let's tell Git, okay, that it needs to clean the cache and ensure that it is tracking these two folders, which is the type and the IDL, because we need those two. So we're going to do git remove --arrow dash cached this directory and this directory, and then you say do greater than /dev/null and return an all true. So you do this, and you also add this again, add those two directory, and for some reason it's not following. Let's do git status, because the goal is to make sure that when you do git and you come here, you want to be able to click this anchor folder, and yeah, it's not there as seen. We are not seeing that target folder. Okay, so this is the issue here. Okay, I think I may have made a mistake when I'm running this. You see, because anchor is one level deeper than the root folder, and this is almost regarding it thinking that this should be in the root folder, which shouldn't. Maybe the reason. So I'm gonna just append anchor in front of this and anchor in front of this. Let's see if that makes better sense. Okay, and for this second command, I'm also going to attach anchor and anchor in front of it. So it's saying the following parts are ignored by one of your .git. So I need to use force, to override this -f, and then it's been ignored. Now you see that it started tracking those important files. This is very important for you to know. Please know this, I beg you, so that you will not have issue. All right, now that is cool, we can just simply just come up with the name add initial IDL files for payroll program in JSON and TypeScript format. So I'm going to commit that and synchronize. Now those two are available because when we're going to be interacting with it online, those are the files that will help us to do that. So at this point, you see that update just happened on that repository. I'm going to import that, and then we don't need to add any environment variable because this is the cool thing. Otherwise, I would have needed to add. Now, for DevNet, for the cluster that I'm targeting is the DevNet. So by default, the application is DevNet. But in case I ever deploy this to a mainnet, then I'll have to put in mainnet, cluster here so that it's target. And secondly, we have another environment variable which is called OpenAI key. Okay. And I've designed this application in such a way that if you don't have OpenAI key in the environment variable, remember that instruction that we gave, then it should depend on the one that will be fed, later on. I'm looking for the place. So this active key is coming from this location. So if we don't have a user key, you should check on this. But there's a more. So this is as environment variable, this OpenAI key. This particular use effect tracks and monitors that so that it will update it into our application. So if you just notice that there is no environment variable for OpenAI key, to just set this to be false because this will return either true or false. And if it is true that that it has environment variable, to just go on. But if it doesn't, it would ask you to enter your environment variable as part of the chat session. Then you enter it. When you do enter it, it's going to be stored in this set set user API key. If I look for this, you see that this there's a certain provision for doing that within this chat panel. Come to on API key stuff. If you look at that, there is a certain entry which is an input for you to enter that, and then it will save for you. So that is very important. So because I am not adding that here, it's definitely going to be asking the user to enter it in manually. So you should just be aware of that. And the reason why I'm not adding it here is because if I put it here, now you're going to be using that one key, and it's going to exhaust my OpenAI private key, which is supposed to be useful for test purposes, not for public consumption. You understand that? So I'm going to click deploy now with that stated. Deploy, and just wait for it to complete. So this is build log. Now it's going to take some time to finish up. Okay, we have an issue here. So the issue is with this child. It couldn't find it, there. Let's look at the file on here. Test. This is one of the issues that you must always watch out for when dealing with Vercel and all of this. I think since it is giving these issues about it could not find this library called ASAD. I think I can understand this. I can understand this. This child, this is supposed to be utilizing, this child is actually listed here. Okay, it's actually listed here, but but it's not listed in the main package.json here. And because of that difference, it's only installing these ones. It didn't install that chai. So we need to have chai and mocha. I think this is one way we can try and solve that problem. So we can try and solve that problem there using that way, and maybe also import this package as well, just to make sure we are in the good side, that when this thing is uploaded, it will just work. So let me add this, shift this, push it to the server. So now let's go back, and it's been updated, and let's try and deploy it again. Oops, project name. Let us deploy that again. Already have something like that. Okay, so come back here. Okay, I'm gonna delete this or leave this one. This is the one that we're looking for. Okay, deployment is happening, which is those chai stuff that I brought in. Let's look at the build log. So let's wait for it to complete. So it is completed. It actually succeeded, all because we just added that chai stuff and all of that, and that is good. For us, you can see the application is online. When I click here, it should just simply bring me to this place where I simply just need to click on this wallet, connect with my Phantom wallet. Okay, agree. Secondly, this is what you need to do. You need to make sure that you are on the right cluster with this. Change it from localnet to devnet. Okay, so you are now on the devnet. Make sure you're at, and you can see the way it's saying welcome. You need to enter your OpenAI key. I'm gonna bring in an OpenAI key here. That is what I'm gonna use in trying to chat here. I'm gonna enter my OpenAI key. The good news is that this is this is provided as like a password kind of thing. So you set it, and there you have it. So let's create a new organization, new org named Tesla, and then let's do that and see if it's applying. Okay, and you can see it, since this is devnet, it has more information about how much it's gonna cost me in gas fee, and I'm just gonna confirm that and see. Hey, that succeeded, so if you look at this, click here, it brought you to even the right devnet. You can see that information. This is the wallet address that was charged. This is the account. So this is just an organization that has been created. This is cool on the server for you. So we want to on this org with two, let's say 2 soul, and add this worker. Let's look for, let's get worker 4. We add this worker to the org at 0.5 salary, so as salary. All right, so let's try that. This should execute to instruction, confirm, and then confirm as well. You can see that 2 Solana token funded and 1 worker added here. You can see all those information, and you can literally check their record. This is the worker's detail here, and you can check, his information here. You can check the transaction that took place. This is just very cool here. So yeah, and you can see that instructions to fund Treasury, you get that, and this one's instruction is to add worker. Okay, so I could decide to add another worker. Let's add the 5th worker. Add this worker as well with the same salary, and then pay them out. Let's see if it's going to be able to do those. We confirm this. Now I'm going to wait just a moment and confirm this if that is possible to do the both transaction at once. You can see that we're able to, like, 1 Solana token has been charged here for 2 workers at 1.5, 0.5 Solana token each, so you can confirm that that actually worked successfully, and you'll be able to see the operation. This was the worker that was newly added, and this was a payroll processing signature. So if I go to this place, I should be able to find the workers that were paid. This was paid 0.5. This was also paid 0.5 as well. So all of those things are working. What if I want to withdraw this now? Let's say withdraw the remaining balance from the Tesla org. Let's see that this is natural language. I didn't even need to specify. By just saying remaining balance, you should be able to know how much is remaining. You can see that is what Solana 1 Solana token. This is really cool, fantastic ideas all together. So I'm really happy about this work. This is really cool, just absolutely phenomenal. So I'm gonna just take a very nice screenshot of it. Okay, so that is it, and I'll see you in the next part of this video. Hi there, congratulations on completing this particular build. I hope it was quite interesting for you. To me, it was really refreshing, okay? And you saw the many things that we put together, the whole bringing in Anchor / Rust. We coded the smart contract with Rust and all that. We tested it, using Chai and different kind of assertions. We, brought it into the front end landscape by creating a service that we interact with the blockchain. We deploy it, on local testnet, on local net, and we played around with it. We integrated it with the front end. We brought in the LLM, the OpenAI interactions. We created the MCP tools, which are functions that will be used by the LLM to call on each commands that are related, that requires actions of, smart contract interactions. So we did all that fantastic work so far. So this is knowledge. This is where the AI space, where things are going now today. So if you're doing blockchain, if you're doing anything, and you don't have an AI about it, you probably are getting outdated. So if you're doing anything that's related to tech, make sure you have AI. So, and this MCP is a real deal. So you need to know MCP server, creation, how to use MCP in your application. So I've done this now. This is for JavaScript, Next.js, TypeScript ecosystem. There is also another one. You cannot do this with Node.js. You can do this on Python. I've done it with Python. There is a certain MCP package, fast MCP in Python that I use in creating. I use that almost on the, quite frequent for my own personal use. So and with cloud. All right. So this is a great build so far. So I hope you enjoyed it. I hope it blessed your life. And if it does, please hit that like and subscribe button, hit the notification bell, so that you will not miss out any updates that is being released on this channel. And don't forget to check out our store where we have all premium courses, bootcamps, books, codes, and so many kinds of things that will be available for you. Now, this code base is going to be free. You just need to check out the description section and you find everything that you need, to get the code base of the application. So with that said, I'm Darlington Gospel, and this is DApp Mentors. Thank you for being part of the build today. I'll see you next time.